Very good morning, everyone. We warmly welcome you to the day 2 of the Green Hydrogen Summit 2025. Day 1 was an incredible start with insightful discussions and inspiring talks. Today, we will continue the momentum exploring the world of the green hydrogen. We will now have plenary talks 4 and 5, which will be chaired by Dr. Tata Narsinga Rao from IIT Hyderabad. We are pleased to have him in the session, and I now request him to welcome and introduce the speaker. Over to you, sir.
Dr. Tata Narsinga Rao, former director of ARCI Hyderabad and professor at IIT Hyderabad, has led groundbreaking translational research in nanomaterials, including scalable production of nanosilver, nano TiO2, and petcoke derived carbon for supercapacitors. With over 190 publications, 20 patents, and 16,000 citations, he pioneered domestic lithium iron phosphate production and advanced lithium ion battery technology. His leadership at ARCI drove innovation in hydrogen technologies like high temperature and PEM electrolysis while also supporting COVID 19 mitigation technologies. Honored with awards such as MRSI Medal and Technology Day National Award, his work has significantly enhanced India's energy and materials research landscape. We welcome you, sir.
Yeah, good morning, everyone. So today we have two eminent speakers with us for keynote speech. And I'm delighted and then very happy to introduce the first speaker, who is my long-term friend, colleague, and then presently is director of ARCI. And he took over the torch from me, and then he's running much faster and then efficient than me. So which is what any director, like father, always thinks that the son should do much better. And then that's what happening here. So it's my pleasure to invite Dr. R. Vijay to dais. Welcome, sir. Please sit down. Please, sir, I will introduce you first. Dr. R. Vijay is the Director of International Advanced Research Center for Powder Metallurgy and New Materials. It is known as ARCI. It is DST's autonomous institute. And the institute has got a special mandate, that is translational research. Means all the projects what ARCI holds, they always start with the fundamental research. They have a lot of PhD students and publish in excellent journals and then translate, crossing the valley of death. They go to the other product side and then demonstrate. And then Dr. Vijay, especially his PhD himself is on hydrogen storage materials at IIT Chennai. And then he has continued in metallurgy, energy materials, batteries, a lot of areas. His expertise includes nanomaterials, hydrogen storage, mechanical alloying, and heat resistant transfer technologies. With international fellowships at the University of Stuttgart and UC Santa Barbara, he has contributed significantly to India's advancements in strategic materials and clean energy research. As a recipient of the Engineer of the Year award, his leadership at ARCI supports national goals in materials innovation and especially hydrogen technology. Over to you, Dr. Vijay.
Thank you, sir. And of course, thank you for the organizers for giving me an opportunity to share some of the work what we have been doing at ARCI. But that also puts me under pressure because my guru is the chairman, and then I have to. My teacher. It's kind of my PhD presentation synopsis and other things. So that's also another thing. So kind of a challenge for me. And it's a surprise that he will be chairing the session, right? So it's okay. Yeah. And then looking forward to give you my overview. I'm not going to the fundamental details and then the equations and then other things, but then giving you a flavor of the technologies and then other things what we have been doing at ARCI, specifically related to the hydrogen production. Because as he mentioned that my PhD was on solid state metal hydride based hydrogen storage, and then Professor Muthukumar, myself, and then Anil Kumar, we have done with the same Professor Srinivas Murthy at IIT Madras. Yeah, so let me begin give you, because some of them my chairman also mentioned that the mandate of ARCI is it's a development of high performance materials and processes for the niche market, and demonstration. Not only we don't leave it at a proof of concept level, but then we do it at a prototype or pilot scale, and then that can be validated for the field trials. And then eventually that will help and then make them to transfer the technologies to the companies. And other important vertical is an human resource development. We do take people, students, summer interns, undergrad level, then projects, MTech projects, MSc projects, and then we also take graduate training programs, ARFs, SRFs, and then research associates. So it's a continuous, and then right now in our campus, we have around more than 80 students who are all working, including JRFs, project trainees, and of course, summer interns is around 50, 60 people. Apart from it, we have JRFs and then project trainees put together. So I also request, if there is any, when people who are interested, SRM students can come there to ARCI and then look at it, work with the state-of-the-art, the facilities, and then not only the facilities, but also the technologies. Yeah, so this is the journey of ARCI. It started at 1996 with the 3 divisions, with the powder metallurgy, engineered coatings, and then ceramics, but then over a period of time, and then depends upon the requirements, and then depends upon the technologies needed for the country, then we have horizontally spread, and then started with the laser processing, and then non-oxide ceramics, that's a silicon carbide materials. Then 2004 with the nano mission, and then everything is coming up. Then we have a nano materials, carbon materials, and then fuel cell technologies we have started. Then of course, subsequently sol gel coatings. Then in 2010, we have another 2 centers of excellence started with us. One is on the solar energy materials, and then other is the automotive energy materials, which works on magnets and as well as the batteries, lithium-ion batteries. And then we are the ARCI is the first institute to have a pilot line to make a lithium-ion cells, both cylindrical and then prismatic cells in India. We have at a center at IIT Research Park or center. Then more recently in 2025, we have actually created 2 more centers. One is on the advanced materials and batteries, because we have been, it started with our Dr. Tata Narsingh Rao, and then development of materials, and then it's been taking up in high priority area in terms of the materials and as well as the fabrication technologies for the battery. And then we also received a very prestigious and then big project from ANRF on Maha EV thing, including 5 consortium partners and then 5 industries put together. And then we are setting up a 2 megawatt hour rapid prototyping center under that. And of course, advanced powder metallurgy and then magnets, and then everybody rare earth magnets we have been working on, and then we'll be setting up our equipment is shipped from Japan, and then in a couple of months, we will be setting up a pilot plant to produce NDFEB magnets, near net shaped NDFEB magnets at ARCI. Yeah, so that's what actually our Dr. Tata Narsingh Rao has mentioned, that what ARCS does is we always take it from invention to the innovation, and then but to cross that we need to cross the to reach there, we need to cross that valley of death. And then essentially what ARCI does is we will take enough steps, and then we have a mechanism, and then see that we cross and then reach the pinnacle out on the other side, and so that our materials technologies are commercialized, and that's what we do it. And then over a period of time, when these are the thrust areas, we are looking at an aerospace, power, alternate energy, batteries, oil and gas, textiles, water, all those things. And then the crux is we have transferred around 47 technologies to the industries, and then around 250 solutions we have provided to the industries. So that's a thing, and then all this is possible because we could able to work at a pilot scale. We could able to establish at a pilot scale, and then make prototypes, and then package it into a component, and then demonstrate it. So that's the reason. So it can be easily adaptable by an industry. Yeah. And then looking at what I'm trying to say is, in the fuel cells, one of the things are hydrogen, because they have been using as an hydrogen is an input material, input gas for any fuel cell for the conversion of hydrogen. And let me looking at that's what the journey has started in terms of a PEM fuel cell development. And yesterday is also mentioning Dr. Leele of NCL of the PEM fuel cell development in his keynote lecture, second keynote lecture. And then when we are looking at the things, we are working on all the components, materials, components, and then when we made a single cell, then short stack, full stack, then balance of BOP is another important thing, then system integration, then finally we made a product, and then we made field trial. So this is what the journey it has gone through from our fuel cell development. And other what is of thrust is cost reduction of materials, then components, processes for the fabrication of the BOP or balance of system. So that is what the innovations which have come in, put in by our people in terms of the journey for the development of fuel cells. And that's what we are looking at, the stack system technology components. If you're looking at the substrate, then we have a catalyst, then catalyst loading, then always have a catalyst application, then of course membrane cleaning, then membrane electrode lamination. So all these things, cell assembly, stack assembly, all those things. If you're looking at all the components, if you see the photographs, then the most important thing is, as is mentioned by Dr. Leele, that's a bipolar plate, which is very, very important. And then not only that, the membrane, that is still we have been importing, that the DuPont, but then what we have done is the loading our catalyst on that membrane. That's a technology what we have developed. And then if you're looking at all those stuff, I mean, all the bipolar plates and then and the channels. So the channels for the flow channels for then one side is an hydrogen and then other side is an air. So all that is channels are optimized with the different configurations, various configurations, and then worked out the electrochemical performance of those in those flow fields. It is all been optimized and then it's been done. Then all these, and then other point is, initially we said that started with a graphite thing, but then it is a very thick and then heavy. Then started with a, then moved on to the exfoliated graphite to take a powder and then compacted it into the shape and then size with the formation of the flow channels. But the other thing is we also moved to the metallic bipolar plates, and then that is what we make a very compact fuel cells. If you're looking at the Toyota Mirai, which was demonstrated from the Bombay to Pune by our minister, Honorable Minister Gadkari, and it runs with a compressed hydrogen, but then it is a 20 kilowatt fuel cell, but it looks like a 1.5 feet by 1.5 feet by 1.5 feet. So that's kind of a volume it takes. But then so they could able to reduce that kind of a stack is because of the metallic bipolar plates they have been using it, which is of around 1.5 mm thickness, and it is all flow field. So it also acts as a bipolar, not only a bipolar plate, but also as a in between the annulus is used as a water flow to the cool the fuel cells. So that's what making it very compact. So we have been working on with the company also to form those metallic bipolar plates. And of course, we have also have established a pilot line, and then thanks to the MNRE for funding it completely line to make it up to 20 kilowatt fuel cell. And then this is what is being established. Everything, all the facilities we have established, and then we could able to make stacks. Using that, we make as in 1 kilowatt, 5 kilowatt, 20 kilowatt, of course 3 kilowatt, 10 kilowatt, and then we could able to make 20 kilowatt fuel cell stack with the balance of systems completely. Then this is having made that, then we have demonstrated this our fuel cells with an auto, and also the stationary applications at Nivali lignates, and then BRC, IOCL for the forklift we have demonstrated, and then evaluated those performance. And more recently, I mean, the disaster management system, Tamil Nadu government, and then fuel cell is developed. And then more recently, it is being demonstrated with an Airtel, one of the towers for the supply of supply to one of the Airtel telephone towers at Pune. Because if you're looking at a cell phone tower, it takes around 5 kilowatts or around 4.5 kilowatts of that's the power it takes a cell phone tower. And then we made a 5 kilowatt cell, and then it is being powered using this. Yeah, using this cell phone tower. So this is all at the fuel cells having done it, and then we also thought that why can't we use this fuel cell for then electrochemical formation or electrochemical conversion of any of those, either water or methanol into the hydrogen. And that's what we have been working on for the hydrogen production. I've been talking about one is the methanol conversion, and then other is from the alkaline electrolyzers. So these are the two things what we have been doing at ARCI. I'll be covering this. So of course, everybody knows we have been talking about, so I don't want to do it, because essentially it has got a very good gravimetric density, but then volumetric density is very poor. So until unless you compress it to around 700 bar, or you use a solid state metal hydrides to increase the volumetric energy density. So that is what essentially, and it has to be, one is generated, and then it has to be stored, transported, and then for the point of usage for the conversion into an energy, either into a thermal energy or into an electrical energy. So that's what when you're looking at the hydrogen, I'm covering it in hydrogen production. So hydrogen is again basically from the fossil fuels. It's even now it's all from the natural gas methane reforming. It's being produced hydrogen, and that's why the cost is very low. And then other is coal gasification is another one is used, but it's again CO with H2. That's what we call it as a producer gas in any urea plant. That's one of the precursors for producing urea. So you produce CO and H2 using the coal, and then these are all I mean again using going back to the fossil fuels. So and then we can also looking at different things, carry. I mean everybody is discussing about yesterday and all those things, brown, gray, blue, and then but the significance is now everybody has to looking at as a green hydrogen, and uh, and that's what we have been working on. How do we do that green hydrogen production? And of course, what do you do that, what is green hydrogen? Everybody knows. I don't want to do that thing. And when you are looking at more important point is the cost. When you are looking at yesterday, we said that gray hydrogen is around 160 to 200 rupees a kg. And the green hydrogen is 350 to 450. So that's what we're talking about. We are slightly reduced. And then the latest bids, IOCL tender is coming as a 397 rupees. So that's what the companies have quoted to establish and then supply the cost. And when you are looking at the cost of an electrolyzer, if you're looking at it comes as an alkaline electrolyzer I'm talking about, it comes around 65,000 to 1 lakh per kilowatt. So that's a kind of a heavy capex. So 1 kilowatt produces around 0.1 or zero 0.2 meter cube per hour. So that's very, very less. And then the generally duration is around 4,000 hours. So that's what it has to work without any degradation. And also it has to be tolerant to the normal tap water. I don't need to fully purified deionized water or anything. So it has to work with the normal tap water with less impurities. So what we are looking at a target as a government or a hydrogen mission, what we fixed is around to bring the cost to 100 to 150 rupees a kg. So that's what the target, and then we have to work towards it. Then this is what, when you are looking at, the last pillar on the other side, in the left side of the photograph, I mean in the graph, when you say that last pillar, so if you take it that as 100% and then you normalize, you could see that the growth, how much of the renewables, the hydrogen production using renewable is increasing. So drastically, if you're looking at in 1 year, 23 and then to 24, so almost around 30% increase it is there. So that's a very happy, good sign to use renewable energy and then produce the hydrogen. So much technologies are coming up, so much industries. We have seen yesterday also 2 companies, they wanted to set up the hydrogen generation plant. Then we are also looking at kind of an electrolyzers in India installed capacity to 5.2 gigawatt. That's kind of a capacity electrolyzers are introduced. So it's very significant from 1.4 to 5.4 gigawatt. That's a kind of a capacity it has gone up. And of course, we can always say that either you generate fossil fuels or the nuclear energy. That's what another point yesterday we are also hearing from Dr. Malhotra. We heard that no, another option is you generate energy, electricity from the nuclear reactors and then power it in an electrolyzer and then produce hydrogen, or you use a renewable energy. That's what I've been talking about for the green hydrogen. And then if you're looking at what is the status on the electrolyzed state of the development, alkaline electrolyzers are developed and then it's being deployed, commercially deployed, and then everyone, what are the hydrogen is being produced is used by the alkaline electrolyzers only. And then PEM electrolysis is a research and product development, and then field trials are going on, but not many PEM fuel electrolyzers are being deployed for the commercial hydrogen production. And another one is solid state electrolysis or solid oxide fuel cells electrolyzers. So that's still at the research level. And when you say that between electrolyzers, we have a different things, alkaline, PEM, and then SOEC, and then anion exchange membrane things. Then you have all the components of the electrolyte, cathode, anode, then operating temperature, operating pressure, then stack lifetime, and then technology readiness level. So this is what we have been talking about. And then if you're looking at So if you're looking at alkaline electrolyzers, comes up to be around $500 to $1,400 per kilowatt. So that's kind of the cost is going to come. So that's going to be cheaper than other processes. So what does it mean in the global manufacturers and then performance data? When you're looking at, there are around 33 medium to large scale manufacturers available around the world for making alkaline electrolyzers. And then there are largest installed reference is 24 megawatts or the 100 megawatts. What they have done is in one single electrolyzer. So these are all the companies, major manufacturers, alkaline water electrolyzers. Then so many countries are there. But I want to see that coming in couple of years, India should be figuring in that. L&T is working, one of the company. Reliance is also working on seriously to develop these electrolyzers. So maybe a couple of years we could see that the Indian is figuring in this, Indian companies figuring in this sector. Yeah, so of course this is a busy slide, and then I don't want to dwell on that, because basically key performance indicators for then each and every processes, then 2020, and then we are looking at a 2050. So we are all pushing it a little higher, and then in terms of the voltage, operating temperatures, all those things, and then it's a continuous incremental innovation also is taking place on the alkaline electrolyzers and then other things. So what exactly is to do is, you need to have a favorable anodic reaction and then reduced energy consumption for the nitrogen production. Right now, we know alkaline electrolyzer takes around 55 units to produce 1 kg of hydrogen. So that's a very, very huge amount. When you're looking at, 5 rupees or 10 rupees a unit, if you take a commercial power line, so you are paying around, what ARCI pays around 12 rupees per unit to an electricity board. So if you compare that, it comes to around, only the power cost comes to around 600 rupees a kg. So that's not, if with that the things, I cannot sell hydrogen, or no one, in the other words, and then no one will be able to buy that hydrogen, I am producing the technology. So we have looking at all those things. And then other point is, the other big challenge in electrolyzer is the membrane to separate and then hydrogen and then oxygen. So more new technology is coming up, which is a membrane-less electrolyzer. So which a startup from the Bangalore, which is all Neo Green, and then they are working on a porous electrode or the porous metallic material, a plate, and then which a very tortuous pore specifically designed so that that filtrates the hydrogen and then oxygen, separates out. So that's what, you don't use anything. But then thing is that the challenge to produce a more porous metallic piece with a designed tortuous path. So that's also another big challenge. People are working on it. And then other is what we want to say is at ARCI we have done as an electrochemical methanol. We could able to make it and then generate, build a system, a stack. We could able to produce around 5 kilograms of hydrogen in a 5 or 6 hours. So that means 1 kg per hour hydrogen. And what is the advantage of that is, it takes only 17 units compared to the 55 units of an alkaline electrolyzer. So the energy consumption is very, very low. And obviously the cost also comes down because the energy is done. And then other is because it's a stationary application, you don't have to go with a fancy material like a metallic bipolar plates or anything. You can live with graphite bipolar plates, and then cheaper. You don't need to use even the exfoliated graphite. Normal graphite bipolar plates, you can use it. It may be bulky and other things, but then it's a stationary application, so you can reduce the cost. Even the capex also can be reduced. And then other thing is, it's also is very easy and then quick startup and then shutdown mechanism. You can also power it and then start generating, and then whenever you want, you can shut down. And we have demonstrated this. We have been working on and then making, trying to operate at this level and then understand the all BOP and then everything. Now it is all done, and it's in the final stages of the technology transfer. So we have been already in consultation with the company. It's a final stages of the technology transfer. That's what it's a status. And then other thing is the beauty is we also said that it can also work with an ethanol. Right now, what we are done with a methanol, but it can also work with an ethanol. And then you all know that our right now the petrol is blended with 20% of ethanol, and most of that ethanol is made from that bio waste because of the bio waste materials. It's also being done. And last year, when you're looking at, it's around 1.9 billion liters of ethanol is being produced and then blended with petrol. And then most of the they're also using it as a some of the spoiled food grains like rice and then corn, which are stored in the NEPCA. So that is being used as a raw material for producing ethanol, and then that is being blended. So once you start with and then also research is also going on in the generation 2 ethanol generation. I mean ethanol production. That is all being done with that's all being done with uh, with all the bio waste, instead of burning those agriculture waste and all, converting that into ethanol, and then that can be used as to produce hydrogen. Uh, and other thing is we have also done the same, that ethanol reformer connected to our solar plant, and then that is also is demonstrated. So another point I'll quickly cover, that alkaline electrolyzers, because you can say that what we have been done, and on one hand we have been saying that alkaline electrolyzers are commercialized, so what is a novelty in it? So but what is done, we have done is generally conventionally alkaline electrolyzers, of course, they use all the nickel electrodes, and then with the nickel porous, nickel alloys porous coating is also given on the nickel plate. And that's why the cost is very, very high. So what we have done, we compared, you can see that the nickel cost is around 1339 rupees, and then platinum is loaded on that is around 3750 rupees a gram, and that's a very expensive. So if you look at the stainless steel, it's only 220 rupees a kg. So what we have done, so that motivated us, can we do something, why can't we replace nickel and then use the stainless steel? But the biggest challenge is the whole alkaline electrolyzer works with a 6 molar KOH solution, and then it's a very, very highly corrosive environment. So our material has to withstand to that kind of a corrosion environment. So what our people have done is, they have actually given a coating, looking at electrodes and then bipolar plates. What they have done is they have given a coating. You could always see that the left one is a plate, stainless steel plate, and then they just given a coating with the dip coating process, and that they have converted, they have oxidized the surface. It's kind of a spinel structure, FeCrO4 structure. That is actually prevented the corrosion of your iron and then chromium on the stainless steel material when exposed to the KOH. And then but luckily what happened is FeCr4 is acting as an electrocatalyst to produce, instead of platinum loading. So the oxidized products itself are acting as a electrocatalyst, and that's why they could able to do that. And then if you could see that, say if you see that the onset potential is also a little lower as compared to the nickel, but then the current, which is all quoted 115.6 milliamps per centimeter square. So even nickel is 15.4. So that's all in the comparable in terms of the current density what we can deploy on an electrode. And also linear sweep voltammetry, even the durability is also found to be good compared to that. So what we have done is, instead with the stainless steel modified, we made a single cell electrolyzer, and then we have tested all those things. And then this coating technology oxidation, which is already patented by us, and then it is also the patent is granted in 2024. And based on that, we have done, but the membrane which has to be is always, I mean, it's imported, but all the electrodes and then bipolar plates with stainless steel coated stainless steels were used, and then we have designed. So this is what then from the single cell to the 4 cell electrolyzer with all those components, It's all designed by us and then made by us, and then it's all integrated, integrated 4-cell stack, and then it's produced. And then we also at the same time, the same BOP, we worked on the BOP required for it. Essentially, how do we separate out the oxygen and then hydrogen coming out from the KOH solution? How do we separate out and finally take out this hydrogen things? And then we can see that gas liquid separators also designed by us. And we could able to see that, and the left one is an hydrogen collected on the flame, and you can see that it's running, it's filling in the balloons. This is all with the 4-cell stack, and then other is the same with an oxygen balloon. You could see that the flame is increasing, so you could able to separately collect hydrogen and then oxygen with the same thing. Then we could able to design built one 1 kilowatt alkaline electrolyzer, but because of those PTFE plates at the end, you could able to see that they are all bulged. So because of the pressure buildup and all, the PTFE is not able to withstand. So we have to use a metallic thing. So that's why we have gone back from the old stack to the new stack design. Everything is modeled and then designed, and then this is also being fabricated, and then in a week's time, and this with the metallic, the new designs, and then with the metallic end plates will be designed and then demonstrated at our place. And then other thing is we are also I'm working with an industry, and then that industry is already supplying that BOP and all. We are working jointly, collaborative thing, and then eventually demonstrate, and then I'll close it, coming to an end. And that's what we have been doing it. And then other thing what we are doing is the PEM electrolyzer we have purchased commercially as an 1 meter cube per hour. So 5 kilowatt is the PEM electrolyzer we have purchased, because we do want to benchmark our systems with the commercially available ones, and then connect to our solar grid, and then use the produce hydrogen. And we have other plants also. You could see that that's a big system. Sorry. This is a big system on the right side. That's a 5 kilowatt commercially PEM electrolyzer. It has got totally the BOP which is there. So essentially that BOP, how small you can do it, how compact you can do it with the system. And then when you produce hydrogen, what we are looking at it is also use that hydrogen, convert that into methanol or any other organic compound. And we have also designed that reactor, and then reactor is being fabricated. And so we connect with the solar PV, and then so PEM electrolyzer, and to this reactor, and then so that the CO2 can be converted. And then and then this is being done, demonstrated to other many industries. They say either it can be a power plant or it can be a cement industry and all. So where it can be a captive system. So with a solar plant, then you have a PEM electrolyzer or alkaline electrolyzer, produce hydrogen, and then convert that CO2 into an organic compound. So that's what in this direction we have been working on. So in summary, so this is what we have done, and then we have done that electrochemical methanol reforming we have done at 1 kg per hour, and then almost the technology will be transferred in a month's time. Then alkaline electrolyzer we have done with dispensed with the nickel electrolytes, nickel electrodes or bipolar plates, and then with the cheaper stainless steel plates with an corrosion resistance coating, thereby reducing the capex of an alkaline electrolyzer. And that's what we have been working. This also we have been working with the company to have a captive small ones. It's not kind of a big megawatt or anything, kind of a 10 kilowatt electrolyzer, so that can be onboard hydrogen generation can be used. And this is all possible with all my scientist people, and then also an academic institute collaborations with an industry, academic institutions, and also my scientists. And that's what I believe. Together we win. And we are also open for the collaborations to take up the work further and to make this green hydrogen a reality. Thank you very much. Yeah.
Great. Thank you, Vijay. And I could see it's just 1 year plus he took over. Then a lot of progress is made in last 1 year, only in this field itself. I know other fields also. Congratulations.
Thank
And
you.
then now let us open the lecture for discussion. And we'll start with our boss, Narendra Garu.
Dr. Vijay, at the outset, congratulations for the excellent work that's being carried out at ARCI in the area of hydrogen production and different types, also fuel cells. Now, I have a comment and a question. It's very exciting to note all the participants that ARCA has developed alkaline electrolyzer. Now, leading industries are looking to alkaline electrolyzers. For instance, AM Green has ordered for pressurized alkaline electrolyzer with a capacity of 1.3 gigawatts.
Yeah.
Now, the challenge here is you mentioned that it takes about 50.5 kilowatt hours of electrical energy to produce 1 kilogram of hydrogen. What are the challenges and what are the efforts to bring it down to, let us say, about 40 kilowatt hours? Because that is the constraint for the usage of green hydrogen in industrial and other applications. The second part of the question is it's also very heartening and excited that ARCI has developed fuel cell. Now, how do we benchmark that fuel cell with the internationally available fuel cells? For instance, fuel cell of Ballard.
Mm-hmm.
Yeah. Reason is Ballard functions as well as volume, because volume of the fuel cell, as you know, is a constraint in mobility sector, in cars as well as hydrogen powered trains. So kindly uh, throw some light on these points so that the participants could understand and enjoy.
Yeah. So coming back to your first question, the alkaline electrolyzers, then energy consumption is 55 units per kg. And how do we do that is there is because why that is coming is you have to apply such kind of an over potential than for the splitting of water. You are going to 2.2 volts or even 2.3 volts. That's what you have to go, and that's a reason. And then at the same time, the kinetics for the production of the splitting of water. So the catalyst things. And people are working on, even though platinum is loaded, so that's the best catalyst everybody knows. But the other aspect you are looking at is like a chalcogenides or MOS2 or WS2 or cadmium sulfides. People are looking at as an electrocatalyst, or even the photocatalyst also people are talking about improving the kinetics. So once we load that, obviously for a given power input, and then if you are able to enhance the production capacity, then obviously my power consumption comes down. So in this direction, people are working over here. And then one of that good breakthrough, what we could able to see is that this is a serendipity, I can call it, because we are only looking at an corrosion resistance coating, and then we thought that we will coat again a catalyst and all. But here is the oxides which are being produced on the surface, like an FeCrO4 kind of stuff, that are actually acting as a catalyst. It's kind of a double effect. So thereby could able to increase the kinetics and then produce the hydrogen at cheaper rate, so that the power comes down. So that's a one point coming to the electrolyzer. Then other thing is in the PEM electrolyzer, and we are not targeting about right now until unless if it is for a transport application. Right now our fuel cells are little bulky and then voluminous compared to the imported things, and then basically we are using as a graphite, even though they are little lower compared to the graphite things, because we are using an exfoliated graphite where they could able to make it thinner pieces and then lighter bipolar plates over there. But for the transport applications, especially for the mobility, people are using as a metallic bipolar plates. And that's what I was telling you. The Toyota Mirai uses a metallic bipolar plates. It's a very, very compact, sitting at around 40 kilowatts of a PEM fuel cell. gives you around 750 kilometers range with a hydrogen filled in the cylinder. So so that is what has to be needed for when you want to go for a electric mobility. We are also working on those metallic bipolar plates. But for as far as an hydrogen generation is concerned, we are targeting PEM electrolyzers for the stationary applications, where weight and volume is not a very binding factor, but the how much energy, how much efficiently it can generate. And we could able to see that our methanol electrochemical reformer could able to take only 17 kilowatts, 17 units per generation of 1 kg of hydrogen. And that's what we are always looking at. And then that is benchmarked with other electrolyzers. Yeah.
Thanks for the excellent clarification.
Yes,
I have
yes.
seen the fuel cells developed in this country. The constraint is the volume.
Yeah, exactly.
And
We do
also,
understand.
yeah, mobility sector
Yeah.
is getting accelerated in this country. So the institutions and laboratories perhaps
Yeah.
need to put efforts
Right.
to reduce the volume of the fuel cells,
Yeah.
benchmarking with the international products available.
Yeah.
I'm sure some of our faculty members will be happy to collaborate with the ARCI
Yeah,
in some
definitely.
of these things
Yeah.
to solicit your kind support for that.
Yeah. Right.
Thank you.
Thank you. Thanks.
Excellent inputs, and
Yeah.
thank you very much for
you.
answering. I can give one more question chance. So you go ahead. Yeah,
What is the membrane used in alkaline electrolysis?
membrane.
The durability.
Membrane, it's a commercial membrane. I do not have an idea. I'll get back to you. Because it's not, we are not being made and then it's being purchased.
Yeah, that's a
That's
Sustanian
also a
membrane and
challenge. Yeah.
Sustanian membrane and Fumatech
Yeah.
or something
Mhm.
like that.
I think so.
What about the durability? Like,
Durability is good. It's well established. It's the same membrane which is being used as in a commercial electrolyzer. The same material is being.
how many hours or something?
We have tested it because the material is already proven at a commercial level. The same membrane which is being used right now.
See, the membranes
it-
for alkaline
it's-
alkalies is
it's-
not a problem.
Not a problem.
If it is anion exchange membranes,
anion
that-
exchange.
but this is alkaline
Alkaline
electrolysis. This is not
electrolysis.
anion exchange membrane.
Analysis, that's
What you are thinking is probably because that has issues.
that has
Yeah,
issues.
Yeah,
That's
but
what,
this is not very
we
simple.
don't have issues.
Okay, still one more chance for the young people. If someone wants in the back side, back half, you want someone to ask question? No? Hey, young people, you should come with more questions. Thank you, anybody. If no more questions, let us move forward, and let me just give him a big hand
Thank you.
for the young director.
Yeah, thank you. Thank you very much. Yeah.
Thank you very much for the insightful session, sir. We now request the session chair, Dr. Tata Narsingh Rao from IIT Hyderabad, to felicitate Dr. R. Vijay, Director, ARCI.
Okay, we'll move on to the next one. The next speaker is Dr. Ramesh K. Guduru. Sir, please come. Please sit for a while I read your, so that people will keep your image in the brain. Yeah. So, you'll be talking about sustainable technologies. Dr. Ramesh K. Guduru is founder and CEO of Green Excel Technologies Private Limited India, and is inventor of a green hydrogen technology, commercialization ongoing TRL9 level already, inventor of seawater based electrolyzer technology, because yesterday I was talking to my panel discussion that the need of the hour is to how you electrolyze seawater, because you need plenty of clean water, the present electrolysis, and seawater electrolysis need of the hour, where you need to work on electrolytes, membranes, and the electrodes, selective electrodes for OER and HER. So he already did it. I hope you'll show some of the results looking forward. Developed India's first direct air capture pilot plant at TRL 8 level, and developed and commercialized environmental friendly and anti-corrosive cutting fluid for aviation and auto industries. Is co-founder of a lithium-ion battery technology startup in the USA, and recipient of Larry Narwood Faculty Fellow Presidential Faculty Fellow, USA, National Research Council Fellow, USA, selected for a renowned 100 Talent Program, China, Overseas Research Student Award, UK. 18 plus years of working experience in the US. He has 22 plus years of R&D and 6 years plus years of industry experience. And served as NSF, SBIR, Small Business Innovation Research Grant, STTR, USA, SNSF, Switzerland, QNRF, Qatar, and Skolovo Foundation, Russia. A well-recognized scientist, academician, entrepreneur. He has patents, 6 granted, 4 pending international, and 3 startups, and funding of 3.8 million US dollars and more. Thank you very much, Dr. Ramesh Garu, for giving your consent to give this lecture. And the now stage is yours. You will have 30 minutes time, and 2 minutes before I'll give an indication. Thank you.
Okay. Yeah, anything is fine. Yeah, just give it to me. I'll hold it. Thank So, thank you, Dr. Tatagar, for the nice introduction. And I would like to uh, extend my thanks to Dr. Path Sarthi and the SRM team, Dr. Rao Garu, the Executive Director for R&D, I guess, and then Mr. Satyanarayanan of I think, Pro Vice Chancellor or Pro Chancellor of SRM. I appreciate for inviting over here. I'm giving me this opportunity to talk about the work we do. And as Dr. Tata said, I would be talking about some of the technical stuff. Due to the confidentiality nature, some of them are not being discussed. But I'll give you the brief glimpse of what we have done. And mostly I'll be talking about what are the future prospects and all. So the thing is that I moved back to India in 2019, 2020. And then we started to work on a couple of these technologies. One of them was using the seawater, how we could generate hydrogen directly without even having to go through demineralization or even purification process. But we had to do some physical separation of the solid particles and other stuff though. It's a big challenge because of the corrosive nature. There are so many contaminants you have in there. And then the other part of our research was on carbon capture, where we got the funding from Shell Energy India. And then we developed the technology, kind of demonstrated it, and we happened to show it even Mr. Mukesh Ambani ji also. So now what I'll do is, where should I, this one, is it right? Is it working? But it's not going. Okay, okay. Please go back. Yeah, back. So, yeah, please go ahead. So I'll be just showing a clip that talks about
Introducing Green XL.
company though.
Revolutionizing green hydrogen technology. In a world striving for cleaner, more sustainable energy solutions, emerges Green XL, the game changer in green hydrogen technology. Say goodbye to the limitations of hydrogen production technologies using fossil fuels and electricity, where hydrogen gas storage, transportation, and massive infrastructure are mandatory for the delivery of hydrogen to the customers under high-pressure conditions. Unlike these methods, Green XL doesn't require any power and operates at atmospheric pressure, making it safer and more efficient to the customer delivery. Picture a future where power isn't just renewable, it's self-sustaining. Green XL is revolutionizing the way we harness hydrogen energy. Built on circular economy principles, Green XL transforms waste materials into clean and reliable hydrogen energy with on-site and on-demand production capabilities. Imagine harnessing the power of the sea. Green XL's technology thrives on seawater, making it a coastal paradise's energy hub. In addition, Green Excel's technology is extended to harnessing the power of the industrial effluent as well, especially textile industry wastewater and brackish water from RO plants. Green Excel's technology thrives on developing groundbreaking and unique technologies for hydrogen and energy generation. Our innovative business model is inspired by battery swapping and vending machines and ensures easy and cost-effective delivery of hydrogen to customers and various applications. At the heart of Green Excel is Dr.
just stop.
Gujaru, a visionary scientist and
Yeah, you can
inventor
just
of this
stop.
ground.
So we'll just skip through that. Okay, so the overview of that video was basically to say that, okay, we are working on utilizing the waste materials per se. Seawater is also kind of close to being waste only. In addition to that, we also use industry waste. And what we do is we kind of tune the technology as per the customer requirement to suitable to the industries. And mostly, I'm actually from Gujarat. I mean, the company is set up in Gujarat. And we work closely with the industries located in the west coast of the seabelt, okay, whatever you see there, like Bharuch, Surat. Those are the regions where you have lots of petrochemical industries. So they have lots of influence. So we work with them closely, how to tune the process for them. And in addition to that, the seawater is one thing which we worked out, and we were able to not only produce hydrogen, we could also generate electricity. Cogeneration we do. That is something which we are targeting to use for automobile applications. When we introduced that to some of the investors, they said, you're a little ahead. Okay, you please put a full stop there and come back to the industries, rather help the industries instead of going for automotive, because in industry, automotive technologies are yet to evolve on the hydrogen side. And right now, they use gas cylinder for storage of hydrogen, then use a fuel cell to run the vehicle with electric power. So with that, I would say we have the avenue of developing multiple technologies from our end. At the same time, since some of them are patented, some of them are still in the pending process, they got filed, few of them. So that's the reason why I won't be able to discuss in detail. Another thing is, one of our technology is already getting commercialized. We are setting up a plant with a capacity of hydrogen production 3.5 tons per day in Bachau. And the investor, who is it's a company which is a listed company in India, and they have the exports going abroad also. So their eventual plan is to set up at least 6 plants throughout India, and to reach a target of around 20 to 22,000 of 22 tons of hydrogen. Sorry, 22,000 tons of hydrogen production per year. That's the target they're looking for. So since we have signed an NDA and confidentiality agreement, that's the reason I won't be able to unfortunately discuss. But if you have any specific questions, how we showed in the video, like using the textile industry waste or even other effluents that come out of the industries, how we utilize them and how we convert that into hydrogen. Even I can give you a simple glimpse on the textile industry waste, which usually comes with the dye. So what we do is we try to, using certain catalysts, chemical approaches, we separate the dye, and then we use the water as it is. That produces hydrogen. By the time the hydrogen production is completely done, the dye gets totally settled down and separated. The water is out. So it's a waste for industry, and getting rid of that waste is a big challenge for many industries in, I think, Coimbatore or Panipat or even Surat regions. So in a way, we are trying to help the companies to utilize their own effluent for production of hydrogen. With that, the other challenge that usually the companies face is how much effluent they're producing. Is it really sufficient enough to scale the technology so that they could use their own hydrogen? Well, there we were looking into the concept of using hydrogen hub. What would happen is, if you have maybe, let's say, 6 to 7 industries nearby, you set up a hub of hydrogen so that it would produce hydrogen and supply to all the companies which would be needing hydrogen for their combustion applications or whatever it is. Now, fortunately, the price of the hydrogen is around 160 to 180 rupees in that range, which competes very well with the gray hydrogen. And we don't really use any fossil fuels here. So that's how, even if you look at the complete carbon management, it turns out to be a green hydrogen with the CO2 emissions less than 1.5 kg of CO2 per kg of hydrogen production. On top, I'm actually a certified carbon management leader also. So we do the carbon management even for industries, like auditing their carbon management, how much emissions they're producing, because that's going to become a mandate in the near future. Indian government is also kind of pushing it forward now. So when we have the companies in India which are planning to export the products to European Union or even may not be the US but other nations, they will be imposing the mandate saying that, okay, this is the level of emission you need to have. If it is below that, then only we will purchase it from you. Otherwise, we are not going to import it from you. So when those mandates come into picture, obviously every industry in India or even other countries also, they have to push themselves down in terms of emitting the CO2. Okay. So now I'll just go through the current status and why the hydrogen has become suddenly a matter of importance. And hydrogen has been there for a long time. Alkaline electrolysis is there for more than 50 years now. Alkaline electrolysis is an established technology. Why it has become an important matter of concern at this point? Because we have the emissions coming out globally, which are supposedly calling the global warming, and you know all very well. So I don't want to go into the details because of the increased temperature. And in fact, in the recent past, India itself, we must have seen. I remember like 1920 or somewhere, we had some issues in Chennai or even Bombay and few. Even Delhi has a very serious issue in terms of the pollution. So it's better we avoid some of these fossil fuel based or conventional fuels so that we could move on to clean technologies where the future is going to be brighter with the green. So, and when it comes to the depletion of the fossil fuels, I really don't know whether we could call it or not. But you know, the Middle East, GCC nations have certain issues with the amount, the supplies. But US has another the supplies sufficient enough for another 235 years or so. Recently, even in the news, the Indian Central Energy Minister, he said we were about to hit something in the Andaman Island, somewhere nearby. If that really clicks out, India would rather become a 20 trillion economy or so. With that itself, sufficient enough to bring to uplift Indian's economy. So I don't really think there is any scarcity or there is depletion, but due to geopolitical issues, the prices are coming out to be quite challenging to afford for. So it's better to avoid, because when you're economically growing as a nation, it's, these geopolitical things should not impact or hamper your growth. So better reduce our reliance on other nations which are providing us the fossil fuels. And when it comes to the renewable energies also, at one point solar used to cost quite high compared to the conventional electricity also. Right now it's around, without distribution cost, I think 2.65 rupees per unit. So it looks quite lucrative for utilizing the solar farms to produce hydrogen. But are we still there to compete with the gray hydrogen? I really doubt, because even if you take 2.65 rupees per unit, 2.5 rupees per say, even if you take, to produce 1 kg of hydrogen in the best case scenario, 40 units you need. 39 is the best case, 40. L&T demonstrated, I think, around 48 or so. The technology that comes from Germany or even France, they're at the level of 48, 47. And our seawater electrolysis is in the range of around 41, 42. We are very close. We are very fortunate in that, because we are not going with the conventional approaches of, going with the standard electrodes and using no. The problem with conventional thinking is you just take existing one, try to improvise it. You have to be thinking quite opposite direction. If everyone is going this way, I better rather go in the opposite direction. That's when we should be able to think radically and go with new technologies. So we use the membrane that comes from Belgium only, but apart from that, rest all in-house made. Okay. So probably the solar should be able to work with our technology if we want to. And when it comes to applications, hydrogen has tremendous applications. I mean, pharmaceuticals, steel, or anywhere you name it, I don't see an end for that. So excuse me. So now why it is good? So I don't want to go into the details. It's calorifically very high, at least 2 to 2.5 times more than the conventional fuel that we've been using, including petrol or diesel or even other LPG and all. So the only challenge is the volumetric thing. It would need more space. So if you want to store 1 kg hydrogen at atmospheric pressure, you need 11.2 normal meter cube. Okay, that's the space. But the thing that people have been proposing to use is 700 bar. Even Toyota Mirai uses a gas cylinder with 700 bar pressure, which carries 5.6 kg of hydrogen and runs up to 1300 kilometers, 1325 or so, with 5.6 kg. On an average, you could say 1 kg hydrogen gives you 200 kilometers or so, somewhere in that range. So, but the issue is, if you're going with 700 bar pressure in your car, if there is an accident, then it can't be imagined, you know. Even right now, the CNG vehicles are also coming up, and they're there in Delhi and Gujarat area, but now in Hyderabad and Telangana, Andhra, it's coming up. Even there also, they're quite hazardous in nature. We can't really rely on them so easily. I mean, it's established technology, I understand. Accident is a very dangerous thing there because the gas is stored at 200 bar pressure, CNG. If there is an accident, then no one can save you. It's very dangerous situation. So how people in the European Union are envisioning that why not we go to or make a shift to hydrogen economy or ecosystem and maybe utilize the conventional approaches like fossil fuel based. Apart from that, maybe some nuclear, renewable, because renewables are not really sufficient enough to produce enough hydrogen due to their nature, intermittent nature. But if you go with the combination of all those and supply the power to the grid and produce hydrogen, which in turn can come into the economy, providing the support to different segments of the industry like transportation, which is likely the end one or maybe upcoming one. But the rest are all there, synthetic fuels or upgrading of the oils or even fertilizers. Those are kind of established ones. People have been already using. It's there in industries. Even perfume industries also use hydrogen because of they need to do the hydrogenation. They have to ensure the product quality is good without oxidation. So, which is being envisioned as like hydrogen itself. Once it exceeds the requirement, it comes back and produce power. Again, support the grid. This is already demonstrated also partly, I would say, when it comes to the power generation by South Korea. They have set up a couple of power plants. In 2020, 21, they commissioned them and they showed the working huge power plants. So it's eventually going to lead to decarbonization of the environment. I don't want to go into these details. There are so many techniques. Some of them are sustainable, some of them are not. When I say sustainable, you can basically run it in a cyclic fashion without having any depletion issues. So green hydrogen is again kind of thing where you want to use the power source which doesn't cause much of emissions so that you can call it green hydrogen. Nothing more than that, okay? But of course, we had to still think about the solar cells. When their life ends, again, they had to come back. Their LCF has to be looked into. But what are the challenges, even if you want to introduce this technology? First of all, it's cost prohibitive. As I was telling, the best case scenario, even if you go with 40 units of electricity consumption to produce 1 kg hydrogen, per unit 2.5 rupees. If you take 100 rupees there itself cost, okay? And the cost of electricity in the production of hydrogen accounts for somewhere close to 50 to 53% or 55%. So that is a major component. And water would be costing around 5 to 7% also. And the rest capex, the rest you would see. So when the electricity itself is costing you 200 plus rupees, obviously the production cost is going to be somewhere close to 250 to 270 rupees. So that's the best case scenario. Even if at this point, if you want to use solar, the cost of solar power has to be somewhere around 90 paise to 1 rupee. then we can bring the price down to 160 to 180 rupees. Otherwise, not possible. But people are working on, high voltage power supply so that they could cut down the distribution costs and all. And so, but apart from that, if you see how to distribute, I mean, what is the supply chain and what are the challenges in terms of pumping the hydrogen into the customer base. So you have the issues with the materials, the efficiency. Even if you currently we use the gas cylinders, maybe 7 meter cube or 10 meter cubes gas cylinders, which hardly carry what 0.65 kgs or something of hydrogen. So the refueling is going to be a challenge. Every time you have to fill in and you have to keep on waiting. So the industries don't work out in that way. The cost and so, and maintenance, the purity is another challenge. Depending on the industry, they need different purities. If you go to pharmaceutical or food one, they need 999 purity easily. And you don't want to have any mercury or anything. That is something you have to look into. Our chloroalkali plants produce some of mercury vapors, which are not really suitable. If you're going with any other catalysts, probably they're good, but ensure we should not have any mercury vapors or any other vapors. Even at the ppm level, they can't be used in the industries. And leakage is a big challenge. When you're flowing the hydrogen at high flow rates, leakage would really cause, right now, even if you have hydrogen outside, it would be basically having a flame, which is not really visible to us. Okay, so that's a big challenge again. So increasing energy efficiency, these are all the fundamental challenges which have been already kind of going through in terms of the discussion. Even yesterday also we had some discussions. Today also in the first talk we had that. So if you compare these technologies, PM, AEM, AEM is the upcoming one. It is still in the lab scale only. But PM is really established and known for very high purities. And mostly it is monopolized in few nations just because of the membrane and the catalyst part. They're not available in every nation. And alkaline is the maybe 50 years old technology. And that membrane, again, still we don't have in India. It comes from, I mean, the one which we use comes from Belgium. I think zircon membrane is the one. So, but still, alkaline itself is going to be costing 3 to 4. And bio, there is one startup company in Bangalore, and they're working in collaboration with ONGC. In fact, we are also invited to work with ONGC while utilizing their stuff. So they claim that their hydrogen is going to be coming around $1.52, but the only challenge with bio approaches is scalability and the rate of production. Kinetics is always a challenge with bio approaches. That's a debatable one. With our approach, since we are using all the raw materials which are waste in nature, are not so useful in nature. I don't want to call it waste because we are using it now. I would rather say not so useful in nature for them. So it's a relatively low capex, opex also. Our price is in the range of 2 to 2.5 kgs. With that, we are trying. The other advantage that we have is we also get another byproduct which has its own economic and commercial value that makes all the whole process more commercially viable. Okay. Now, when it comes to applications, see, because most of the time when you talk about electrolysis, you just focus only on producing hydrogen. You don't think about anything else apart from that. That really kills the viability of the process. We had to always keep the eyes open in other directions also, so that somehow the technology could be brought into commercial scale. So when it comes to the applications part, petroleum refining or ammonia production and methanol, which are already established, they have been using quite heavily. Automobiles is the one which is going to be upcoming. Now, most of these technologies, when they are getting into the market, they start from the large scale, like for example, industries utilizing the hydrogen directly. It doesn't go from bottom to the top. Usually, I think it goes from the top to the bottom. By the time it comes to the customers, at the customer level, even at the households, if you want to use it, that's going to take some time. Probably customer may, at the customer level means mostly automobiles are the ones at the personal level. And so for energy applications, either heating, cooling, because there were a few questions I was asked yesterday, what are the applications of hydrogen industry? No, it's a kind of established one. People have been using quite heavily. In the energy, power supply is a new one though, cooling or even process heating instead of LNG, LPG, and other gases, hydrogen can be used, which is going to be 2.5 times more efficient. In industries, green steel, or even the processing thing, one could see. And finally, the mobility is the thing which is going to come into picture. Those are the future prospects. That's what I'll be kind of focusing more on this talk also. This is something that was demonstrated in India in Ashok Leyland, and Reliance in collaboration together showed the truck which is ICE based, internal combustion engine based. The efficiency of these engines is hardly 24 to 28% or so. Cummins is working. Cummins is the US company which is in Pune also. I think they have reached to a level of 40 to 45% also efficiency. But when it comes to the fuel cell side, their efficiency is around 54 to 57, in that range, close to 60, the best case scenario. So Toyota has demonstrated some of these trucks using the hydrogen for their applications. So this is where I was telling just moments ago, we are also targeting one certain technology. We have been able to demonstrate it at the lab level, where you go with some sort of modular components, and where you have to replenish the the raw materials for the modular components with water and a couple of the materials also. So what will happen? That produces hydrogen along with electricity, and both of them can be used together. I mean, hydrogen doesn't go directly though; it goes through the fuel cell, and once it converts into electricity, you can use both of them to run the vehicle. And of course, India is also now coming up. So Germany is the one which demonstrated the running of trains by hydrogen. The thing is that setting up hydrogen train is going to be quite expensive, but OPEX is very low if you're using gray. So they were able to run the train up to 6,600 miles or so with a single filling. And if you look at Toyota Mercedes sort of vehicles, this is what our initial target we began with. And when we kind of half the way presented it to Shell, they said, no, you're coming in competition with our own business. You better put it aside. So, I mean, literally they said, you stop it, otherwise we will not fund you. So we had to move it aside and keep it in a different direction using it, because the one which basically, instead of the gas cylinder and the fuel cell in combination, you need it though. Gas cylinder would be weighing around 20 to 30 kgs, even if you use in the automotive vehicles. Our setup is going to be weigh somewhere close to 70 kgs, 60 to 70 kgs. Still, it is going to produce enough hydrogen to run the vehicle up to 400 kilometers or so. 400, based on the amount of hydrogen that is produced, okay? 400 to 430 kilometers. So in these vehicles, you see the gas cylinder, fuel cell, and a battery would also be there. So for the ancillary operations there, even to start the engine. So, and these are some demonstration though people have shown. MF Hydra is a yacht which was developed in, I think it was basically Norway company, I guess. Yeah. So they demonstrated. India is also going to be showing this train by September or so. That's what yesterday said. And okay, let's see now the aviation side. These are upcoming applications. Boeing or even Airbus, they are trying to somehow slowly move away from the fossil fuels to see the viability of using hydrogen in the aviation industry. I'm sure you must have seen the recent accident in Ahmedabad, where the power outage, not the power outage, yeah, it was actually due to power outage. The power outage took place because of the fuel cutoff, supply cutoff that was done, whatever the situation was. But if you go with the hydrogen sort of thing, ensuring with minimal pressures, not very high pressures, still in the aeroplanes you use high oxygen cylinders, we use with high, slightly at higher pressures. Maybe even at that level, if one could think of using hydrogen and utilizing it for running the engines, that should really suffice to to fly the vehicles in the in the aviation industry. But then we had to see, can we use electrolyzer itself as it is, or it's better to go for storage? These are the two challenges. The technology that we are developing is highly applicable for ships because you have the seawater readily available. You just take it. You don't need to carry. You take it and then utilize it and dump it if you don't want to. Okay. So unfortunately, our technology would have a long way to think about using it in the airplane. So, and these are portable gensets developed by Israeli companies, and which are already into the commercial use, but on a limited scale. I don't want to go into the details. This is the one which I was telling, power plants. Globally, how people have been showing the applications of hydrogen. Uh, South Korea has set up this plant in 2022, which covers around 250,000 households. Now, during the power generation in the fuel cells, you also generate heat, which is being now being utilized by the households around up to 40,000 plus or so. So these are the avenues where we could also think of jumping into. But I understand the cost of hydrogen is the biggest challenge. But if with the introduction of the hydrogen that we are producing, the green one, with low cost, probably we should be able to become supplier for some of these applications, if we can think of setting up these. So they all need innovations in the fuel cell side. Now, see, we start with industrial scale applications. Rocket fuels, it's already there, established one. Then it goes to the households, probably to the customer level. So what sort of demand we have in India? It's actually huge, humongous. I would say India is not going to have enough supply of its own, even if we start to produce it ourselves. And when they did the survey, India wants to become an exporting nation, but we are the rapidly growing economy, so we have a huge demand for that. Now, right now it is a gray, and POX are the ones which are in high demand. But if you see the green hydrogen and its contribution in the future, probably by 2050 it's going to be in the range of around 90%. It's going to contribute. So that's the target of the government, and we need the technologies that would really provide support to that. But I could see the bright side of this is maybe instead of solely focusing only on developing electrolyzers and other technologies, we should rather think about circular economy more. That's going to be a better option as of now, I could say, because we also produce so much of waste. I see industries produce like a few, not MLP, BLP, billions of liters per day. And the processing of that effluent costs around 4.5 to 5 rupees per liter. And they want to get rid of it with zero discharge. So those are the avenues which we are literally venturing. Yeah, please. No, I'm almost done. So these are the targets. I really doubt whether we could reach if we are going only with electrolysis. I'm sorry to say this, but it's talked about very long, but the ground reality is it's a myth. It's not going to happen unless $1 becomes 200 rupees by then, okay? So I would not agree, and I would totally disagree with this point, okay? So it's good. I mean, having an ambition is always good, but whether we reach there or not, it's a different thing. Right, I mean, it's better to introduce this hydrogen thing in the old plants or even existing. Retrofitting is the best option to go with. Then we can think of going for exports. Even ammonia is being talked a lot about for utilization in the industries, or even as a carrying agent for hydrogen. I really don't know how well it is really, I mean, it's going to happen, because for making ammonia is going to be energy consuming process. For breaking also, it's an expensive, energy intensive process. But I am totally surprised. People just get carried away saying that, oh, ammonia can really take care of all this transportation. No, I really doubt. I mean, that is the ground reality, but people may not like it. But the ground reality is the fact, okay? So what are the opportunities India has? India is a beautiful country in a way. It has all the resources. You have 7,600 kilometers of coastal belt. So you can imagine how we could, exploit the seawater for production of hydrogen. But when I say seawater, most of the time people think about using, desalination process. No, we should not think conventionally. Why not we use it directly? Let something happen in between. That's totally fine. But is there any way that we can use it? Even if something goes bad, I would rather go with low capex one. I would rather replace my setup and go with a newer setup. So that's why the one which we are commissioning right now, the capacity of one reactor is close to 450 to 500 kgs of hydrogen per day. The cost of it is just the reactor itself around 1.8 crores or so. But then if you add interlocks, valves, uh, rupture discs and other things, safety features, it would come to 3 to 3.5 crores. When I talked to the South Korean company which supplies alkaline electrolyzer, the cheapest one was 5 crores, 5 to 5.5 crores. It comes as a skid and for producing 100 kgs of hydrogen also per day, okay? So the rest, I don't want to go I don't want to go into detail, but I can see there are lots of opportunities, how it's going to come out, and even where do we stand historically, what was the thing, and where are we heading. We are quite behind as per the targets though. And the GCC nations are really trying to become exporting nations. GCC means Qatar, Dubai, UAE, and Saudi Arabia and all. So if you see, this is how the future situation is going to be. Probably India, US, China are going to be self-sufficient. Importing nations are going to be this. So there are opportunities even for us not only utilizing hydrogen within India, probably exporting it to other nations. Okay. So what do we need to do? We have to have right incentives, as the CM, Mr. Chandrababu Garu said, those are very attractive, very lucrative incentives for the companies to come down. So I sent a message to our investor yesterday itself, as soon as I saw that, okay, there is an avenue, why don't we, because Hyderabad, we are planning to set up a plant so that we could supply the hydrogen to all the pharmaceutical hubs there. But in addition to that, if you could think of having one somewhere close to Nellore or somewhere down the line, close to the border of Chennai, where you have, again, lots of industries over there, automobile industries, the manufacturing industries, which really dump waste into, I see the canals. I mean, just before going to Chennai, it smells so bad. So that could rather be taken care also. So these are the things, I mean, maintenance cost of fuel cells, investment is needed, technologies are needed, and viability is the one which is required. So is it a hype or hope? That is something you could judge by yourself depending on the technologies available and also how we are progressing, okay? And thank you very much. Thank you for your attention. Yeah, please, thank you. Yeah.
Thank you, Ramesh Garu. It's a wonderful talk and then a lot of insights. So before I go to audience, then it's open, seawater electrolysis, or you said even textile waste water.
Yes.
And while I was introducing, I was telling that there are a lot of challenges associated with seawater electrolysis. And maybe you have an innovation and then IP, but you may not.
Yes, that's unfortunately, because as a businessman, I can't do. Academician, as a researcher, I can do.
But you can give a little clue.
Sure.
Because a lot of young people are there, and then.
Certainly.
So, is it the electrolyte part? Is it the electrode part or membrane part, which is playing a key role in making it successful?
Okay, good. No, thank you for that question. So, when it comes to the textile waste, we don't use electrolysis. We use simple chemical plus electrochemical approach using catalyst part, where we try to split the water using some galvanic coupling of the materials, okay? And when it comes to the electrolysis, we use the conventional, I mean, not exactly stainless steel, we use a different composition there. Materials, mostly nickel based and all. And we haven't even done the complete designing, that the channeling thing we haven't even done. We did only with the plain ones. Yes, we use catalysts which are more of soluble in nature rather than coated ones.
Okay.
Because coated ones are solid in, it's a solid
surface. It's a kind of a sacrificial catalyst or something?
No, we use consumable, recyclable. Okay. But the thing is that as soon as you go to the solid route, you're limited with the surface area. That's a big challenge. We should always think about the kinetics part. If you go with something that's already existing in the liquid, you have plenty of room. I mean, plenty of surface area available.
Okay, so anyway, at least there is a nice hope that the industry is coming and telling that seawater electrolysis is possible. So that's wonderful. So now it's open to audience for any questions, please.
Yeah, Mr. Ramesh, Dr. Ramesh,
Yeah.
I'm Robbie here.
Yeah, please.
It's very interesting, Ramesh, and because I'm representing industry.
Okay.
I'm not from academia,
Okay.
so I always look for a solution which are when you said about below $2, kg of hydrogen you can really supply.
Close to 2.
Exactly.
I don't want to
So
below.
it's very, very, very much interesting for us. And then touched upon a lot of pain points which really we had today. And you touched about water scarcity. You touched about how my sewage going to down. And then see when we really count the cost of money we spend on sewage
Getting rid
treating
of
and
the
using it back.
effluent,
And
yeah.
if you add this, and probably it would be a great proportionate. And then again, probably one more thing, a big dream people had like me, we had, have a fuel station inside the sea. I'm talking about energy station, not a fuel station, which have their offshore energy.
Offshore.
And then offshore, solar, and then storage of hydrogen, where you are probably seawater conversion can always will be a great help. So this all, what you really, what you shown us, it's touched a lot of pain points of an industry. Okay. Now, coming back to one of your innovation, or probably you said you'll be commissioning in Gujarat about
Yes, it's
waste to
going on
hydrogen.
right now.
Waste to hydrogen. I have a couple of questions. Probably I'll be taking a little longer time than anyone else here. And what is the route you are going through? Is that a
What is
gaseous?
that?
What is the route you are going through? Is that a gaseous route or anything else? Converting waste into hydrogen.
It's a liquid. Liquid we are starting with, it turns into gas. And I mean, the investing company, they have their own plant over there.
No,
I mean-
gaseous means it is like typically converted and then.
No, we are, it's not being, no liquefaction of hydrogen, nothing. That's
No, I'm talking about the waste, how we are treating, how waste is
The
converted.
waste
it's
is
a
liquid waste, right?
liquid
It's
waste.
a liquid
It's a liquid
waste.
waste
Yeah.
only.
Liquid waste.
Liquid waste, yeah.
And then it will be converted. And what
Yes,
is the
exactly.
other components we get it? Carbon or what it is that way?
No, we get,
It's slowly.
No, I'm a
yeah, we get,
businessman.
we get some byproducts which could be utilized in the, once purify that, they could be used in the chemical industries as chemicals mostly.
Another chemical.
Yeah.
Wonderful.
And I, as a businessman, you know it.
Definitely. For us, we are not even ready to venture into becoming another manufacturer, but again, we wanted that solution so that I
Yeah.
can invest money and then take my money.
Absolutely. Because, excuse me, the extent of investment the company has put right now is 124 crores or so for setting up the plant there. So we have that confidentiality, and I can't even share the details because right now we are connected to even ONGC, GMR is one of the things which we are working with. I had meetings with Unilever and all few other companies, but everyone has their own. We just keep it separate.
Okay, we'll make fast forward.
Yeah, please, go
Any
ahead.
quick question? One more.
That's all, sir. Thank you
th-
so much,
thank you
Mr.
so
Ramesh.
much.
We'll be in touch with you again.
Yeah, let's
But
please. Let's
these
please.
questions are very useful for the audience as well. Any one more question anyone wants? Yep.
Dissolved solids for the seawater electrolysis. You're saying catalyst is a
Yeah,
dissolved
kind
catalyst.
of dissolved salts which are recyclable.
No, but how does it?
Because once the hydrogen production is over,
Yeah.
the water gets dissolved, you can recycle it. You can bring it
You have
back.
to buy the technology license.
No, no, no.
No,
see-
that's the difference between
see,
academician and a
30 minutes
See,
is
businessman.
not-
see, no, no,
Extract.
redox flow batteries we can do just flowing it.
Yeah,
but,
anyway, you both can discuss during. But some of the points what you touched are very interesting. First, let me ask you very quick, rapid fire. Fuel cell versus combustion.
Mm.
So, how I also get confused. Combustion gives 30%, here it gives 50%, but you use noble metals and all. So, what is the best way, in your sense?
See, I see is the problem is when it sucks air out of the atmosphere, okay? The problem is you have other gases on top. Once the oxygen goes and reacts with hydrogen, it produces vapor. That itself is going to consume some more energy. And in addition to that, you have the energy is going to other gases as well. So probably that is the one which is kind of bringing it down. But the right extent of pumping hydrogen gas and providing only oxygen, that would rather improve the efficiency, not the air. Because right now we have whatever the technologies they use air directly from the front end, okay, of the vehicles. Yeah.
So, still at the moment, fuel cell is the.
Fuel cell is the best, but the problem with fuel cells is they are monopolized only in few nations. The way.
And the last one, you also touched upon ammonia as a carrier, and I also agree. I also have the same Because in mind, you always make ammonia from nitrogen and hydrogen, where hydrogen is produced, and then use the ammonia again to crack it.
You
and
use
all.
Bosch
So,
process,
yeah,
you go to
yeah, Haber
475
process.
degree
So,
centigrade.
so
Haber process, not Bosch.
I think someone has to answer this question.
Yeah, because
it's fine.
even cracking is also not a low temperature process. As soon as you say energy, you're killing the process. That's a very
Anyway,
first enemy.
there is a lot of scope for discussion for people. These questions are just posed to you. Thank you so much, sir.
Sure, thank you very much. And
So don't go.
thank you very much.
We need to
Sure.
fill.
Thank you very much, sir, for that in-depth and solution-oriented talk. We now request Dr. Tata Narsingh Rao, sir, to felicitate Dr. Ramesh Guduru. We thank the session chair and the speakers for their truly inspiring and innovative insights. As we let those ideas percolate, it's time to take a short tea break, a perfect moment to recharge, reflect, and connect. We will reconvene for the next session in 15 minutes.
Stunning 100-acre campus, surrounded by cutting-edge facilities and a vibrant community that will inspire you to reach new heights. Imagine diving into a world of innovation guided by brilliant faculty who are passionate about your success. Our forward-thinking curriculum, aligned with the National Education Policy, will challenge you to explore, create, and excel across disciplines. Life at SRM University AP isn't all about hitting the books. Get ready for an exhilarating student experience. From pulse-pounding national events like Aloha, Infinitus, Udgam, to the cultural extravaganza of Paridan, every day promises a new adventure. Explore, engage, and excel in our centers of excellence, where research isn't just conducted, it's lived. And when the day's done, find solace in hostels that are more than stay. They're sanctuaries of comfort and camaraderie. With over 30 clubs, ignite your interests and make lifelong connections. And with our team of CRNCS, step confidently into a career that's not just a job, but a calling. SRM University AP is not just where you study, it's where you soar. Join us, and let's embark on this extraordinary journey together.
SRM University AP has built a magnificent infrastructure that caters to enhancing student experience on campus. Our academic and administrative blocks are designed for diverse fields of study. The X Lab and JC Bose blocks house the research and entrepreneurial hubs, where groundbreaking research and startups thrive. At SRM AP, each block stands as a monument to our unwavering dedication to excellence. Our athletic facilities, including top-notch track, cricket pitch, and a synthetic tennis court, ensure holistic development. The university is home to 6 fully furnished hostels with modern amenities. It also offers nutritious and hygienic mess facilities and multi-cuisine food joints. From cutting-edge laboratories to interactive digitally enabled smart classrooms, multi-storied hostels for both boys and girls to beautifully landscaped grounds, each block serves as a sanctuary for academic, research, innovative, and athletic excellence. Welcome to SRM University AP, your gateway to a glorious tomorrow.
Nestled in the heart of Andhra Pradesh's capital, SRM University AP is a multidisciplinary research intrinsic university. Backed by a 60-year-old legacy that is transforming the face of education, technology and innovation, SRM AP stands as a pioneer in educational excellence. Spread across 100 acres and designed by the American architectural firm Perkins & Will, this new age university believes in being globally connected, regionally transformative, and nationally relevant. Established in 2017, this tertiary educational institution is home to over 9,000 students from across India and 38+ countries across the globe. SRM University AP, known for its forward-thinking curricula, interactive learning methodologies, and industry-oriented programs, help nurture students not just as scholars, but also as visionary leaders and change-makers. With 19 departments across diverse disciplines, we don't just educate, we redefine learning. The 3 schools, School of Engineering and Sciences, the Pari School of Business and the Iswari School of Liberal Arts, are carving excellence in their respective domains. SRM AP School of Engineering and Sciences, SEAS, is one of the most sought-after schools, on par with the country's top engineering institutes. In a landmark collaboration with Carnegie Mellon University, SRM AP has established an AI institute, marking a bold step towards global leadership in intelligent technologies and future-ready research. Pari School of Business, SRM AP's management precinct, is known for its global collaborations, innovative pedagogy, and entrepreneurial mindset. The Ishwari School of Liberal Arts, SRM AP's Liberal Arts School, is synonymous with progressive thought and an interdisciplinary approach. With a spectrum of world-class resources in terms of research, academic, sports and extracurriculars, SRM AP has become a center for holistic education. The university also has a dynamic team of faculty, a full-fledged entrepreneurial ecosystem and global partnerships, making it an institution of repute. The varsity's strategic direction is guided by top leaders and educationists from the University of California, New York University, University of South Florida, and McGill University, Canada, to name a few.
I would love to see SRM is counted among the top 10 universities of India, and I would love to see it as the #1 private university in India. I think we are making good progress, and hopefully we'll achieve that.
SRM AP will be is it will be a strong and contributing component of this region's economy. And I don't just mean financial economy, I mean intellectual economy and entrepreneurial economy. And SRM AP will be a major contributor to that. But I know the leadership here has ambitions far beyond that SRM AP will become a major contributor to India, and indeed a major contributor, a major contributor to the world. And I have every confidence that those ambitions will be achieved.
SRM AP in large part because of its commitment to become a comprehensive liberal arts as well as interdisciplinary university. And I have been, very pleased to see that it's continued to honor that commitment in the way in which it's been building and growing.
The university's students have also made a mark in the sporting world, with Olympians, Paralympians, and other international athletes representing India on a global platform. SRM AP proves that it not only believes in pure academic excellence but promotes holistic growth as well. Our alumni network is second to none. With graduates placed in Fortune 500 companies and some of the top-ranking universities of the world, SRM AP graduates leave an indelible mark, carrying the legacy of the SRM brand across countries and continents. At SRM AP, every milestone is a leap to a vibrant tomorrow.
Welcome to SRM University AP, where innovation meets excellence. Nestled in a beautifully designed campus by the renowned Perkins & Will, SRM AP stands as a beacon of advanced learning and holistic development. At SRM AP, learning transcends the traditional. It's an interactive experience, a blend of global perspectives and cultural diversity. Here, research isn't just important, it's a way of life, pushing the boundaries of innovation and discovery. The state-of-the-art labs, smart classrooms where theory transforms into groundbreaking reality. Here, you're not just studying, you're pioneering the future. Our immersive international programs catapult you across the globe. The heart of SRM AP beats in its library, a sanctuary where information breathes life into ideas. With an extensive collection of resources, it stands as a beacon for academic and research excellence. The cafeterias, thoughtfully positioned throughout the academic grounds, offers a whole bunch of options to keep you going. At SRM University AP, we nurture more than just your intellect.
Step into a world where brilliance thrives and potential soars. Welcome to SRM University AP. Picture yourself on our stunning 100-acre campus, surrounded by cutting-edge facilities and a vibrant community that will inspire you to reach new heights. Imagine diving into a world of innovation, guided by brilliant faculty who are passionate about your success. Our forward-thinking curriculum, aligned with the National Education Policy, will challenge you to explore, create, and excel across disciplines. Life at SRM University AP isn't all about hitting the books. Get ready for an exhilarating student experience. From pulse-pounding national events like Aloha, Infinitus, Udgam, to the cultural extravaganza of Paridan, every day promises a new adventure. Explore, engage, and excel in our centers of excellence, where research isn't just conducted, it's lived. And when the day's done, find solace in hostels that are more than stay. They're sanctuaries of comfort and camaraderie. With over 30 clubs, ignite your interests and make lifelong connections. And with our team of CR&CS, step confidently into a career that's not just a job, but a calling. SRM University AP is not just where you study, it's where you soar.
SRM University AP has built a magnificent infrastructure that caters to enhancing student experience on campus. Our academic and administrative blocks are designed for diverse fields of study. The X Lab and JC Bose blocks house the research and entrepreneurial hubs, where groundbreaking research and startups thrive. At SRM AP, each block stands as a monument to our unwavering dedication to excellence. Our athletic facilities, including top-notch track, cricket pitch, and a synthetic tennis court, ensure holistic development. The university is home to 6 fully furnished hostels with modern amenities. It also offers nutritious and hygienic mess facilities and multi-cuisine food joints. From cutting-edge laboratories to interactive digitally enabled smart classrooms, multi-storied hostels for both boys and girls to beautifully landscaped grounds, each block serves as a sanctuary for academic, research, innovative, and athletic excellence. Welcome to SRM University AP, your gateway to a glorious tomorrow.
Step into a world where brilliance thrives and potential soars. Welcome to SRM University AP. Picture yourself on our stunning 100-acre campus, surrounded by cutting-edge facilities and a vibrant community that will inspire you to reach new heights. Imagine diving into a world of innovation guided by brilliant faculty who are passionate about your success. Our forward-thinking curriculum, aligned with the National Education Policy, will challenge you to explore, create, and excel across disciplines. Life at SRM University AP isn't all about hitting the books. Get ready for an exhilarating student experience. From pulse-pounding national events like Aloha, Infinitus, Udgam, to the cultural extravaganza of Paridan, every day promises a new adventure. Explore, engage, and excel in our centers of excellence, where research isn't just conducted, it's lived. And when the day's done, find solace in hostels that are more than stay. They're sanctuaries of comfort and camaraderie. With over 30 clubs, ignite your interests and make lifelong connections. And with our team of CRNCS, step confidently into a career that's not just a job, but a calling. SRM University AP is not just where you study, it's where you soar. Join us, and let's embark on this extraordinary journey together.
SRM University AP has built a magnificent infrastructure that caters to enhancing student experience on campus. Our academic and administrative blocks are designed for diverse fields of study. The X Lab and JC Bose blocks house the research and entrepreneurial hubs, where groundbreaking research and startups thrive. At SRM AP, each block stands as a monument to our unwavering dedication to excellence. Our athletic facilities, including top-notch track, cricket pitch, and a synthetic tennis court, ensure holistic development. The university is home to 6 fully furnished hostels with modern amenities. It also offers nutritious and hygienic mess facilities and multi-cuisine food joints. From cutting-edge laboratories to interactive digitally enabled smart classrooms, multi-storied hostels for both boys and girls to beautifully landscaped grounds, each block serves as a sanctuary for academic, research, innovative, and athletic excellence. Welcome to SRM University AP, your gateway to a glorious tomorrow.
Nestled in the heart of Andhra Pradesh's capital, SRM University AP is a multidisciplinary research intrinsic university. Backed by a 60-year-old legacy that is transforming the face of education, technology and innovation, SRM AP stands as a pioneer in educational excellence. Spread across 100 acres and designed by the American architectural firm Perkins & Will, this new age university believes in being globally connected, regionally transformative and nationally relevant. Established in 2017, this tertiary educational institution is home to over 9,000 students from across India and 38+ countries across the globe. SRM University AP, known for its forward-thinking curricula, interactive learning methodologies, and industry-oriented programs, help nurture students not just as scholars, but also as visionary leaders and change-makers. With 19 departments across diverse disciplines, we don't just educate, we redefine learning. The 3 schools, School of Engineering and Sciences, the Pari School of Business and the Iswari School of Liberal Arts are carving excellence in their respective domains. SRM AP School of Engineering and Sciences, SEAS, is one of the most sought-after schools, on par with the country's top engineering institutes. In a landmark collaboration with Carnegie Mellon University, SRM AP has established an AI institute, marking a bold step towards global leadership in intelligent technologies and future-ready research. Pari School of Business, SRM AP's management precinct, is known for its global collaborations, innovative pedagogy, and entrepreneurial mindset. The Ishwari School of Liberal Arts, SRM AP's Liberal Arts School, is synonymous with progressive thought and an interdisciplinary approach. With a spectrum of world-class resources in terms of research, academic, sports and extracurriculars, SRM AP has become a center for holistic education. The university also has a dynamic team of faculty, a full-fledged entrepreneurial ecosystem and global partnerships, making it an institution of repute. The varsity's strategic direction is guided by top leaders and educationists from the University of California, New York University, University of South Florida, and McGill University, Canada, to name a few.
I would love to see SRM is counted among the top 10 universities of India. And, I would love to see it as the #1 private university in India. I think we are making good progress and hopefully we'll achieve that.
SRM AP will be is it will be a strong and contributing component of this region's economy. And I don't just mean financial economy, I mean intellectual economy and entrepreneurial economy. And SRM AP will be a major contributor to that. But I know the leadership here has ambitions far beyond that, that SRM AP will become a major contributor to India and indeed a major contributor, excuse me, a major contributor to the world. And I have every confidence that those ambitions will be achieved.
SRM AP, in large part because of its commitment to become a comprehensive liberal arts as well as interdisciplinary university. And I have been, very pleased to see that it's continued to honor that commitment in the way in which it's been building and growing.
The university's students have also made a mark in the sporting world, with Olympians, Paralympians, and other international athletes representing India on a global platform. SRM AP proves that it not only believes in pure academic excellence but promotes holistic growth as well. Our alumni network is second to none. With graduates placed in Fortune 500 companies and some of the top-ranking universities of the world, SRM AP graduates leave an indelible mark, carrying the legacy of the SRM brand across countries and continents. At SRM AP, every milestone is a leap to a vibrant tomorrow.
Welcome to SRM University AP, where innovation meets excellence. Nestled in a beautifully designed campus by the renowned Perkins and Will, SRM AP stands as a beacon of advanced learning and holistic development. At SRM AP, learning transcends the traditional. It's an interactive experience, a blend of global perspectives and cultural diversity. Here, research isn't just important, it's a way of life, pushing the boundaries of innovation and discovery. The state-of-the-art labs, smart classrooms where theory transforms into groundbreaking reality. Here, you're not just studying, you're pioneering the future. Our immersive international programs catapult you across the globe. The heart of SRM AP beats in its library, a sanctuary where information breathes life into ideas. With an extensive collection of resources, it stands as a beacon for academic and research excellence. The cafeterias, thoughtfully positioned throughout the academic grounds, offers a whole bunch of options to keep you going. At SRM University AP, we nurture more than just your intellect.
Step into a world where brilliance thrives and potential soars. Welcome to SRM University AP. Picture yourself on our stunning 100-acre campus, surrounded by cutting-edge facilities and a vibrant community that will inspire you to reach new heights. Imagine diving into a world of innovation guided by brilliant faculty who are passionate about your success. Our forward-thinking curriculum, aligned with the National Education Policy, will challenge you to explore, create, and excel across disciplines. Life at SRM University AP isn't all about hitting the books. Get ready for an exhilarating student experience. From pulse-pounding national events like Aloha, Infinitus, Udgam, to the cultural extravaganza of Paridan, every day promises a new adventure. Explore, engage, and excel in our centers of excellence, where research isn't just conducted, it's lived. And when the day's done, find solace in hostels that are more than stay. They're sanctuaries of comfort and camaraderie. With over 30 clubs, ignite your interests and make lifelong connections. And with our team of CR&CS, step confidently into a career that's not just a job, but a calling. SRM University AP is not just where you study, it's where you soar.
SRM University AP has built a magnificent infrastructure that caters to enhancing student experience on campus. Our academic and administrative blocks are designed for diverse fields of study. The X Lab and JC Bose blocks house the research and entrepreneurial hubs, where groundbreaking research and startups thrive. At SRM AP, each block stands as a monument to our unwavering dedication to excellence.
Welcome back. Hope you had a refreshing break and are geared up for the next exciting sessions ahead. We move on to the Conclave 3, and I invite Mr. Ranjan Nair from BPCL to moderate the session.
Mr. Ranjan Nair, Business Head for Renewable Energy at BPCL, a trailblazer steering India's energy shift. He has driven innovations like India's first LPG vending machine and digital platforms like Bisfit and HSSC Portal. He has led nationwide operations, managing large scale distribution networks, and implementing safety and automation standards. Currently, he is leading BPCL's renewable energy strategy, aligning with India's energy transition goals. We request Mr. Ranjan Nair to welcome the panelists and provide a brief introduction.
Very good morning to one and all. Thanks to the organizers for inviting me as the moderator for this wonderful panel of great researchers and who are making advances in clean hydrogen. The topic of today is technologies for clean hydrogen, advances and challenges. May I call upon the panelists without, because they're running behind schedule, I'm told. So our first panelist is Dr. Ramesh Guduru. You just heard from him, the plenary talk. I'll reintroduce him to you. Dr. Guduru is founder and CEO of Green Excel Technologies Private Limited, a Apart from being a researcher, he is now into industry. He is inventor of green hydrogen technology, seawater-based electrolyzer, India's first direct air capture plant. He is recipient of many awards, starting with Larry Norwood Faculty Fellow, President Faculty Fellow, and many more. He has 18 plus years of working experience in USA and 6 plus years in 22 plus years in R&D and 6 plus years in industry. So may I please welcome Dr. Ramesh Goduru onto stage, please. Second on the panel is another gentleman working in the industry level for green hydrogen, Mr. Harish Jairam. Mr. Harish Jairam is Vice President, Business Development at Hygenco Green Energies, a global developer of green hydrogen, ammonia, and biofuel solutions. A clean energy transition leader, he brings extensive experience in scaling commercially viable projects across hard-to-abate sectors. With a strong background in renewable energy storage and operations across India and global markets, he has led major initiatives at Sun Edison and Suryadesh Energy. Mr. Jairam holds an MBA in Finance and MS in Industrial Engineering. Welcome, Mr. Jairam. So, before we get into the third panel, may I congratulate you, Mr. Jairam, for the third plant you have put up. Yeah, we'll discuss more about that during the conversation. Next panelist is Professor Sridevi Upadhyayula. She's a class of 66 chair professor in the Department of Chemical Engineering at IIT Delhi. With rich industry and academic experience, her research focuses on environmentally benign heterogeneous catalysis, biofuel production, and catalytic processes for petrochemicals and biomass conversion. She holds PhD from IIT Kharagpur and has previously worked as a postdoctoral fellow at the University of Notre Dame, USA. Welcome, Professor Sridevi Upadhyayula. Next on the panel is Dr. Mallikarjun Bhavanari. Dr. Bhavanari is an assistant professor in electronics and communication engineering at Manipal University with expertise in renewable energy, electrochemical devices, and nanostructures. His research focuses on electrocatalysts, electrolyzers, and thin film technologies for clean energy applications. With hands-on experience from premier institutions like ARCI, CSI, CSIR, NCU, etc., he is committed to advancing zero carbon impact solution through collaborative research. Welcome, Dr. Bhavanari. Last not but the least, Dr. Parthapratim Bagh is our next panelist. Dr. Parthapratim Bagh is an assistant professor in the Department of Chemistry at SRM University, Sikkim. With prior teaching experience in Dumka Engineering College, he is a fellow of Indian Chemical Society and life member of the Material Resource Society of India. He also serves as the editorial board of the American Journal of Applied Chemistry. Welcome, Dr. Bagh. So we have 5 panelists, and I shall be moderating this session. Frankly speaking, I'm a little nervous because I have been never with so many professors after I graduated. So all these gentlemen, except for a couple of them, were industry guys. So that gives some comfort. So I'll take the chair, and then from there we'll proceed. Hello. Yeah. So before we get into the discussion, a couple of things to set the context. challenges we have been hearing since morning, and yesterday also you might have heard about challenges with respect to implementing green hydrogen. One, uh, as an off-taker, BPCL also has developed a green hydrogen station at Kochi. I would request anybody sitting here who turns out, who plans to visit Kochi, welcome to, it's just outside the airport. You can go and see a 500 megawatt indigenous electrolyzer, 500 kilowatt indigenous electrolyzer built with bark technology, alkaline electrolyzer, with another 500 kilowatt electrolyzer, which is not indigenous, but you can actually see the entire plant, the electrolyzer plant and the dispensing station. Another project which we've done is the 5 megawatt electrolyzer at Bina refinery. We have also floated a tender for 5,000 tons of green hydrogen on BOO basis. So that tender might get opened on Monday, this Monday itself. Like we have got the rates for IOC as well as Indian Oil as well as HPC, which is around, I think, 10 rupees difference, 387, 397 we have got. So we also hope that similar rates would come. So why I said this was, today we produce refineries because we are seen as an off-taker. The primary question would be that if off-taker is sitting there, you should just buy hydrogen. The problem is the hydrogen today, what we produce, gray hydrogen, is using LNG or naphtha, which through SMR process, it costs us only 150 rupees. So the price discovery which has happened is around 400 rupees. So a straight 250 rupees, which we cannot pass it on to petrol or diesel because that has to remain affordable for the customers. So we have to absorb that. So that 250 rupees multiplied by whatever tons we buy, like IOC is going to buy 10,000 tons. So that 250 crores is going to hit the bottom line. So that's the one challenge. Otherwise, if a mandate comes and if there are schemes wherein this price difference can be absorbed, the refineries will be a reality as far as green hydrogen is concerned. So that's one. Second is our team visited South Korea recently, where they saw 70% PLI is given on production, 70% on the infra, the capex. So they are not worried about the green part. They are doing gray hydrogen. So the entire economy is gray hydrogen economy. So they are, it's like CNG here in India. Every 10 minutes they fill a vehicle. So they want to build around 1 lakh vehicles of gray hydrogen. So that's another perspective. So I thought these two things, and then we'll take it forward. One more thing. Recently, in a roundtable conference with which I joined with Padma Bhushan Dr. Anil Kakutkaji, he mentioned that we require around 28,000 terawatt hours of energy if we want to become Viksit. Like we will have a lifestyle of any developed nation. So if 28,000 terawatt hours of energy is required, renewable will add up to only around max of 8,000, 9,000 terawatt hours. What do we do with the remaining? So hydrogen along with nuclear is the future. So with these, may I go to my first panelist, Dr. Guduru. And you have to pardon me if I ask you anything which you may find here. So I have never moderated a session. I have always been a panel member. So this is slightly difficult for me. Anyway, so yeah. So Dr. Guduru, how can nanomaterials and surface engineering innovations, which presentation also talked about and your profile talks about, improve the performance and durability of hydrogen production? Because these are two challenges. I'm not getting into the challenge part because we all know most of the challenges. So how can nanomaterials and surface engineering innovations help?
Thank you. So to begin with, I was actually a nanomaterials person. We used to synthesize lots of nanomaterials and, test them out for different applications. Then, when I jumped into the ground, the basic grounds in the industries, there's a huge gap. It's not an easy task to utilize nanomaterials directly into the industry applications, maybe except the cosmetics, like, titanium oxide sort of thing, maybe in the absorption, like, the emission catalyst and all. But so when it comes to utilizing these nanomaterials and their surface engineering part for hydrogen, see, whatever you think of increasing the surface area, functionality groups, surface functional groups and all, you could add. But at the end, beating platinum or overtaking platinum is not so easy, because that has to be kind of inert in nature. At the same time, regeneration has to be easier. Having said that, the other challenge that we always have with the solids is the limited surface area. How much you do, it's always limited. And I see even when it comes to CO2 capture side, also people always talk about, oh, we are developing these some functional groups on some nanoparticles and all. No, that's not going to fly. It is the simplest answer from the commercial point of view. For R&D, paper publication, most welcome, you must do it. That way we would learn lots of new concepts, new evolutions and everything. But when it comes to industry, it is a surface area that's going to speak out. It's always possible only with the liquid. So you can think of increasing the surface area. Why not use platinum nanoparticle itself instead of just using these, or even, platinum coated nanoparticles you could think of using instead of just using platinum itself. That would help cut down the cost. But otherwise, from the commercial viability point of view, you can think of doing that, but I don't really see when it comes to competing with the kinetics. Nanometals are going to enhance, but they can't really catch up with the liquid process, whatever you do. So as a catalyst, if you want to use it in the electrolyzers, one could think of using platinum coating the nanoparticles of other materials which are inert in nature, probably even titanium oxide or something, functionalize them and utilize them for hydrogen production to cut down the over potentials. That's it. That's the thing which I could say. I see lots of paper people talking about even copper-based materials, copper oxide and other materials. Even in Nature they published. But are they really viable on the large scale? I really doubt, because they are not stable. When Cu copper oxide is not a very stable material, it undergoes changes over a period of time. Okay.
Thank you. So surface area is the issue. So nanomaterials is the future, you're saying. Yeah. So I move to my second panelist, Professor Upadhyayula. Pronouncing it correctly. Thank you so much. Okay. So I read you are dealing with heterogeneous catalysis. So how is this heterogeneous catalyst, how it can be optimized for efficient hydrogen production, or some of the challenges we have?
Very much. First of all, take this opportunity to thank SRM and the organizers for inviting me here to this excellent summit. Meet all the stalwarts of the industry as well as the academia. So coming to your first question about how heterogeneous catalysis is optimized for efficient hydrogen from biomass and refinery feedstocks. So I would separate both of them first. Let's take up the biomass. So there is biomass, again, when you classify, it goes into forest and agri residues, and that the conventional pathway is there where it can be catalytically gasified. Gasifiers are there, but catalysts, albeit, can be used in the gasification process to produce what is called syngas, which is hydrogen to CO and CO2, and of course a lot of impurities like tars. This syngas has to be cleaned up in the next step, and then there is in the conventional pathway for the coke gasification and coal gasification, you have the water gas shift reactors that are coming up after the cleanup, which maximize the hydrogen to the carbon oxides ratio. So this is what, but in this biomass with the forest residues, you can actually do what the hydrogen can be separated from the syngas first after its cleanup, and then the CO and CO2 can actually be converted into more hydrogen, thus maximizing the hydrogen from the biomass. And this technology we have developed at 3RTRL4 in our lab. I can talk to it. I think probably you're asking me in the fourth question, so I'll talk about it. That's one way from the biomass. The other way from the biomass is using an anaerobic digester. And there, of course, enzymatic catalysis comes in. It's also heterogeneous, by the way, but it's enzymatic. So that has disadvantages of low kinetics and a lot of problems with the microbes and all. But then when you add more enzymatic the things for the methanogenesis reaction, you have your biogas that you're getting with about 30 to 40% of CO2 in the biomethane that you are generating. Now, CCU, I think yesterday Dr. Malhotra was talking about hydrogen production without CCU is not going to be viable or sustainable in the long run. If we just look at hydrogen and neglect the CCU part, again, you need to do all the research and come back again from ground zero and then develop CCU and all that. What is happening in the refineries now because we didn't bother much about the CCU. So while you're doing hydrogen or making hydrogen, we need to be careful and aware of the CCU part, CCUS or CCU. So while you're doing this, 40% or 30 to 40% of the CO2 that comes out of this biogas, we now have a technology for it again to convert into more hydrogen, of course, with supporting other useful materials coming out of it. Then comes another type of bio waste which are sulfate laden, especially we have a lot of population in India, so Indians, we need to be careful about the sulfate laden waste that we get, the sewage sludge that we get out of all the domestic usages. And this again can be converted again by an anaerobic digester. However, at this stage, this anaerobic digestion should be pushed towards the SRB, that is the H2S generation, the sulfidation instead of the methanogenesis earlier, where you use it for the biogas production. And this, if you push it towards the, this thing of production of H2S followed by that H2S can be decomposed directly into hydrogen and sulfur. In the refineries, you use the clause or superclause process, wherein you actually produce water and then sulfur and sulfur dioxide. So instead of that, we have a TRL3, TRL4 developed in our labs, where we directly can split H2S using these heterogeneous catalysis, and I get hydrogen and sulfur directly. So this technology we had presented in HPCL refinery. By the way, there is next generation, and we got a first prize for that. I hope to, hope for collaborations in that. So this is what heterogeneous catalysis can do in many ways to the biomass. And same thing with the refinery H2S as well. So the clause process, which does not yield you hydrogen now, can yield you hydrogen by the process I've told. Thank you for taking a little more time. Question is.
Thank you, Professor. Yeah, we are doing a lot of CBG plants which are coming up. Some of them use some of the process which you're talking about, but I think a larger collaboration definitely yield results. There are around 130 CBG plants which are in the pipeline. So some of them use anaerobic digestion and stuff like that. So definitely we look forward to a collaboration. Next is Harish Jairam, dear colleague and dear friend. We have been interacting. He has put up the third hydrogen plant. This is for Sterlite Industries. So what are the key factors that determine the commercial viability? Because you have put up three now, definitely know what all factors for the commercial viability of large-scale green hydrogen, especially in hard-to-abate sectors.
Yeah, thank you for the question, Mr. Nair. And first, would like to thank my fellow panelists. Also thank SRM University for having me here, Ground of AP. This is a very interesting question. As at Hygenco, in the last 5 years, we've set up 3 operating plants. We set up the first R&D plant way back in March 22, set up at Ujjain, Madhya Pradesh. And since then, 2 more operating plants, commercial plants with long-term contracts with end off-takers. We went live last year for Jindal Stainless Steel, March last year, and we supplied them green hydrogen. And this plant has been running very well for the last 16, 17 months. Just this week, we announced setting up one more plant for Sterlite, which we actually commissioned and gone live early this week in the state of Maharashtra. So we have 3 operating plants, and then we have a large-scale green ammonia plant setting up in Gopalpur, Odisha. So that will be commissioned in 3 phases. Total capacity is 1.1 million tons per annum, built over phases. First phase will commission in 28, 29, and the last phase by 31, 32. Yeah, lots to share. First, for feasibility, commercial feasibility, let's look at the macro factors we have to look at. Of course, India's mission is obviously in place. It's very good. Exactly why all of us are here. We look at policy support, which comes from the center, also comes from the state, and states have different policy support. And you pick the battle, you pick the right state. Very, very important. For example, we have a ammonia plant in Gopalpur, Odisha, and state offers a lot of capex subsidies for putting up plants over there. It's over 25%. Some states like UP offer up to 35% capex subsidies. So you have to pick the right state to put up your plant. And then, of course, factors on RE availability, grid availability, all these are very important factors. But commercial factors, I want to highlight about 3 or 4. You have to pick the right off-taker who has a mandate to go green, off-taker who wants to utilize green hydrogen. Maybe the premium is a bit more initially, but over time, it evens out. So you have to pick the right off-taker. And also pick the right use case. There are use cases today which are feasible. Many use cases not feasible. So pick the right use case. In the case of Jindal Stainless Steel, the contract which we signed 2 years back, plant was commissioned last year. We are supplying green hydrogen for the downstream process of heat treatment annealing. But today the customer is sourcing gray using cracking mechanism, which for them is obviously more expensive. But we gave them an option of green hydrogen, and for them it's feasible commercially from day one. And hence we signed a long-term contract with them 20 years. The one for Sterlite we commissioned just recently. They actually use green hydrogen in their glass preform process, and for them sourcing green is very viable from day one. Plus, they have a strong mandate to also go green. The other factor is tenure. Tenure impacts the pricing that is offered. 10 years versus 20 years. Longer tenure will actually lead to a low price you can offer customers. Today, tenures out there vary between 10 to 25 years, right? So ISL tender was 25 years, which was given to L&T a couple of months back. Recently, HPCL is also 25 years, BPCL will be 15 years. Tenure has an impact on the pricing. So that's something to closely watch. Obviously, as a developer, we negotiate a longer tenure so that we're able to offer a lower price to the end off-taker. And understanding the customer's requirements is very important. So spending time with the customer, understanding what the pain points are, and how they want the supply. What quantum? Do they want supply throughout the day, throughout 24/7? So let's say a customer wants supply 24/7, then I have to think about storage. How do I store hydrogen? All that adds to the capex, right? So discuss this with the customer and understand what he needs, what the pain points are, and how we need the supply, right? So all this has a bearing on the pricing, hence the commercial feasibility. I want to highlight one more important factor, right? So especially talking about large-scale projects, exporting ammonia, port infra becomes very important. Thankfully, this state of AP has, I think, a dozen ports. I think offers about 4 large ports. And yesterday, Honorable Chief Minister said he will have a port every 50 kilometers. What does that mean? This state has almost 1,000 kilometers coastline. That's 20 ports. That's very important. I think having the right port access, port infra, port charges being very, very moderate is very important for developers like us to set up large-scale plants. And then access to water. Water is to me is gold. You may put up large scale desal plants, but water is still a premium, right? So water can be used in number of ways. But if water is utilized for production of green hydrogen, it better makes sense, right? So it's very important. Access to RE, we've been talking the last 2 days, is very important. Thankfully, India has some wonderful policies. IST's policy is something India offers, which no other country has. No other country has it. So essentially, I can produce my RE in one part of the country. I can have my gas plant in, let's say, on the East Coast, RE plant on the West Coast, but able to transmit electrons without paying a charge. No other country offers this benefit. India offers these benefits. So on the infra side, access to port infra, access to RE. India has the lowest cost of RE, I believe, for both the wind and solar, which means that we're able to produce the lowest cost of hydrogen anywhere in the world. So which means our exports become very attractive. So all these factors, right off takers, picking the right use case, tenure matters, knowing what the customer wants, customer pain points, understanding customer supply requirements, and last is infra is very key. Land is very important, right? So land is hard to find in India, and sometimes finding land close to a port is very expensive as well. So here's why we need support from the state. And state like Andhra, Odisha, Gujarat, all offer land at very attractive prices, and that's very important for investors to come in. So land, water, infra, all these are become very important for us to be feasible. Thank
Thank
you.
you so much. So you'll be keenly watching the BPCL tender. Looking forward to, and I'm sure with the kind of experience you have, yeah, all the best for that.
Thank you so much.
Move to Dr. Bhavanari. How can I read a lot about your work in nanostructured electrocatalysts. How do you think the advancements in nanostructured electrocatalysts can enhance the efficiency?
Good afternoon and thank you. Thanks the organizers and the chairman for the question. And yeah, so when we look for the cost of an electrolyzer, you're basically looking at what cost you can deliver the electrolyzer, and where OPEX also includes the heating element, balance of plant, everything. But when you develop a nanostructure with high efficiency and high current generation at a lower O potentials, it can generate more amount of hydrogen without any external input, external energy input, and but and also now if you see the alkaline electrolyzers, they are being operated at 60 degrees centigrade. But when I and also the electrolyte which is used is harsh, so there is a chance of corrosion. So to increase the longevity of the electrolyte, we can also go for low temperature operations of the alkaline electrolyzers for decreasing the D rate or increasing the longevity. So, but at another thing is like we also operate at various pressures. So decreasing, we can also decrease the pressure by increasing the surface area of the catalyst, which is durable for longer operations at higher current density. Also, another thing I would like to tell, not only alkaline electrolysis, now we are talking about seawater electrolysis. So suppose it was demonstrated in Orkney Islands that they use wind energy on the surface, they use an electrolyte, desalinate and then generate. But with increase in the amount of gigawatts of electrolyzers to generate higher amounts of hydrogen, which is beneficial for medical applications, power application, and also now India is looking forward for semiconductor applications. There also they need very high pure hydrogen. So for good security of energy security of India and also economical security as well as export, we need a very good electrolyzer which can operate for very longer durations, because by operating at this atmosphere, some of the catalysts are leaching. And again, this capex will be increasing time to time. So the replacement of the electrolyzer also would reduce by proper design of the electrocatalyst with triple phase boundaries, and operation at lower temperatures, or if you go for higher temperature also, it should be resistance to adverse effects that are being uh, uh, promoting in delaminating or derating the electrolysis.
Thank you so much.
Thank you.
We move to Dr. Bag. What are the most promising areas in chemical research that could address the limitations? Since we're talking about limitations, what are the various research you are taking?
Yeah, thank you for your question. So good afternoon, everyone. So at first, I'd like to give thanks to Professor C.H. Satish Kumar and Pro Vice Chancellor and Dr. M. Pardhasarathi, so who invited me and gave this opportunity to attend this Green Hydrogen Summit 2025. Yeah, coming to this question, what are the most promising areas of chemical research that could be addressed in the current limitations? So, in the current current research on this green hydrogen production, so most of the time, as a academician, if I say, most of the time we faced that catalyst which are actually producing a very good amount of hydrogen, but we faced that less stable, low stable, as well as the durability also very less. So that, in my opinion, if we design such material, maybe mostly the nanomaterial, if we design in this way, by combining different types of earth abundant metal, which replace the non-metal, probably the transition metals, which are low cost, so that we can minimize the cost first if we can make this. And secondly, what the stability we are talking. So if we can make hybrid materials, then definitely it it definitely it will be stable, as well as it efficiency also definitely it will increase. And second thing, that fuel application, that hydrogen storage purpose. So generally uh, hydrates, mostly hydrates, those things are used for the hydrogen storage. But if we, yeah, if we make recently what new types of, not new, but recently we are using in literature, if we see that the metal organic framework or covalent organic framework, those are having very good pore size, as well as its surface area is very big, so that it can be stored in efficient way. So if we summarize my answer, that materials, that electrocatalyst, if we design in this way by which that efficiency as well as durability will increase, and the hydrogen storage material, if we make it in advanced way, probably we can face the challenge. And yes, definitely another last point I mentioned, that yesterday I went through the session. So there, what they mentioned, that daytime sunlight is there definitely, but nighttime there is no sunlight. So for that, what my opinion, so if we make like a hybrid system which will produce this hydrogen, daytime, this means it will combine together that solar system as well as wind together. When your solar means sunlight is available, that time it will work using sunlight. And if when there is no sunlight, then wind power we can use, and we can produce hydrogen. So probably it may solve the problem and whatever challenge we have. So thank you very much.
Thank you, Dr. Bag. So coming back on to the point which Professor Upadhyaya was saying about carbon capture. Refineries haven't done much. So that's true. That's a fact. So we are still in the research mode. If we had done, we could have taken care of each of the emissions. So coming to you, Dr. Guduru. So I read a lot of CO2 capture related work. So I jump onto that because as a refiner, I'm interested in knowing what we can do in that. How do you see hydrogen and carbon capture technology?
So, I mean, if both are going to be ending up on the same goal, we want to basically decarbonize, make it net zero. So hydrogen production, as long as it's commercially viable, it's going to achieve whatever you're targeting for. But one thing, what technology are you using to produce hydrogen? That's number one. Number two, if you're going with green hydrogen using electrolysis, what sort of power input? I mean, where is the power coming from? If you're going with solar and all, it's intermittent in nature. You will be going for the batteries. That's the only way out. But my biggest concern with batteries is always like there is no recyclable technology as such. I mean, environment friendly technologies still have to evolve. There are a couple of companies in Nevada, US, but I don't really know what's happening in India. Most of the materials, either they get crushed and then they emit lots of carcinogenic gases when the electrolyte comes out. So that is the only threat which I see as a batteries being used. If you're using the solar as intermittent the power supply unit for high production of hydrogen, okay? There you lose some sort of sustainability. Again, it could lead to eventual environmental pollution. May not be the direct emission right away, but at the end or throughout the life cycle, somewhere you see. And when you talk about carbon capture, amine-based technology is already existing. And you know, with David Keith is a faculty from Harvard who started to capture CO2 directly from air 2009 odd, I guess. That's time even Bill Gates funded almost close to $100 million to set up a plant in Canada-US border. So the challenge with the process was they were using KOH as an absorbent. With NaOH, KOH and all, they're good, but their regeneration is quite energy consuming. And on the other side, if you go with amines, maybe not primary, secondary, tertiary amines are coming out to be a good solution to use for CO2 capture, but they are quite sensitive to oxygen. If you have any oxygen, and their selectivity is also not so great when it comes to lean concentrations of CO2. They're good only for rich CO2 concentrations, like flue gases. Again, in flue, if you don't have enough CO2, it may or may not work out efficiently. But the technology that we have developed, we don't really use any high temperature for regeneration. We just use only room temperature. So then I see that there is a good possibility. You know, sometimes, I mean, I don't want to say this, but I had to share it. Sometimes common sense is so common. I felt like people have somehow missed out, and there I found the solution. Instead of running for something else, something whatever we have, we could really utilize it. In that way, we invented this process, and the patent was also filed. So I see both are going to be converged. But on the CO2 capture side, if you are again bringing energy into point of consuming, capturing CO2 from air is an energy intensive process. It's quite expensive. Even as of now, it's around $300+ per ton of CO2 capture. If you go with amines based, somewhere around $100 or so per ton of CO2 capture. The best viability without affecting the environment is going to be below $70 or $60 per ton of CO2 capture we have to do. So if we could target it out in that way, yes, we are in the safe side. So I see both are going to be helping you achieve the same goal. But you know, the things have to roll in that direction to meet the target rather than you know, just developing some solutions randomly and pushing them. Okay, thank you.
Thank you, Doctor. Very well said. Professor Upadhyaya, the next question is on your work on ionic liquids and zeotype materials. So how do these contribute to green hydrogen production and take care of some of the challenges?
Yeah, so let me first come to the ionic liquids part. So as I said, CCU plus hydrogen production is the target that I pose to my students, my researchers, young researchers. So both together to give you all a sustainable process. And for this, you know, you have CC as absorption-based process and adsorption-based process. So one such, the absorption-based process, I think Dr. Ramesh has just told you what are the problems in the industrial absorption processes. So ionic liquids as such I'm using for that, which, overcome those disadvantages that he's talking about. And hopefully we don't need even the cost, because every time when we say ionic liquids, people say they're very costly, which is not true. The blends that are used for the absorption are very, very cheap, and probably will be hitting the target of 60 to 70. So which is very good. Now coming to the next is the zeotype materials. So there are other processes where you just need a heterogeneous catalyst for scale, when you scale up this process. So we're trying to use ILs as catalysts as well, and because they are in liquid form, we try and heterogenize them on the zeotype materials, which we also synthesize in the labs. The researchers do that for the specific processes that I have talked about in the last question. Thank you very much.
Thank you, Professor. At what stage this is, Professor, your research on?
Yeah, so anything in our lab is only at 3, 4. Proof of concept is established. The 4 to 7 needs funding. So we are approaching with our ideas to different, as I said, I went and put my idea to HPCL Green R&D, and they gave me a prize for me and my students. I don't know when they will give the fund. So somebody like that,
leaves
or
some
the inner
opportunity
government.
for
And then I
BPCL.
also take this opportunity to tell you that I do have one project with BPCL R&D there. Rajiv Kumar, Dr. Rajiv Kumar Racha, and everybody are involved. But this is not towards hydrogen. That's why I didn't talk to you before that. But when you express this, so that is for making SAF by the CO2 captured in your refineries and then directly into SAF. Yeah, thank you.
Thank you, Professor. So, Mr. Jairam, from business development lens, what partnership or models are proving most effective for accelerating green hydrogen? In your opinion, what do you think? What kind of partnership, kind of collaboration will help in scaling up? With your experience in putting up the last.
Yeah, thanks for the question. I think one thing we've realized in the last 5 years is we can't bring in every capability as HydrogenCo. So we have to seek help outside sometimes, and to actually bridge the gap on that capability. And first, we need to acknowledge that, right? So we don't want to invest capex in every capability. So it's very important for us to go outside to seek the right partner. So this could be partner for, let's say, a partner for RE power, maybe a partner for storage. Sometimes we're putting up large storage in Gopalpur. And the dilemma is, do we incur capex for putting up a large storage of ammonia there, or can we lease this from a third party, right? So these are some things to look at. So that's very important. And also, now the other thing is we are making ammonia at Gopalpur, and we obviously have to sell this to markets globally as well as also India. Right now, demand signals globally are fairly subdued the last year and a half. India has done well. Let me tell you, India in the last 6 months has done very well. So we have had 2 price discoveries, one from IOCL tender, which happened a month and a half back. Second one was from recent HPCL tender. We closed the SECI ammonia tender last week, which happened to be the largest ammonia tender, which closed last week. Start of the year, NTPC commissioned probably the world's largest green hydrogen hub in actually in this state, Vizag. So India has done really well. But for us to sell overseas, and as we put up all the capacities, we have to tender globally. One is H2 Global. This is offered by EU, by German government, and wherein supply comes from India, other countries, and then it goes to the market in Europe, which have a demand right now. So here we're asking government of India to actually give preference for developers in India, so that there's a tender specific for India developers to supply into the market in Europe through the H2 Global partnership platform, right? So I think these are some of the ways for us to be comfortable and being able to sell our product globally through some of these partnerships. Technology tie-ups, very important, right? So for ammonia, we signed up with Topsoil last year, right? So and for ammonia conversion, there are not too many technology partners out there, very few out there. So I can name about 3 or 4 right there. Topsoil is one, Casale is one, KBR is one. So, and given your specific design and the way you want to operate, integrate with RE, we have to pick the right technology partner. So we looked at all 3 partners, Topsoil, KBR, Casale, and then we signed up with Topsoil, Denmark last year. Electrolyzer partnership is important. Having a robust supply chain, that is also very important. And given the issues we're seeing right now, which are like geopolitical, which leads to supply chain disruptions, but there are also other issues with trade barriers, trade constraints. You need to have access or tie-ups with multiple suppliers of electrolyzers, right? So we're talking to suppliers in India, suppliers in China, suppliers in Europe, suppliers in China. And at any given point, you need to have multiple supply chain partners, especially for fertilizers. Our large scale plant in Gopalpur, it's a large scale plant. We can't go have just one supplier there. We need to have multiple suppliers there. It's very important. Yeah, so we have to look at this macro scale. We have to understand all the risk. We have to time things well. You have to spend your money wisely. You can't put capex in all areas. Where you can afford to lease, let's say storage or let's say land. Look at the option, right? You don't need to invest in every piece of the value chain. For example, RE, either you can choose to build your own RE or you can have the long-term third-party PPAs, right? So look at all these options as you tie up with various partners across the value chain. Value chain is starting from your RE to your production plan, storage, transportation until your port facilities. And port is very important, especially for exporters. Ports are very important, right? So pick the right port, pick the right state. And our government has notified 3 ports as green hydrogen hubs: Kandla in Gujarat, Tuticorin in Tamil Nadu, and Paradeep in Odisha. But there are also other ports out there. Our plant in Odisha, our port access is Gopalpur. State of Andhra has I think about 13 ports, 6 already operational, 7 under consideration, right? So, and so having the right ports at the right location, all these are very important. So partnership is key at every stage of the value chain.
Thank you, Mr. Jairam. And we are running out of time. We'll come to a final question to panelist. Dr. Guduru, I'll go to your last presentation, the last slide, hope or hype. So it's a question for all the panelists. I start with you. So what is the hope in hydrogen, or what are the few things we should look at or work on to make sure that it becomes a reality?
Thank you. So it's not exactly hype. There is a good probability of success in every innovation there, but only thing is that it boils down to the investment and the support that you get, okay? The policies that should favor. And let me just give you a very contrasting answer here. The way how people look at the innovation in different countries, that matters a lot. And because being in the US, I interacted with several investors companies. They had they would like to take the risk and give you the money, and they want to bet on it. Okay. We even, while being in India, when I talked to them, they said, "Why don't you bring the technology to US? Then we will fund you." Being in India, we are not going to. They said it on my face, so I didn't have any way to answer for that. But then When it comes to India, what I have seen is there is always a reservation against the innovation. The people don't want to step into the new regime, uh, and they want everything to be set up and established so that they could have a comfort zone in driving the companies or technologies or vehicles, whatever it is. So that's not going to work out if you really want to succeed in every aspect of the technologies. If you want to be at the forefront, or forget about all that. Even if you look at China, the government supports a lot. What I heard from many people, even in the business segment, is that many they have sort of several small companies, must are micro, small scale, whatever. The government does support in selling their products. That's a very unique, beautiful thing any government could really afford to do for their own companies. That makes their livelihood very happy. So people would love to venture into new things and seek the help of selling their products. And unless that happens, innovations will not really find their path way out into the commercial segment in India. I mean, that is something I could say. That would be very challenging. Uh, Even we have been trying to work with the ONGC. It took a good amount of time to penetrate into the barrier, but now we are with them. So I see, there are barriers, a good amount of entry barriers. Thank you.
Thank you, Dr. Gurud. Madam Professor.
So with respect to the green, I would say, I mean, a sudden jump into the green is not a visible one, but of course not hype as well. I think we should go along with gray, blue, and turquoise, and then green. Of course, green being the target. But I think for a while we'll have to hold hands with the other colors as well together. And the future, whatever technologies are coming up, we should be very careful to make them all green in the sense the CCU is to be added to become completely green. And of course, the feedstock material, which also should be, not from the fossil. So this is the way to go probably. And I think in India, we have one problem is three to four or four, I say TRL4, it's very easy with institutes. In many of the institutes, you have lot of TRL3, TRL4, and they're all shelved. Of course, all these institutes are human resource development, so they take their degrees and go and get good jobs. That is fine, but then the 3 and 4 to the 6 and 7 demonstration or 5 and 6 demonstration, that's the slowest rate limiting step in my own engineering words, if I have to say. It's the rate limiting step in our country. So if this will be, targeted, this rate is increased, then I think we actually have very good technologies coming up for the green hydrogen. Thank you very much.
So had you asked me this question 2 years back, is this a hype? I would have said, I'm not sure, not too sure. Let's be a bit more patient. But now, with the question asked today, I'm very upbeat. I'm very, very upbeat. India is poised as a leader. India is doing really well. There's been an uptick of activity in the last 6 months. India is putting out very positive signals globally. The price points achieved in India, people globally are looking at that. I think the price points of green hydrogen are right now sub $4. These are good prices coming out. So all of us here in this room should work together and ensure that India is a leader in this space globally, putting out the lowest cost of hydrogen, lowest cost of ammonia, and other green molecules, be it the green methanol or SAF. On the debate on the color, I'm going to say that we should stay focused, pick your battle right. Don't pick all the colors, pick one color. And that color for India has to be green. Why I say it is for water electrolysis for green hydrogen, you have only 2 inputs. What are those? Water. India has all the water. India has ample water. We just need the right technology there, right innovation to bring on the water to all these plants. The other input is RE, renewable energy, which is what? Wind, solar. And India has amongst the lowest cost of solar, lowest cost of wind in the world. We have ample resources. Let's look at the statistics for wind and solar. How much of solar do we have in India? I think it's over 110 gigawatts, 120 gigawatts. How much wind do we have? I think it's over 50 gigawatts. Installed capacity of RE in India is about 50%. I think it's about 220 gigawatts is RE of the 450 gigawatts. So water is solved for. We have access to water. RE is solved for. What else do we need? Land? Come to this state. Come to Andhra. We have all the land here. Most states have offer land packages. They offer capex subsidies. So let's stay focused. Let's go green, and let's pick the right color. And that color is green hydrogen. And let's do it. In about 2-3 years' time, I think India will be the market leader. And market leader, I would say in the top 1-2. I think there's very few countries today who can match the cost from India. I can name a few countries, probably 1-2 from the Middle East, maybe 1 from South America. Not the rest, not the rest. And the other thing is India has also very strong local demand. If I can't export globally to markets in Europe or to the Far East markets, I have local demand. And these costs are coming down. So the local industry, refineries, fertilizers will consume locally.
Thank you, Mr. Jairam. I think I asked the wrong question to. Yeah, he's the biggest brand ambassador of green hydrogen.
I can talk all day.
Yeah, Dr. Bhavnari, please.
Thank you. For India to become a green hydrogen supplier all over the world, I think first we have to look for academia industry partnership, because India is very good in innovative and low cost process development. But if you go for the R&D, we work on the science novel materials to generate an efficient material or product. But when industry and academia come together, products can be launched, engineered in a shorter duration. Also, in terms of larger establishments of green hydrogen plants in India, we also require manpower for the same. So gaining the, at the starting at engineering level or master's level, giving them some insights on what is required, how is the future, and also some vocational trainings related to the plant maintenance or developing the products. Also, like material availability. For encouraging the R&D, we also need the material availability. Now there are green hydrogen valleys which are proposed, but most of the materials, Nafion, if you think, they are being imported. And the suppliers there are in India, different types of Nafions, and there are, when you come for focusing on affordable product development, we also need to do some experiments. But at the same time, these should be available to the researchers. So this could also be the one to include providing the proper materials. Also, there are some translation institutes in India who have developed the products, but that also can be available to the industry for developing, also testing. After along with the testing, how about taking it to the market? So for that, we need some centers where they test the technology. In industry academia partnership, what happens is different components which are developed can be integrated. So that's how we can look for affordable hydrogen and product development in India at a very short time for implementation. Thank you.
Thank you, Dr. Bhavnari. Dr. Bhag.
Yeah. So, answer to this question. So, when I started my research in this field 9 years or 10 years back, at that time, if you ask this question, definitely it feels like a hype. But now at this moment, how the research progress, this is not hype, rather I can say this is hope. Obviously, this is hope. But yes, I agree with all the panelists, what they told, that immediate, we are saying green and listening this color, green, it's really very nice. But immediate to convert green, little bit difficult. So if we consider all like that blue hydrogen also, then probably it will be fine for now, but slowly we can convert. And then another, what Dr. Ramesh he mentioned, that financial support. If we have enough financial support, definitely we can achieve one day this green hydrogen mission in India. So thank you very much.
Thank you, Dr. Bag. So there is a lot of hope. So there is nothing to despair. So green hydrogen is the future. So only the path being adopted. Should we go with from gray to blue to green, or straight away jump to green? That's only a point of view. Otherwise, there's a lot of consensus on the panel members here. Investment in R&D, government intervention. There is a lot of academia and industry collaboration, which is looking forward to. So I conclude the session with that. We're complimenting all the panelists here. They're doing wonderful work in advancing hydrogen and hydrogen-related work. Congratulations to you, and all the best. Thank you, the organizer. Thanks to the organizer. Thank you so much.
Thank you very much for this enriching discussion, sir. We request Mr. Ranjan Nair to felicitate the panelists. To start with, Dr. Ramesh Guduru, Professor Sri Devi, Dr. Mallikarjun Bhavnari, Dr. Partha Pratimbag. We request Dr. Sujit Kaluri, Associate Professor, Department of ECE, co-convener of Green Hydrogen Summit, to felicitate Mr. Ranjan Nair. As we move forward to the Conclave 4, I request Professor A. Gopal Krishnan Iyer from REPA to kindly moderate the session, sir.
Sri Gopal Krishna Iyer is the founder president of Renewable Energy Promotion Association and Inertia Foundation. He is also a distinguished alumnus of a National Institution of Technology, Kurukshetra. With over 30 years of leadership in India's clean energy and infrastructure sector, he has played a pivotal role in shaping public and industry discourse on sustainable development. Professor Iyer served as head of marketing at MAN and B&W Diesel Power Plant India Private Limited, and later as a CEO of Indian Oasis. From 2004 to 2007, he was executive editor and CEO of Inertia, a business journal focused on energy and infrastructure. As a columnist and editor, he contributed to Indian Express Energy Supplement Business Avenues, a critique of COP, Conference of Parties. Professor Iyer recommends US dollar 10-11 trillion per annum investment necessary for renewable energy and SDG combined, as it is just about 10% of the global GDP. He has introduced, as of 2024, a brand new terminology for the purpose renewability beyond sustainability, which is now poised to be the future roadmap for global energy transition. We welcome you, sir.
Thankful for that introduction, my friends. I think all of you should have energy. When I call over the other speakers, I want this entire hall to clap and please encourage who are coming because they're taking their time off from their busy schedules and also they're giving their minds here. So please give all of them a big hand, but I'm just starting with Dr. Yuvraj is there. Dr. N. Yuvraj, I think he's not there. Dr. Sujit Pillai, may I invite Dr. Sujit Pillai? A little bit more force. Energy sector should have more force. Dr. Sujit Pillai is currently serving as a scientist F in the Ministry of New and Renewable Energy, Government of India, contributing significantly to the India's clean energy initiatives through policy advice, program design, and the project evaluation. In 2019, he served as a consultant at the National Institute of Solar Energy, NISE, focusing on scaling the solar applications and integrating renewable energy technologies. His work bridges technical research and applied policy, advancing hydrogen solar research to support MNRE's mission. His presence at the Hydrogen Summit reflects MNRE's commitment to cross-sector collaboration in building a sustainable hydrogen economy. Please give him a big hand. See, the clap goes down. I don't like it. I'll be very animated. Be careful. The next gentleman I'm calling is Mr. Robbie Rajashekharam. Taaliyan bajaiye, please. He is the Chief Executive Officer of KPI Green Hydrogen and Ammonia Private Limited, leading the KP Group's transition into the global hydrogen economy through strategic direction, technology, innovation, and global partnerships. As alumnus of the IIM Lucknow and Cambridge and the project management credentials from NICMA, near me in Pune, right? He has led major infrastructure projects across solar, thermal, petrochemical, hospitality, and commercial sectors. His multifaceted background and the commitment to decarbonization, energy-intensive industries make him a key driver of India's clean energy transition. Once again, a big hand to him. My next panelist is Mr. Anil Srekar Pavluri. Do we have him? Yes, wonderful. He's the head of business development at Green H Electrolysis Private Limited, a joint venture between Spain's H2B2 and India's GR Promoter Group. With over 15 years in clean energy, specializes in green hydrogen, electrolyzer technologies, and EPC solutions for hydrogen infrastructure. His prior roles at Toshiba GSW and L&T Power shaped his expertise in business development and project execution. Anil holds an MBA in business development and project execution and holds an MBA from the NMIMS and a BTech from the JNTUH. Congratulations. Please give him a big hand. Hey, the claps go down. What happens? Mr. Karthike A is our next panelist. Is a visionary in public policy leadership. Is he there? Mr. Karthike is there? Yes. So he's also a dear friend, by the way. So I'm introducing a friend. Mr. Karthike is a visionary public policy leader and a strategist currently working with the government of Andhra Pradesh and known for driving 3.7 lakh crore in green hydrogen investments, implementing impactful clean energy education, skill development initiatives. He holds degrees from the ISB, Cornell, and IIM Bangalore, and has led the drafting and the state's hydrogen promotion policy, establishment of skill and renewable energy universities, and modernization of technical education. Recognized globally, including as a keynote speaker in COP28. Please give him a big hand for that. He brings award-winning leadership experience from both government and the private sector. And I think I have one more, and I'm sorry, gentlemen, please have your bio, but I'm inviting Dr. Y.B.K. Reddy, Everett, to come here. I hope that maybe you can, sir, introduce yourself, because I have not got any slip here. So you need to.
Good afternoon, everyone. I'm Bharat Reddy from Everett Energy. Everett is a company owned by Brookfield Renewables, which is one of the largest renewable company globally. Before Brookfield, I was with Solar Energy Corporation of India for around 12 years. And then I worked in Mozarbeer R&D before Solar Energy Corporation. I worked both academic, industry, and government organizations. Right now, we are focusing on development of large-scale renewable in Everett, and also we are venturing into green hydrogen. We have number of MOUs with various states, including AP. We are just waiting for the viability of the projects. Commercial viability is important. For that, we are waiting with the means good incentives or policies. I think we will start our journey soon in green hydrogen also.
Wonderful. Yes, that's great. My friends up there started it. Wonderful. So, I've been certain things they have not said. So I wish to just take a little time with the permission of my guys, not this, not these books. Actually, I was lucky because I knew a few prime ministers, including Dr. Atal Bihari Vajpayee Saab, Narasimha Rao Saab. So I am a biographer of 4 prime ministers of India. Atal Shastra on Atal Bihari Vajpayee, Narasimha Sutra. I gave the book, they could not show. So that is Narasimha Sutra. The third one was on Rajiv Gandhi, Rajiv Samhita. And the fourth, recently, which I published, is called Manmohan Granth. The man, I tell you, will be found out later as the great Prime Minister of India, Dr. Manmohan Singh. So, in addition, I was mentored by 2 giants of India. One was the man called Dr. V. Krishnamurthy, who is responsible founder for BHEL, Bharat Heavy Electricals Limited, the megalith, which actually is the biggest company in India in energy technologies. And the second one was Yogendra Prasad. He was the longest serving chairman of the public sector in India for 7 years. We lost him in COVID. But now my dear friend, Mr. Gurdeep Singh, the current chairman and managing director of NTPC, has crossed that. He's now 9 years public sector chief. So he breaks that record. So they were my mentors, one on hydro and the other on the technology side for power. So please give a big hand, because people like me are coming here because of these people who taught us, right? And I headed a world-leading company called MAN BMW. MAN BMW now is called Everlane, and in between it keeps changing its name. I don't know why. MAN BMW Diesel, and later on MAN BMW Diesel and Turbo, and then subsequently it became a Volkswagen company. It became a MAN Energy Systems, and then it now is Everlane. But I can tell you, the beautiful company had put hydrogen into its engines long ago when I was there, and they were already blending 25% hydrogen in the late 90s. So, and we were building power plants. We built 4,000 megawatt captive power. I was heading that game in India, and that was the largest. We beat China at the time. So I want to give this historical perspective. They were liquid fuel power plants, burning heavy fuel oil. And in Andhra, it was my Karma Bhumi. Tadpatri cement plant, we built 212 megawatt, first cement plant ever in the world to operate 1 million ton without grid. So now that was an Excel belt, and today everything is now clean over there. Fantastic, people's lives have come up. And recently, the favorite project of mine, where I mentored officers here, was the Pinnapuram. And if you say I visited in February, I can tell you its beauty. It's in the Kurnool district nearby. And again, the same energy train. It's the biggest hybrid project, 6.68 gigawatt it will produce using, our renewable energy. But beauty is the pump storage with and its technology there. It's a landmark thing. Last day, I got a news that 6 of the machines are already on the grid. Only 2 more are going to come. Of course, for other purpose, I think the center has to clear. Some clearances are there, but the machines are ready to deliver to the grid. Another good news for pump storage is that Tehri also, we have 2 projects now. 2 engines are already on the grid delivering power. So pump storage policy we made last year, 2024. We made 100 gigawatt solar in 2013, which unfortunately 100 gigawatts not achieved in 2022, 25, but that's good. We're celebrating this on the 6th of August in Mumbai. And also 108 CBG plants. Please give a big hand to the government of India and all people, because what they said cannot happen. We did a white paper in 2021, moved and shaked it, and with Tarun Kapoor, the current advisor to PM, that time was the petroleum secretary, and he said, Professor, you could move and show us some direction in this area. So I worked on so many areas, including financing, and that's why we are here today, because I'll be telling you that there is an alternative investment for inclusive financing coming up, and I'm representing a very major development of private development financial institution having a $1 trillion corpus for renewable energy and sustainable development goal. But this is not enough. As you must have heard, I've said that COP is not done enough. UNCTAD was critical of COP 28 and 29. They made blunder further. UNCTAD report said $544 billion for sustainable development goals was not enough. We needed something like $10 trillion because the global GDP at this juncture is 110 trillion. So we are not putting enough, we're not putting money where the mouth is. So that's a scenario with which I begin. And first, I would like Mr. Sujit Pillai to start, because he is in the government, he's in the scientist level. But I think, what are the challenges fundamentally, that how do you go to alternative? Because currently the debt exposure to even the best companies, I don't want to name them, but top 2 or 3 or 4 companies in India who are very powerful and they get bank finances. The ESG reports tell me that 9.5% is the average debt exposure to the private sector. Public sector, the debt is about 8.5%. So this is not viable, because my neighbors are getting money at about 5%. China is accessing anywhere less than 5%, sometimes 3.5%. So my first question is, how do we go? Technology, yes, new technology, investment, business case, all this will come, because we need a business case for every issue, even hydrogen. So this is even more tougher than solar or other things, because hydrogen, the time to prove the technology is still there. We are in the midst of it. What are the challenges now for the government itself? Because you will be in many forums. What are the challenges for the government? Is the government looking at alternative mechanism of financing, or is the government still looking at the bank sector to finance it?
Yeah, thank you for the question. So I'd like to thank the organizers first, SRM University, and all for inviting me. That's a difficult question for a scientist, because scientists typically don't deal with such things. But anyway, I'd like to say that green hydrogen, basically, I disagree with your statement that technology is not proven. I was at a seminar recently organized by the India Energy Storage Alliance, where they showed us that now the specific energy consumption for electrolysis has come down to 41. That's very close to the HHV of hydrogen. So I think that, and this is a company that has a partnership with one of the biggest companies in India. I won't take their name, but I think you can guess who it is. And so I don't feel that the technology has something to be proven. But as far
I'm just interjecting. I'm not talking from that perspective. See, the funding perspective is they want installations. I have seen these examples. So what they do, they say this, if even at least a dozen installations have not worked for, let's say, 7, 10 years, they end up not considering those projects. This has happened in many cases. So this is the point. It's not that it's not proven for us, but the world investment community is not interested in it unless they see years of experience, because they generally know these projects start showing their other side after 5 or 7 years, whatever is claimed,
Yeah, but then I think in India the story is slightly different. We are, as
But I'm
opposed to
also
some
part
other
of the story.
Yeah, sure, but in certain other countries, I know I don't want to name those countries, but there are projects getting cancelled and all that because of certain issues. So in India, I think the outlook is much more rosier than this thing. So and maybe I know a number of yesterday at the conclaves they mentioned about demand side support and all that. So maybe that is something that could be, you know, we've noted that down, and maybe that is something that could be considered. But I feel the story in India is very rosy right now. Of course, you mentioned the interest rate differential and all that, so that is always there. But then we have to, I mean, with the learning curve and all that, I think it should, I mean, we are after all one of the lowest solar rates in the world now.
No,
So it may take
I would
some
still
time.
like to engage you. No, probably my message goes for. My point is, see, conventional financing has its limitations. It has been found out, and one major policy dimension the government did, which unfortunately has not been exploited in the country, and that is for this funds to go in FDI mode for energy infrastructure. 100% FDI is allowed in this country.
100% every day.
Okay, but it has not been used. See, for example, the banking industry cannot go through that route because FDI is a different route. So I'm just making this discussion a little bit forth so that when I go to the next speaker, see, we understand our challenge here. Our challenge is to get trillions of dollars into the economy. Like the power sector needs roughly $4 trillion if we have to even look at what figures we are talking about. See, suppose we expand current capacity to 800 gigawatt to 1000 gigawatt installed. I'm not even talking of efficiency right now. Then, you know, we would need roughly $2 trillion minimum to move it, because that needs transmission infrastructure to move as well, on 1 trillion equivalent, and also the generation infrastructure. So when you know that 2 to 3 trillion is the minimum that you need, which is half of my GDP, how do we plan? What is the government thinking on these lines? It is thinking that banks, financial institutions, multilateral institutions will do it. I'm very doubtful, sir. I have not seen this happening for years now. At these 11 years, so 25 years, I have not seen this happen. That's my question.
Yeah.
It is going to be a difficult session, but
it is,
we'll find a way
it's
out.
a difficult question, but maybe you can sort of, I'll come back to, yeah.
Yeah. I'm saying let it go. No, we'll be a little informal here. I would like everybody, because we will deal with financing in this section. I will not digress from any other area, because technology fellows are coming. They want to invest in it. And some people say, and then they say, okay, private sector fellows goes and say, I will invest so much, but from where? It's all banks, right? It's bankrolling the whole thing. So there's a limitation to that, because we need to build roads, we need to build projects, we need to build so many things. So what all we have?
Thanks for this question. Let me just elaborate my version of answering your question. So there are DFIs, there are banks like ADB, World Bank. They all want to fund green projects, which involves renewable energy, which involves green hydrogen and all. And everybody are worried about 2 to 3 aspects. The most important thing is technology disruption. Right now, the current technology which we have at the moment is alkaline and PEM, which are at the TRL level of 9. And slowly there would be technologies like SOIC, solid oxide electrolysis. There is anion exchange membrane as well, which could disrupt this market. So I have been interacting with one company in Gujarat. So they signed recently an offtake agreement with a company. I can't disclose those names of the companies. So they signed an offtake agreement for around 10 years, and they kept a lock-in period of around 4 years. 4 years at a particular price, they want to buy the hydrogen from the developer. And later on, when there is technology disruption, they will be seeing the market, what exactly is happening in the market, what could be the cost of green hydrogen 4 years down the line. If there is a reduction in the price at which they signed the offtake agreement earlier, then they would be again going back to the developer and they will be asking them, what could be your price right now? Will you be matching that price? If you don't match, I'm going to cancel the contract. Off-takers are protecting themselves from these kind of situations to have a flexible kind of, off-taking agreement. So financial institutions should look at or financial companies should look at medium-size offtake agreements and large-size offtake agreements. Medium-size offtake agreements like capacity of like 5,000 meter cube per day, 10,000 meter cube per day. There are off-takers for those as well, you know. And you can have to have an offtake agreement regarding a 10-year offtake agreement. Then you need to have this kind of flexibility inside the offtake agreement that the developer could be going again back to the banks, boss, 4 years down the line, I'm going to cancel, I'm going to get the offtake agreement cancelled. So why don't you give me an interest rate, maybe at a higher price, okay, so that there will be technology disruption later on. I will apply new technology in that, and then we revise the offtake agreement. So that kind of flexibility, if it's offered to the financial institutions, then they can devise the financial model accordingly. That is for the long or shorter one. Coming to the long-term one. So recently we had my colleague from Hygienco has said, my fellow colleague. So there was a recently, 2 months back, there was Paris Discovery in India for IOCL. L&T is the developer. And just last week, we had a result of HPCL in Vizag and 5 tons per annum pricing. So the prices were around 337 rupees per kg for a 100 megawatt plant. And for 50 megawatt plant, 328 rupees per kg. So there is a difference of around 7 rupees.
The L&T price is about $4.67 per kg.
That's including GST. Excluding GST, it's $3.95.
Yeah.
So I'm not talking about the GST part, okay. So there the financing would be from institution. In L&T case, I think it will be completed from L&T finance, okay. But in case of like the other company, HPCL, they would be having a debt financing for around 25 years offtake agreement. So the company is ready to offer 25 years offtake agreement at a certain prices, would be around 3 to 4%. There are cases. I was discussing with some steel company in India, and banks have come forward. Since it is green steel, I'm going to offer you a debt of around 2%, 20 years offtake agreement, right? 20 years offtake agreement, provided your IRR is less than 10%. Okay, so that is not bankable, but they want to do in this particular range. So there are financial institutions who are going to come and fund it.
Okay,
Yeah.
see, I'm going to be devil's advocate here. See, what happened, we have built hydropower. It's a proven case. Technology is no issue. Power sector is no issue. The only point is the environment issues. And generally they get delayed. For so many years, I've been championing the cause. Pump storage also we brought. What we have seen is that whatever they are claiming right now, banks do not have the muscle to fund it. See, I'm very clear on this, you know. So you can't tell a different story when the existing story is not at all good. And so therefore, you know, the current financial situation, see what happened in COP also, I'll tell you. COP is a mega failure in 29. They reduced the funding to 300 billion when they were criticized by UNCTAD for having only 544 billion. So trends do not tell me that I should believe in this at all. I as a professional will not believe in it because I'm not bound either by any model or anything to believe in it. You know, my whole interest is people like you succeed, people like him succeed, you know, and the government succeeds, you know. So this success cannot happen if we are not clear on what we are talking about in the financing world. So I would like this question to be immediately addressed, if possible, by our last man. Karthik should definitely address this because he will be best positioned to talk on this.
Yeah, your questions are so lengthy questions, but anyway, I
So
understand. I understand
short,
that your
short is clear.
No.
Interest rates in India are not good for long-term investment.
Sure.
Long-term asset investment.
Andarki namaskaram. First of all, I would like to thank SRM University and also our state New and Renewable Energy Development Corporation for making this summit as a huge success. The reason is, from last 8-9 years, I'm attending summits in abroad and everywhere. But the first summit I've seen in Vijayawada just happened because of our energy department and NetCap and SRM. Big congratulations to NetCap and SRM. I'm really proud that I'm in the state and seeing all the investors from across globe and attending here. So when it comes to question, Mr. Nair, I had a discussion with him 1 month back, a long, lengthy discussion on financing. No one can beat him on finance, how you can get a financing to the projects and all this. But I think financing, before that, I just talk on reality, we are talking about hydrogen. Hydrogen is not a new word. Everyone knows that green hydrogen. But where is the off-taker? Before producing anything, everyone talks about 35,000 crores, 50,000 crores, 1 lakh crores. But where is an off-taker? Do we have off-taker? Everyone comes and says that we want to set up a hydrogen plant. And of course, fancy rosy words, they talk about setting up a manufacturing plant. Where is the demand? If you have a demand, you can supply, correct? So in rest, everything will follow. So are we going to create bankers or investors that confidence investing in hydrogen? Yes, hydrogen is a future. There's no doubt in that. But are we going to create that confidence? People say that banks are ready to give investments, like World Bank, Asian Development Bank. I had multiple meetings with the ADB. They are ready to fund. Investors are ready. Green bonds are ready. In fact, gentleman is here. We had a meeting with the EY in Poland. They are ready to get investors. But where is an off-taker? You're going to set up your plant here, ammonia and all this. Where is an off-taker? That's the first question we need to answer. The rest, everything will be followed. We have to live in reality, not in dreams or this thing. And World Bank is there, and ADB is in green bonds, public-private partnerships. I really appreciate there are few companies that are setting up 2 acres, 3 acres land and setting up manufacturing electrolyzers. The cost also is high now, green hydrogen. Then how are we going to get cost below $2? It's a challenging thing. Only thing is, as per our Honorable Prime Minister's vision, Green Hydrogen Mission talks about it like indigenous electrolyzer manufacturing and PLI schemes and all this. But government has to assure that an off-taker should be provided to the companies who are going to come. Without off-taker, you're talking about a green hydrogen production and ammonia, there's no point. Investors are ready and banks are ready to financing, and the rest everything will be followed. So my question is, where is an off-taker? Hydrogen is the future, but we need to identify off-takers. If there is a demand, we can supply. Without demand, don't say that no, we'll supply. What you will do with that? The cost will be high. There won't be any person to buy it. Export also, we are going to export. But again, the cost. How much are you going to export? India is a country where you can produce and we can use it. We have plants here, fertilizer plants, steel plants. Everyone talks. India is a country where we don't require to export. We can use our own production, whatever we produce, green hydrogen here only. Such a technology we have. But people should come ready ahead that yes, we are going to buy hydrogen from you. Show us at least 4 or 5 like that. Each state should have at least 1 where an off-taker comes and says that yes, I'm ready to buy. That is the confidence will be given to the person who is a company who is going to invest. And government should come with their incentive schemes. Incentive schemes doesn't mean that how are we going to provide land. That's what our Honorable CM yesterday spoke. Because I am part of bringing investment state of Andhra, we are showing all the ports. We have longest coastal corridor, we have 1,053 kilometers, 6 operational ports. We are showing the lands to the people. People are coming, yes, we are going to invest. If you see our office, NetCap office or our office, we have many hydrogen proposals are there. But we rely only thing is, so the first question asked by who is your off-taker? If you get an answer for who's an off-taker, how long is going to buy, what cost is going to buy, rest everything will be answers, will be given financing and establishing manufacturing units, everything will come. So land is ample, land is available in Andhra. Water is available. Government is, our integrated clean energy policy speaks the best policy I can say that compared to other states. I've gone through other states' policies also. Which state has got longest coastal corridor after Gujarat? Andhra. Everyone is looking, the other third person looks after Andhra to invest. But we want a real-time investors and who has got a credibility in the market in a global level, who can come and invest. But again, the question comes, whether do they have off-taker or not? Recently, I had a meeting with National Green Hydrogen Mission DG, Mr. Abhay Baikre, sir. We have 15-20 minutes discussion. We discussed only thing. Everyone talks, Karthik, but as you said, there is no off-taker. When they have an off-taker, then only whatever we talk, whatever we do, it'll be on real, it'll be on ground, and we can produce. Production, no problem. But only thing is off-taker. Who is going to buy and what cost is going to buy? A technology we have, everything we have. But people should start producing, but identify small off-takers who can give that and start producing, and don't ask for 1,000 acres, 500 acres and all this. Start producing in 2 acres or 3 acres. Show the results. I've been to a Hygenco plant in Jindal, JSW. I think the earlier panel, he spoke. They actually have an off-take with JSW, they're doing it. Now we have here on Mr. Anil.
Can we go to other speakers also?
Yeah, we'll give, I'll give. So here Anil is there. They're also producing green hydrogen train. So they are not talking big numbers, but what is exactly is required now, they're working on it. So off-taker, so we need to find out the right off-takers for bringing their costs down and indigenous manufacturing. Thank you.
Yeah, I just want 1 minute for you. See, basically, there was a renewable portfolio obligation or a purchase obligation. It was a purchase obligation. So therefore, the renewables moved, actually. Yesterday also, we had a discussion together. In fact, we talked about the green hydrogen obligation. But I'm saying, why green hydrogen? Hydrogen obligation itself. Because you have to go to the intermediate. You can't jump from gray to straight away to green. So the blue is the way forward. I have discussed this with Tarun many times, and Tarun Kapoor agrees with me. He keeps telling me that, is there a way out? So I can tell you there is a movement going on. I hope the government can bell the cat in this case because the pain I can understand. Because if there is no offtake, there's definitely no investor. We both know it.
You should be an advisor to the governments.
How can I be unless
No, that is what, you said, you're going to get investment.
Oh, yeah, surely. That I will do.
Yes.
But I'm saying they must listen to the right minds. That's all. There's no barrier.
Our state, and you have seen our CM yesterday. He is a
No,
person
he's
who
very clear. He is very clear.
That's
The
it.
very
You start
few
with
chief
one state.
ministers.
You start with the state of Andhra.
Yeah.
Alphabetically also, we are number 1, A.
Yeah.
So start with Andhra.
For sure.
Am I right or wrong?
And we just had Dr. Kamalakar Babu is a good officer. Vijayanand is leading you. So there is no...
Who said he is a good officer?
I have said no.
He is an energetic man, an energetic, dynamic leader.
Absolutely. So we can do it. We can do it here. Now comes the next question. I want the next speaker, Mr. Rajaram, to come in here because he's been waiting. So my question to you, sir, from this perspective itself, but from your technology area, did you face problems in raising capital and investment in your business when you went forward? You met bankers, you met financial institutions. Because let's be clear, in this session, I'm trying to take something out of this, what we are facing. Because in the case of CBG, when we brought the policy, the first thing was we wrote to the Indian Bank Association, because that time the Secretary Petroleum told me, Professor, the biggest problem is we have done the priority sector lending in this, yet the banks are asking for additional collateral from the CBG owners, 50 crores additional collateral. Will he give his house? So these things we have faced, and I keep facing this even in solar and other areas. So let's be a little bit open so that we know what's the problem here. Yeah.
Thank you so much, Mr. Gopal Krishnan Iyer. See, to your specific question, when you have a proper business case, which clearly demonstrate there is as Mr. Karthikeyan said, there is an assurance for my, product which I'm going to produce, and then someone going to consume it and going to pay me a right price. And then a long term, my lifespan of that equipment or maybe that plant. And until then, my risk being mitigated by, his assurance. And then we have a proper business plan. We never find any difficulty. And then, the banker, when we talk about banker, or as Mr. Anil also was talking about, there are a lot of funds, green funds available where we really can tap them. But only thing is our business case should be very strong enough that, there should be, my risk is completely eliminated by, off-taker or maybe a consumer. And then, the cost of a technology really allowable, and then my IRR is reasonably okay, then, it's not a big deal. That's how we raise a lot of capital. And then a lot of institutions available, but the only thing is, again, your company should have a strong balance sheet, and then you have a great history, and then people will definitely believe. If a newcomer coming will be a challenge, but again, when we seasoned industrialist, which we already have it, and we don't really find. But as, always we are in a business, we always look at, we don't want to invest too much in a technology. We look for academia and then other industry who can give us a technology. We will be will play the role of an integrator, would like to invest money, would like to look back our money. And then we really don't find a great challenge in getting money. Yeah, thank you.
Wonderful. See, again, I come back, it's always square. The question is missed, the cost of finance. So I come straight to you because you're from the Brookfield and you've done something in India and you are a neighbor to me in Mumbai. So please answer this question because your company is investing all around, taking assets. So your perspective is very keen and very important here in this forum. I would like you to throw light, Mr. Reddy Sab, on the success of how Brookfield has done it.
For these questions that Anil has answered, yeah, what I mean to say is that it means around 10 years back, it was the story in renewables. The bankers were not ready to give funding more than 10 years. Then later, they funded for 12 years, now 15 years, now 25 years also, they are funding. So it's the banker's confidence actually. Even though investor is having good, means strong credibility, but most of the investors, they're looking for non-recourse financing, not on the balance sheet financing. So for the flexibility in the market. Actually, I told you I was in SECI. Why SECI became a commercial company? Because all the investors came to government of India, said that someone should be there from the government of India in between so that our investment will be safe. So then only it started actually. So similarly, now SECI is doing a good job there in intermediate for the green hydrogen tender. They're doing. These are the things, but the domestic lenders mostly they would be safe on whenever they want to fund. Based on the robust contacts only, we can get the financing. As Brookfield, we do have leverage to global and domestic financing institutions, but the story is same everywhere. We need robust contracts. As Mr. Karthika is saying that we need the proper offtake, long-term offtake. That is the main thing.
The question goes back to Pillai Saab. I would engage him because he's spoken less. One question last. So before we, because most of the things are covered, but still, want to give you an experience which probably you can link with this hydrogen also. See, the pump storage also the same story. Offtake came because, to the credit of the government of Andhra Pradesh, the team led by Vijayanand and this Enred Cap and all these people, great, because they literally listened to the advice where I said a discovered price on the grid is about 4 rupees 30 paisa for base load. And for peak load, the discovered price was 6 to 7 rupees. So in fact, Greenco has taken a major risk without a PPA to bring this project up. So it is the first of its kind in the world, not only in the country, that the concept of PPA is not seen. And they build this whole mega crore assets with the confidence that there is a market because it's an electricity market. There's an offtake, there is a discovered price. And I can tell you this price exists throughout the country. But we are still going towards that reverse bidding and tender. We are wasting our time. In fact, this country should go and agree to a standard grid price and then call 10 companies. Then after the 10 companies, don't give them, put a quota that iske upar nahi hoga. You create 100 businessmen to do the job. So why can't we do something like this, innovative in the hydrogen? Because then people like me will bring mega fund to you. 10 to 20 billion, no big deal, sir.
Maybe Bharat can start with that. He has been with SECI, so maybe the reverse auction and all that he can start.
But I'm saying, I'm ready to support the government. I'm saying
Maybe
10
Bharat can
billion,
start
20
with this
billion,
and
25 billion, you tell us.
Yes, sir.
Sir, I want to just correct the thing. The Greenco case also partly PPA supported because I was involved in that solar plus peak power tender. The first peak power tender, it was designed for that. Based on that, only funding happened.
No, I'm talking of pump storage alone.
For pump storage
Pump
only.
storage is
No,
PPA.
for pump storage only. For the same project, I was involved in the means arranging the PPA and also something.
It came much later.
Okay, so in the green hydrogen also, we can think of having some agreements like that if government can come and give some support. like that. Earlier, yesterday you were telling the solar story.
Yeah.
So where it started from GBI. In spite of having all the incentives right now, hydrogen is having ISTs, waiver was there, capital subsidy was there, everything was there. But even that it was expensive. Then GBI was there, generation based incentive was there with some subsidy. And then government supported some VGF also. Okay, with that solar became cheaper and it became so cheap. Now government started plugging out all the incentives and loading. Okay. If you remember the green hydrogen when we targeted for $2, the price of solar price was around 1.99 was the bidded price.
I know that.
The trajectory was it will touch around 1.4 or 1.5. If government of India might have not included the BCD
Exactly.
or increased the GST, it might have been the reality. It might have touched 1.2 rupees also, that the $2 might be viable. Okay, so I recommend, sir is there, Pillai sir is there, if we can take that into that direction, just for 3-4 years or 5 years, if some incentives where solar was given, the same incentives if green hydrogen might be given today, the commercialization will start from small scale. And once it goes to the bigger scale, they can take back those things. Okay.
Right. So wonderful. I'm closing this because organizers ended up telling me that lack of time. But Pillai Saab, last word for you.
No, I just feel that green hydrogen today is looking more and more practical and doable. And the reason is, I mean, in the one of the last sessions, there was a graph that was presented which showed a quadrant of 4 types of possibilities. There is countries that don't have, will be net importers, countries where green hydrogen is not practical at all, countries that have will be exporters, and countries that have that will have a huge domestic market. So initially, the green hydrogen mission was started with a goal of being 70% export oriented, as you know. So out of our 5 million metric tons, you wanted 70% of that, so 3.5 would have been exported. But I feel that given the ever increasing scope of utilization of hydrogen, people are discovering more and more ways they can replace the gray hydrogen. Like, for example, we just had a seminar at IIT Bombay the other day where they were discussing how in fine chemicals and specialty chemicals we can utilize green hydrogen. So I feel that maybe the export market is my personal feeling only, I'm not speaking for the government, but I feel that it may be not 70-30, but maybe 60-40 or maybe or 50-50, something like that. This is what I feel. But I'm thankful to Bharat for giving me the history of SECI and all these things, because at that time I was doing pure solar cell research. So it's nice to get the history of how SECI made the India solar a success story, and I'm sure that India's green hydrogen is also going to be a success story. I'd like to just mention that there are two learning, as you know, there is something called Swanson's law in solar. It states that with every doubling of module capacity, the price comes down by 20%. You will see similar experience curves in green hydrogen production as well as in electrolyzer cost. It's just that the scale at which electrolyzers need to be deployed is something that, I mean, we have given a tender for 3 gigawatts, as you know, 3000 megawatts. And in order to, at 55 kilowatt hour per kg, which is what the original was, you would require about 60 to 80 gigawatts of electrolyzers to meet this target. So there's a huge expansion that needs to take place. And I feel that as more and more efficiencies creep into the electrolyzer market, like already it's at 41, because there's an Australian company which has come up with 41, which is working with one of our India's leading companies. And I feel that in the next few years, there will be some disruptions also, in the sense that electrolyzer may not necessarily be the best way of producing green hydrogen. There may be other technologies also. So I feel the outlook is really rosy.
So wonderful, because we have to close. So I make my last comment here to close. One is, hydrogen is here, and it was yesterday because I told you we put in our engines in MAN hydrogen many years ago. I left MAN roughly in 2000, 2001, and MAN was already putting hydrogen into two-stroke and four-stroke machines. So it's an old story, and I believe hydrogen direct combustion. Last point, I'm just taking off, and then use of blue hydrogen with CCUS. Today, Fluor and Worley, these companies have the technology. But somewhere, we need to absorb technology and bring the cost down, probably to get this intermediate, problem to a solution mode, so that the cost at $2 can really be achieved. That's one area I believe we must focus on, the blue hydrogen. And as somebody said yesterday, and I am always advocating the same, because I had discussion with Dr. Bakre, and then this came up. I said, sir, it was a little tight. I said, sir, अगर आप continuously green बोलेंगे तो I will continuously talk blue also. And then वो फिर सारी खुदाई एक तरफ, जोरू का भाई एक तरफ. It was the Hindi statement. He said, no, professor, we'll also support you for what you're saying. So it's like that. Basically sometimes we have to sometimes shake the government. Like, when Andhra was doing 24 gigawatt, CA asked me, the chairman CA asked me, Professor, how this is feasible, how they have come to 24 gigawatt, how they have ordered. This is a record in the history of India, sir. 24 gigawatt of DPRs done, and orders execution in pump storage is a record. We are not celebrating enough. In fact, NetCap, congratulations to NetCap. Yes. Yeah, I'm saying India is not celebrating. I'm saying, see, because this is an extraordinary thing that has happened.
See, that credit goes to, I think, total identified 70 gigawatt, I think, India storage system, but I think NetCap has achieved more than 50%, almost 40%.
Yeah. So this is what I'm trying to tell.
It is globally also in COP, we spoke in other countries. They're highly celebrating, but of course, now India is, India is not celebrating, then it's not like that, but I think India is celebrating.
No.
MNR is recognized.
No, wait. I'm not talking of that. See, please understand. Media space has not come to this area. Please understand my question.
हमको क्या करना है media से?
अरे sir, करना
6
पड़ेगा.
crore people are there and 150 crore people. That is enough for us, not for media.
Wait. Don't discount anything. See, what happened, understand my story. CA, when I went in, then the confidence came in the CA chairman in that meeting, because I was telling that Andhra is very much on the track and they could achieve the whole 44. Not only that, I said this is only on river capacities. I said the off-river capacities are not. This is an example of how we need to also tell the state governments to the center. So we need to go to the center. All our states must come forward to work. Like Odisha has potential. Every state in that area has a potential. Same like hydrogen. So you said you want to create a market. It can't be one state creating a market. It has to be the countries, states and the center together to create a market. So that is the challenge that is in front of us. If you make this happen and have this low-cost finance for long-term funding, 25, I tell you, India can literally cross. I don't say that we will compete with China immediately, but I can tell you we can catch up with them in no time. That's going to happen if we put our act together. With that, I close this session, and it was wonderful to be with all of you, and it's a pleasure to be in such a forum. Congratulations, SRM. Congratulate the organizers and also the government of Andhra Pradesh. Thank you all.
I would like to congratulate our moderator, very well moderated. Try to brought more financing points, and we'll have a more discussion on this. Thank you so much. I'm so sorry for it.
No.
Thank you all.
Thank you very much for the enriching discussions to the panel. I request Professor Gopal Krishnan Iyer to felicitate the panelists, to start with Mr. Bharat Kumar Reddy, LSRE, Director of Evren Energy. Mr. Anil Shrikar, Green Hedge Electrolysis, kindly step forward, sir. I request Mr. Kartikeya A, APEDB, kindly step forward, sir. Thank you very much. Before we break for lunch, participants are requested to collect your certificates of participation available at the roundtable area during the lunch hour. We now break for lunch, a valuable opportunity to unwind and engage in fostering connections. We will resume the next session promptly by 2:30 for the last plenary talk. Thank you. Good afternoon, everyone. Welcome back to the Green Hydrogen Summit 2025. We have had some great discussions over lunch, and now it's time for our last plenary talk. I request the speaker, Professor A. Gopalkrishnan Iyer, to kindly take over, sir.
Sri Gopalakrishnan Iyer is the founder president of the Renewable Energy Promotion Association and the Inertia Foundation. He is also a distinguished alumnus of National Institute of Technology, Kurukshetra. With over 30 years of leadership in India's clean energy and infrastructure sectors, he has played a pivotal role in shaping public and industry discourse on sustainable development. Professor Iyer served as head of marketing at MAN BMW Diesel Power Plant India Private Limited and later as CEO of Indian Odysseys. From 2004 to 2007, he was executive editor and CEO of Inertia, a business journal focused on energy and infrastructure. As a columnist and editor, he contributed to Indian Express's energy supplement business avenues. A critic of COP, Conference of Parties, Professor Iyer recommends US dollars 10 to 11 trillion per annum investment necessary for renewable energy and SDG combined, as it is just about 10% of the global GDP. He has introduced, as of 2024, a brand new terminology for the purpose renewability beyond sustainability, which is now poised to be the future roadmap for the global energy transition.
Hello, friends. I think it's most difficult time for me to come back after that panel, and we had wonderful panels today. Difficult time because you all had lunch, and I think that's the time when a little bit doze off can happen, right? So I'll try to make this exciting because I wanted to take you through what happened into the history of India, and because in the power sector, basically, and in brief, So I don't want to go back to several years after freedom we got in 1947, when I had a very illustrious family background because my grandfather, that is the mother's father, was actually the dear friend of Hawk Larsen, the founder of Larsen Toubro. And until 53, my grandfather was with him. So, in fact, the first time I understood India's challenges was through my grandfather's talk on power. He keeps telling that India's big problem will be how it would run the country because we will need to feed a lot of people, especially not only food, but also energy. So, in fact, that wisdom stood with me for a long time. And I was able to tell the policy and makers that the worst poverty that somebody can account for or see is energy poverty. This term was not used by the international arena until recently because I've been saying that you were not poor by money. You were poor by the access of energy. So India is energy poor at this juncture when I talk to you, coming all the way up, we're producing 480 gigawatt. That is the installed capacity. That's not the actual exported capacity. So how much we put into the grid with that much capacity, I'll make life simple for you. It is almost like generating continuously 250 gigawatt. And that would translate to roughly, when you put the efficiencies in, it translates. I have individual calculations for each power sector. Everything does not. Solar is only 5 hours, 6 hours, right? Wind goes intermittent and at night tapers off. So average PLF is 25%. Hydro is the best because the conversion efficiencies go to 85%. And then you get into, pump storage, which is coming, which will also be almost similar. So you have different efficiencies there. Thermal power will be about 55 to 60%. Actually, it's not more than the thermal efficiencies are at 40% alone. Even in the ultra mega, 42%. So basically, you're not seeing what is the installed capacity going into the grid. What you're effectively seeing is about 250 to 260 gigawatt, and that will reflect from government's last data of peak energy demand. So peak energy demand hasn't crossed 255 gigawatt in this country. So if you translate that, it will be roughly 2070 terawatt hours that we produce. And when we divide it by our population index, we come to just about 1400 kilowatt hour per capita consumption. And that is very poor because the European Union is in the region of 6,000 to 7,000, China also beyond 6,000. So if we compare these two, then I think we are not there, and we cannot compare with America, but they are at 12,500 plus per capita. So we must really know that we are energy poor. And this question, actually I addressed in the release of my book, 2003, first book when Kalam Saab wrote, Dr. APJ Abdul Kalam, everybody knows as Missile Man of India. And he wrote a beautiful book called India 2020. How many of you know about this book? I don't see too many hands, but okay. So that time, there were some poor people like us who also wrote a book, right? In the similar breadth, but different. I wrote a book called India Brandished along with my late brother, Prakash, who's no more. He was physically challenged. He had polio on his lower limbs, and he had to spend his life that way. But he was a great guy, great ally in research. So we delivered a book called India Brandished, Superpowering Brand India, 2003. In that book, when I wrote the book and I released the 5th edition in 2015 in Delhi, it was Chief Minister of Uttarakhand, and then Defense Committee Chairman in the Parliament, Bhuvan Khanduri, I spoke in that India will not achieve $5 trillion, because if we have to achieve $5 trillion, we need 600 gigawatt on the grid. Now you will see my position being endorsed right now. We have 480 gigawatt, and what we are producing is an economy of 4 trillion. So you can see the energy economy connect there. And this is what I wanted to talk to you guys, because we will talk about hydrogen, we'll talk about other things. But that's all. The emergence of this is the next stage, right? So it comes from the fact that we do not have access to energy. And if you see that demand, the demand is so skewed that predominantly almost 56% of that is used by the industry. So the next is basically the agriculture sector, about 17 to 20%, right? And you go down the line, you'll see government is the biggest consumer then. Government and institutions. Then what is the domestic consumption? It's nothing. It's barely anything, you know. The load will be not more than about 15 to 20%. So what effectively happens that demand for energy for economic activity is increasing, but household consumptions are going down, but they are the guinea pigs, because the tariffs are being raised for the households. I pay 15 rupees a unit in my place in Dombivli in Maharashtra, which is the highest per capita or per kilowatt hour tariff in the country. While we have states like, I think Andhra would be about $7. Yeah, Bangalore would be about 8 rupees. And these are all average half of what we in the MMR region pay. And the surprising part is, you will be shocked to know that it is not the private sector. I am in the public sector domain. Mahadiscom, MSCDCL is a public sector organization. So the big daddies, whether it's Adani, whether Tata, anybody who's operating in the Mumbai metropolitan circle, have a tariff almost 8 to 10 rupees. They are lower than what I'm paying to the government body, right? And MSCDCL supplies power to the whole of Maharashtra. So you can sometimes get into the dichotomous situation if you don't realize what is happening. And that's because it's easy to cross-subsidize. And then the urban consumers are the easy target to be uploaded on this. So industrial people have lobbies, and they will go and they will get their tariff down. And every lobby will get it down, but there is no individual lobby for households. So I am trying to go to the regulator in India shortly. I think our friends from MNRE and all are here. So they will see me challenging them on whether Attak to Katak, Kashmir to Kanyakumari, can we have one domestic tariff? And if we have a differential tariff, urban and rural. So then only we can call ourselves a one grid, one nation. We cannot call ourselves a one grid, one nation if we are not giving our common consumer a chance to get decent quality power at affordable price. Now, why I use the word affordable? You all must be reading the Sustainable Development Goals. I'm not getting into teaching you this because you will read, but you go to the inner philosophy of the SDGs. The driver SDG is energy or power together. So if every activity needs that. There are some activities like hunger. You'll say, how would you satisfy hunger? How would you make a business case of hunger? Can we make a business case for gender equality? So these things will happen, but all of them dependent on certain SDGs that stand, and they have a driving force of energy. You want to look at sanitation, it'll be again energy, because you can't use your municipal operations cannot happen without energy as an input. So if this is clear, then we must know that we are not using that word affordable access to clean, green, renewable energy. That is SDG 7. So have we satisfied Sustainable Development Goal 7? The word is affordable. So if the planners and policymakers miss the bus here, the word affordable, they go on increasing the cost. That is a challenge for the Indian economy, for sure. And also I can tell you when I'm sitting here, every case is given to me of rich countries. They'll say, Germany, this is the tariff. I also know. My friend is sitting in Ingelsdorf near Nuremberg, and he has put a rooftop. At the age of 65, he gets benefited from his rooftop. But at the same time, he says, they buy my power at a lower cost and sell power at a higher cost to me, right? So it's happening everywhere. But do we follow this strategy in India? No way. Don't do a monkey see, monkey do. Really come into the fact that your domestic consumers are just minimal. They are not much. And then we can definitely support, because they are the ones, when you go to the land banks, you buy the land bank, you get a policy dimension, you want their partnership. It's a masses partnership. So the real, if you want vote bank to come in, real vote bank, I tell, if any politicians hear this, their best vote bank is give electricity access 24/7, give water access, and give other resources access to them. Then only you will bring them in. I'll give you a case study. This was when Gujarat was in the early days, and we all know yesterday, Honorable Chief Minister Andhra Pradesh said that we are the pioneers in the reforms, and it's absolutely right. I was part of that whole story and constantly worked with officers like Vijayanand and at Center, Mr. Tarun Kapoor and others. And I've seen that Odisha model and Andhra model were the early models, for sure, for reforms. But there was another model that came in, which actually emanated with my officers in Gujarat, like Dr. DJ Pandian, Maheshwar Sahu, his senior. So what I said, they must separate the line systems for the rural economy. And that resulted in a very interesting policy construct. What happened is the farmers came and said, we are ready to pay for the power, but we need 24/7. Now, 24/7, it was difficult to put in because they had their pumps also. So when the pumps operate, 3 phases required for the pumps to operate. Agricultural pump set need 3-phase power, right? While they could do 24/7 on single phase. So what they did, they separated these two ideas. And another thing was, one of my dear officers, Mr. H.S. Patel, was a fantastic man. He was a MD of DGVCL, Dakshin Gujarat Which Company Limited. He made a massive research. He said these farmers are very angry with us because we end up waking them up at 2:30 a.m. in the morning to put water into this soil, So basically, they would operate that either through electricity or through diesel. And I found that diesel subsidy was going on there. So this would happen at 2:30 a.m. If the electricity comes 2:30 a.m., otherwise he will be operating a diesel pump set. So they said, if you can change the timing to around 5:30 to 6, we'd be thankful to you. And they did. It made a massive difference. It made a massive difference to their lives, right? So small things can change the destiny of people. And then the energy access 24/7. Gujarat was probably the first state to tell its farmers that you pay $150, rupees 150, and we supply the single phase 24/7 to you. And it happened. And then I can also tell you that the same policy, when I had talked with some policymakers and electricity fellows, including CSE in Kolkata, it happened in Bengal as well. 18 hours of supply happened to rural economy, and they won one of my awards also for doing that. So it's like, it's not just 2 states, other states also following the same suit. Maharashtra has done the same thing now, because the biggest thing is I came from the pump. When I started my career, it was with a company called Jyoti Limited. It was the mother company. And the great man whom I worked with was Nanubai Amin. Nobody in this country takes his name, but I'm ready to take his name here. He was the first man to build a water pump in India, imported it from Czech Republic and replicated the pump. And how it started, there was a company called Alembic Chemicals Works in Baroda. Alembic used to make that, glycodine, which was for our throats, right? Those old one. People from that era will know. Glycodine used to be the cough medicine. And what used to happen, this plant had many pumps, the process pumps and all. No repair. So Nanubai started telling his brother who owned the plant that, why don't you give me the repair business of the pumps, right? So he got the repair of the pumps. Then he went from there to water pumps. And that time, Kirloskar was only in the farm equipment. The great company, Kirloskar Brothers Limited. It's a 130-year-old company in India, right? It's a technology company, according to. So this company was not still into the pumping sector. It was Jyoti Limited, Baroda. And they made all type of pumps, vertical turbine pumps, all water system pumps. And Nanubai was such a guy. He was so prolific that he demonstrated rooftop solar in 1947. 1943, this company was born. 1947, he had demonstrated. He made a solar cooker. And he also was the man who founded ERDA. How many of us sitting over here even know this history, industrial history of India? So this is what you, young generation, it's not about only reading about our other things. We must know about our industrial history. I'll give you another thinking shot here. How many of us remember Dr. C.V. Raman, the great man? Yeah. And now, what is it that he invented or discovered? He did not invent, he discovered. He was traveling on a ship. How many of you know this? When he saw the yes. So basically, he was traveling on a ship. He saw the refraction of light, and he explained that effect. It became the Raman effect later on. I'm making life simple. I'm not getting into the complication of the Raman effect. We are not here on a thesis. But then what happened later? Are we giving any credence to Raman for the evolution of the photovoltaic? Because Raman effect comes down, piezoelectric effects comes down, and you say, so the mother of that whole theory came from Dr. Raman's work. And we don't. We in India don't celebrate Dr. Raman, the great Nobel laureate, and another man from a different field. We don't remember him. See, plants have life. This was a great botanist and physicist combined. It was Dr. Jagdish Chandra Bose. He's remembered in Germany, but not in my country anymore. It's so surprising. So please wake up, my friends. Start remembering these people, because he said plants have life and they do things differently. We have a bloodstream, they have a different stuff, right? So I think youngsters sitting over there, this particular part I have given for young people in SRM University, that they must get into their roots and have a scientific temper and blend of mind, so that if they can nurture this, feel proud about what's happened and learn what they did and probably go forward, we could deliver more not only to Indian economy, but to the world economy. See, the importance of India is we were leaders always of thought, we were leaders of spirituality. We were also leaders in science at some point of time. So what happened to us, right? So did we miss some bus that we are doing run-of-the-mill researches, run-of-the-mill work? So we need to come out of this run-of-the-mill researches, and I think we need to improve our quality. I go to my NITs and I tell them that you have to increase your quality of work. PhD scholars should do much more to work on it. They must commercialize their work. They must forward to that. And there's always a way to commercialize your work. If you have a proof of concept, then I can tell you the next thing is we must push our governments to say that if it is deployed, then I get a small return. That would be the best way, instead of trying to sell our technology just like that. In fact, you give it to 5 companies, 4 companies are allowed. You take it to market, and then you get something when it sells, you get a kind of a royalty. I think we should follow what Europe did long ago. Probably they must have forgotten what they did, but we must try to replicate this model and bring more number of people into these systems, whether there's energy, there's the power, there's the infrastructure. I was just having a chat with our friends sitting over there, and we discussed what? We were discussing slag-built roads, right? So it is not a subject of hydrogen, but we were discussing slag-built roads, because several years back, I met somebody who's a dear friend, and the gentleman over there is almost a replica of my friend Jeff Kukura, right? So we just had funny discussions. We had lunch. I missed 5 minutes late. I was here, but luckily things did not start. But that's the type of thing, So don't think about one area. Slag-built roads will need a lot of energy, again, because the input of energy comes in everywhere where you go. So if you have to build slag-built roads, then you must look at the energy part of it, and it must be made economically viable. Already 1 kilometer of this road has been put in Hazira, in Gujarat. And my first visit was to the SR steel plant almost 20 years ago, when I told them that you have mountains of slag here, you must convert. They were ready, but I think they did not get any incentivization to do that at the time. But now, after 20 years, we see just a pilot project of 1 kilometer of slag-built road coming in. But I'm happy, because concrete roads are environmental disasters, because you end up putting in more energy in making that stuff, right? Whether you make cement, you make steel reinforcements, you put the concrete in, and we are not using too much of bitumen here in this country, because we don't have access to it because of the market dynamics. But bitumen would be the best material to actually make your roads live long, So, but right now we are not able to do that. So we don't coat the surface, otherwise the quality will not come in. So we have challenges everywhere, and all of these go back to the petroleum industry, will go back to the energy industry. Anything you touch will go back to the energy industry. So my point in all this talk that I'm giving you, so just from all this that you saw on the Hydrogen Summit, on where it will go, I wanted to give you a larger perspective on energy and electricity. This part is very important. And I will also tell you that, as I narrated some time back, that we used hydrogen long ago at MAN, and our friends were asking me whether I can get the book. I'm working on a book called The Return of the Zeppelin. It's a book on hydrogen. So how many of you know what is Zeppelin? Yeah. So decent number on this side, but people have not heard it. Yeah, you heard it. Okay. Pre-World War II, Zeppelin was an airship, and it would travel at about 150 to 200 kilometers per hour, unlike planes that could travel to 800, So it look like a balloon when it goes, when people watch it, because the speed is not as much. But the beauty is, it was run by hydrogen engines, and these hydrogen engines were reciprocating engines in design. So that is the pre-World War II, when Rudolph our great guru was alive, Rudolf Diesel. I'll tell you the story of Diesel after this, So Rudolf actually was part of that entire design. And this Hindenburg, this company was named, not this Hindenburg, not the American one. Okay. The new Hindenburg is more like the stock market fellows, right? I'm talking of the Hindenburg of that era, which owned this technology Zeppelin. And Zeppelin was so successful until they made the blunder because they allowed everything to happen inside. And hydrogen is, literally, it can catch fire in no time, right? So what happened? Everything was happening. Like you drink, you booze, everything was happening inside. You smoke cigars. So one fine day, that big accident happened and Zeppelin went down and all were killed. And then that accident was put up as, oh, no more this airship. The game is over. And it was great because the moment they did it, they left hydrogen in the LERS and it's gone because it was successful. That was the only accident that happened. It was not like multiple accidents. We have had so many air accidents. I don't have to tell you what happened recently, right? But we questioned Zeppelin. The whole world said nothing doing. We'll not use this. Nobody discussed how hydrogen can be safely used. And this is pre-World War era, my friends. So today we have airplanes. They're moving. It's fine. But are they the real means of transport alone? So I don't know. No, there is a thinking going on in India because I have friends in the airport authority and in the government on that side. We are talking about 25 to 30-seater aircraft already. And these 25 to 30-seater aircrafts will look at airstrips in India that have not been used. There are so many airstrips which are not used in the country, right? So to energize those airstrips and to use this is a good idea. But I would still prefer a bigger plane, maybe 70 to 90-seater. And I can tell you the country that can provide me this is Brazil, for example, Embraer. And they can put a lot of this, blending of ethanol into it. So we must all think on what markets we can do and how we can work. Probably we need to invite these civil plane manufacturers now. Time has come that we just don't buy these big planes and then say commercially unviable and we don't get into short routes of less than 1 hour with these bigger planes. I don't think it makes sense. So a cross-dimensional thinking has to come into my, government and policymakers, feeling which, they would use piecemeal. It's those 9 blind men, 9 to 11 blind men and the elephant kind of model. So we need to be very careful about the future because we are moving in all directions. I'll give you one more example. I'm happy that the government of India has picked my point up. I said, why not food be sold in calories? Because this idea came to me when the farm crisis were there. Farmers were sitting minimum support price. I also wrote to Supreme Court that they must be given some minimum price. I was supported by Devendra Sharma. He is the master of the entire game. He is one of the best agriculture scientists because he was under trainee of great MS Swaminathan. But I brought a new idea. I said, why can't we get food access in calorific value, right? The calories of the food. So then it becomes energy. So that brought that idea called, the government is saying, ki kisan urja data hai, annadata nahi. So that part came from what I said, right? So it's very interesting. So I've been talking to Shripad Yeso Nayak on this, and I'm happy that they're using it. The government is using this point, but they must go back to what I said. That is, whether we can find a method that nutrition and calorific value in the food becomes the energy point of dimension of living. So this looks simple, you've heard. Now all of you will understand where it is going, right? And what happens? All the waste, agro waste is being converted to bio-CNG. We are celebrating 108 CBG plants in India. When I started it, only 11 plants were under construction. One was operating for 10 years in Maharashtra, about 4.5 tons at Varanagar. So Satat was made in 2018, but Varanagar was operating before that. And then 2021 policy of Satat Plus, that how to, energize this whole thing. Like we had this discussion. So I'm trying to release a white paper on hydrogen itself because I will not talk only of green hydrogen. I'll talk of the hydrogen economy. So we need to make the life simple for people to come to terms with these kind of challenges that are in front of you. So I'm very confident after this learnings in this summit, hearing all of you, and also seeing the other perspective. We were working on it for a long time now, almost 6 months. In fact, the last year I started working on this hydrogen thing. I had meeting with people in the government, and I was completely not convinced about only calling green hydrogen. So I'm happy that somebody said clean hydrogen. So it makes sense to me. Clean hydrogen is sensible. And we must commercialize this. We must find ways and means to get this to the ground. So every place where you go, like the farmers, if they don't get more money from other sources, so what is the new money source for them? It could be
their bio-waste, which goes into making CBG. It also could be their animal husbandry waste, which is the cow dung, buffalo dung, huge biomethane there. So I can tell you we are already deploying this. In my Rohtak plant of Spectrum Renewable Energy, which makes about 8 tons per day, and with an input of 250 tons per day, which actually use the Evonik membrane, who are our patrons, in REPA. So this technology, the latest technology was used. It was commissioned about 3 years back, 2022, they got my award. And this plant is very successful. It started a 7 ton per day design. Now it's, I think, delivered between 8 to 9 tons. And early plant, they also got, from the government, they were allowed a biopump on that highway which connects, it's called the something like Kundli Manesar highway or things like that. So from Rohtak to that place, they have got a pump, and now they are dispersing in retail. The beauty that that project succeeded was it hybridized cow dung, buffalo dung with the waste biomass, which was coming from press mud, the sugarcane press mud. So, and then they did not have any chance to use the spent wash because they themselves don't have a sugar factory. So they used only these two items, and they fixed a price for the waste. And that was interesting because they started giving rupees 2 to rupees 3, roughly that region, per kg of gobar or cow dung, or buffalo dung. And farmers came doing it. But I have a different plan for this, which I think our friends in MNRE can hear. I believe that you can think of, these goshalas and all are not the right method to do it, but there is a different method. We found out because we did a plant with cow dung, 1.4 megawatt, and we delivered it in Bilaspur in Madhya Pradesh. And this guy had 10,000 cows and buffaloes, and he's still producing power. It is using an engine from MTU, which is another German manufacturer. So this was done in 2011. They got an award. MTU got an award from me for delivering that technology in India long ago. So I can tell you from my experience that's making power. Experience is 55,000 of acre of land, you can do captive grazing for 10,000 cattle. So if the cattle is no more producing milk, the cattle can still produce, the buffalo, the bull can still produce its dung, right? And it is clearly an energy product for us, right? So if we think of captive grazing, which actually has happened at my place in Mumbai, there's a Goshala fellow down, he came from north, and this fellow's milk is very good, So he has some 10,000 cows and buffaloes, and he is using captive grazing, not for this purpose, but he's using that so that it doesn't go into other areas and start eating the fields over there. So innovative thinking is required. So this captive grazing could probably give you access to cow dung in good quantum. So I don't know how this will be delivered in land which will be equivalent to my requirement right now. That means we add straight away in 2 or 3 flat years. And this, I'm ready to help the government of India in a policy construct which can do this, because we need to involve the farm sector. We need to involve the panchayats. We need to get the 10 acre of land in each gram panchayat registered like a farmer producer organization, because they cannot invest, but they can give us the land. If the land goes into a farmer producer organization for the village, what happens is they can be part of the exporting of energy into the grid. And I can tell you, massive revolution is waiting to happen. We don't have to go the China way, only creating big parks. That time is over. That era is over. We have shown we can do it, right? Now the time to be practical. And I will connect it with CBG and also hydrogen, because all the farm waste can get into you. If you say every 2 villages, I can tell you our calculations are there. We discussed with Tarun Kapoor long ago. In fact, I was of the opinion that every village can generate a 5 tons per day output of CBG. If you don't want it as CBG, you can convert that to hydrogen. But even if we discount it by 50%, we have 300,000 villages. Why I'm saying, because my friends from abroad will not understand lakhs. So 3 lakhs, okay. So 3 lakh villages is 300,000 villages. So if we produce it, I can tell you only 30% of it we will use in the Indian economy. We will stop importing gas in toto. That means all that billions of dollars of bill is gone. And we're going to use this for our automotives. For God's sake, don't go to electric vehicle, because this is the route to extend the life of our IC engines. And the moment they do it, your engine is also going to be ready for hydrogen. Because if you put CBG in it, you have the hydrogen in it. Next. So we must not go to electric vehicle cycle. And I wanted to give the answer first. People talked about, our friend Mr. Malhotra was talking about the hard facts of missing out the bus going to electric vehicle. But I'm telling you the raw facts that come in. because this engages my rural economy. This reduces my import bills tremendously. The calculations are mind-boggling. And I can tell you that we still have 70% of the output ready to go as exportable hydrogen or to be used in the market. So this is also green hydrogen. How it is anyway different? The only thing is you need to do the marginal, I would say it is called micro CCUS. So probably we need to work on in universities on delivering micro carbon capture. That could be an area to work on. So this is another, see, this hybridizes two items. One is you have got the solar, which comes about 5 hours. Then we need 24/7. So either we can also go to the route of hybridizing this with electricity production. See, that means if the village, some villages say, okay, we are ready to deliver electricity. So let the electricity come. So what is the policy construct? The government should not be tendering on PPA and all that. The government should work on grid discovered price. There are two discovered prices. One is the base load price, which is throughout the country between 4 rupees to 4 rupees 50 paise. And there is also our energy exchanges. They are discovering we don't go to those prices because they are very highly fluctuating. But I'm saying a standard price, every DISCOM, every state transmission utility will have these figures. And the regulators have the figure. A second part is peak. So that is what Andhra has discovered. 6 to 7 rupees is average throughout the country. So whenever you drive the peak power, you buy at that price. Whenever you drive the base load power, so why do you have to do a tender? You have to go and do a tender that who's coming and delivering this, and the 4 rupees price is a very attractive price on the grid. And I can tell you, immediately the energy crisis of India will be gone. The solution is given in Andhra Pradesh. That's why probably the Chief Minister, Honorable, said that this is a landmark meeting. So I am the last one speaking on this issue, right? So probably whoever is sitting there will send the message and it will go. I'm very sure. So Andhra can start first. Probably it can adopt this plan for its villages to hybridize these two and go towards, while we have got the Quantum Valley for computing, we have got the Hydrogen Valley going on. Why don't we convert every village into an economic, I would say, behemoth, literally, powering the economy of urban centers, rural centers, and everything together. So they are our Urja Datas. And this is my fervent appeal in this talk when I make last to everybody who is here, who's understood, go forward. And this could make many businessmen in India and many micro businessmen from overseas and many people who can invest little bit, and make things happen. It's not about only large investments being attracted. It's about how we make a market for energy and electricity. So it is important to make a real market for this. It's a product. It's a commodity if you look at electricity. Because what the exchange is, when exchange was born, when Rajesh Mendrita first met me, he had no clue about how to do it. Those days, we had helped out. Of course, they have forgotten it. Then they went into gas exchange. But I'm not very happy with the gas exchange. They will do minuscule business and it will not come out big for the country, because we need much bigger. We need multiple exchanges if we want to create a market. One single exchange cannot help us because it delivers monopolies, duopolies. Today, what happened to the airline industry? Technically, we are in duopoly. We have 2 airlines now. And we had so many airlines in the past. So a duopoly increases the price of the ticket, right? So wherever you go, you'll see what happened to telecom also. We have now 2 major operators. So we are in duopoly. So wherever we create this duopoly, by accident, by default, by process of so many things, NPS happened, whatever. I'm not getting into the blame game, who did it and what happened. But we are in reality living in this era of duopolies. So India cannot create monopolies and duopolies. India must create a larger global economic dimension. I'm sorry, I may not agree with President Trump. He keeps trying to be protectionist, right? He can continue, but his is an era. It will be gone for us as far as we are concerned. 3 years is no time in history. But I can assure you that democratically, the way Europe is thinking, the way India is thinking, the way others are thinking, will take us to larger markets. And we have to, and even the Americans, see, most Americans are highly democratic. So energy is a democratic subject. As I told you, energy poverty is the main issue that is actually going to be the challenge for the future. And with this, I come to complete end of my talk, because I can go on talking, but I feel that you got enough masala for your state, for your time. And anybody wants to ask me any questions, only 1 or 2 or 3, according to the timing. Otherwise, it's okay with me. Anybody? Yeah. One hand has gone up. You can give the mic to him, please. Don't be worried. I'll answer all your questions. This side, somebody. No, not you. Okay. Somebody raised the hand. That's why I said. Anybody wants any questions? Don't worry. Here it comes.
A great talk and very impressive. And clearly, without energy, there is no nation, there is no growth, there is no power. Yet we face so many hindrances, right, from policy. What's your view on state versus center? The minute you talk about a grid which is aging and every state is going to fix their own, we know it's an unsolvable problem. Any wisdom on that?
Yeah, see, the interesting thing is I also run another foundation by the name of Marconomy Foundation. So today it was not the subject, so I didn't talk about it. This foundation actually works on GDP tracking for the country. We have built a plan of 13 trillion economy by 2032, which I know again will be missed if we don't look at the energy train, which I talked about. There's an energy factor to it. We're talking of something like 1 terawatt worth of installed capacity plus, or rather 1.2 terawatt to achieve that economy. So I'm connecting it with electricity right now. But the energy part is very important because we have heat. We use heat. People are not talking of heat. Nobody discussed. So one of my friends is doing a small experiment to run a vapor absorption machine in Gujarat. And this fellow is a fantastic guy, Mr. Deepak Gadia. He is known because he started cooking, this rice in all the devasthanams, the religious places. So this guy is trying to run a vapor absorption machine, and there's an Australian company which is actually with him because he lives in an ashram. He lost his family. He's no more. He's alone. So he lives in an ashram and does it. And he has successfully driven an air conditioning system for a hospital. So these are the islands of success. And his dream is, he says, before I go, Professor, because he went into a situation where he lost his life, he came back. He said, now, before I go, what I want to do is this 1,000 acres of land, I want to take it away from the grid. So these are people who are also working with me. So if SRM or anybody wants to access this type of stuff, they want to strengthen, and mind-boggling, they are solving this problem. So why I come to your answer to your problem is policymakers must understand if they are working on the economy, they have to work on energy and vice versa. Now, in energy dimension, we cannot relegate our agricultural economy away, which was a blunder in the past. And I gave you the solution to that today, right? Which I'm actually putting concrete on 6th of August in Mumbai. So I'm very clear that I believe that we have to find a solution to integrate the rural sector with the entire movement of the economy and then ensure that they become participants than being opposition to your growth and development. This has been the challenge for India all these years. I feel policymakers and politicians, if they only work on this little dimension, rest of it, we can talk about corruption, we can talk about so many other issues are there. But I'm not going into that because that's not my forte. Neither I'm not interested because that they have to think. If they want to tell the population that we want to go, tell them, आपकी बिजली पानी सड़क रोटी कपड़ा मकान digital connectivity health education ये हम guarantee करते हैं. Show me one manifesto which does it. So this is my problem in this country. So they have not made a manifesto like this. And then I'm delivering another one next year, mostly. A model manifesto for India. So these are my work which are not in the energy domain, these are in the economy domain. Why should we have a political party's manifesto? Why can't we have a manifesto for my country? So these are things which probably the Europe can pick up from me. So that same thing is happening in Europe. Same thing is happening in America. Challenges are very similar. Maybe the dimensions are different, right? See, for example, corruption. Now, I did not touch, but I'll touch. Corruption or pilferage in the economy. I would rather call it pilferage in the economy. Pilferage in the economy, even the World Bank is accepting. I don't want to name the country. They say 35%, 25%. They're writing pilferage in their notes. So that means they've accepted that they have to shell out. Why you are being official on that? So there are such things, my friend. I have rounded off my thought, and I hope I can create 1,000 volunteers who can actually move in the direction educating politicians, policymakers. That is the dream. See, now, not to build big enterprise. I did not have any dream to build any enterprise. Yeah? Yes, sir, that we have to go away now. I will have to catch a flight, don't worry. It's okay? All the best. So my best wishes to SRM. And I must say, thanks to, I don't see Kamlakar Babu here. Thanks to him that I'm here. He made a personal call. He said, Professor, we want your thought process here. Please come. Thank you. Thank you, all of you. Thanks to the institution. And thanks to the audience for being so sporting. and throughout being here, and always to sit through the last day is even more tougher. Thank you.
Thank you, sir, for sharing your insights with us. Now I request Dr. Parthasarathi Maram, Associate Professor, Department of Chemistry, Convener of the Green Hydrogen Summit 2025, to kindly take over from here, sir.
So hello everyone. Now, after 2 days of summit, we have made a history at SRM AP. A lot of discussions, deliberations, suggestions, targets. All those things is the outcome of this summit, which is what we have expected when we started this, and we are very happy. We are in that line, and now I am. Actually, we came to the most important part of the summit, is a valedictory. Now I will call dignitaries on this dais. Professor C.H. Satish Kumar, Pro Vice Chancellor, SRM University AP. Professor D. Narayana Rao, Executive Research Director, SRM Group of Institutes. Dr. Sujit Pillai from MNRE. And Mr. Andres Kuman is a venture capitalist. And Dr. Sujit Kalluri, co-convener, Green Hydrogen Summit. Thank you, sir. Now I request Professor C.H. Satish Kumar to give the valedictory address.
Good afternoon, everyone. All dignitaries on and off the dais. It's a privilege to talk to you. I'll make it very short. Whenever we do the summit, we always see only academicians and researchers coming here. First time, I think, in the recent past, I have seen that all the three stakeholders, government, industry, and academia, all are on the same platform. I think it's based on our deliberations and discussions on and off the room. I've seen that summit is one of the wonderful success stories of SRM. But this summit doesn't stop here. SRM has been given a very important responsibility to take it further about this hydrogen issue. And I am from an area of not this hydrogen, but I am the other area called public health. People are talking about, the summit talked about that, what are the difficulties in producing, how to reach that goal. But I am from that area, which you don't do, what is going to happen? That means I'm worried about that particulate matter 2.5 and 5, 10, and these are the problems, what happens to the human community, humans actually. I think, I don't know how many of you know that these things will create premature death, lung problems, immunity problems, so on. Very surprising to tell you that our yesterday's chief guest, our Saraswat Saab, he himself is victim of that. He was continuously on using that Allegra or Cetirizine and so on actually. That means this is the race stage we all of us will reach of if we don't do this, and you'll have a problem for the humanity. And this is very important because when another important part I want to talk about that, we have seen the three stakeholders. One important stakeholder we missed, that is community. Because we never know that we had so many hydrogen buses, hydrogen things are happening, but we never seen that what community felt about it. All these things we are doing for the community, I think next time, I think as an SRM, we will take up from the public health side. We'll talk to the community. What are their knowledge? What are their perceptions? What are their experience? What are their expectations? I think whole this industry should move and around those expectations, those needs, and those requirements. I think people are talking about the rate of the hydrogen, but it's 300, 200. But we don't know whether what community wants. Like we never know mobile. Now everybody is talking about Apple mobile of 1 lakh rupees, even whether you can afford or not afford. So because it's all because convenience. I think it is if you have the cost doesn't matter, then it is creating a problem for your health. Because as a public health person, we have seen that people spend lakhs and lakhs of rupees on health issues to get rid of that. So in this scenario, whether cost makes a difference, of course, it makes a difference, but affordability is important. But at the same time, we do not know what community's expectations. I think next time when we do talk about that, next year, Dr. Chandrababu Naidu sir was telling about that, we'll be doing this summit next year. I think next year, by the end of, I think when we come back, I think we will come back with the community perceptions and community expectations, community needs also. And we'll stand here and talk and discuss, and then we'll come out with another important dimension of the whole aspect actually. Thank you very much for all of you to come here. And SRM is committed. We are starting the Center of Excellence for it. And we are bringing the topmost scientists here to work on that, along with the industry and the policymakers, and take it forward. I think with this assurance, I want to stop here. Thank you. And once again, thanking everyone from the core of our hearts of SRM University. Thank you.
Thank you, sir. Actually, we are very happy that you brought that one missing point, that is community, who is the end users or applications, and what are all people or what are all communities expecting from the hydrogen. That is a point which we will include for sure in the next summit, sir. Thank you. Now I ask Dr. Sujit Pillai from MNRE to say a few words.
So, respected dignitaries on the dais, SRM University Pro Vice Chancellor, Dean, I think Professor Narayana Rao, and I do not recall the name of our foreign guest, but and Dr. Sujit Belluri. It has been a great opportunity and experience to visit SRM University and see the work that is going on here, as well as attend the conference here today and yesterday. I would like to assure everybody that green hydrogen is here to stay. And of course, now that you have mentioned the community aspects, I think one aspect is that even on my recent trip to Chile, I would like to sort of emphasize what happened there. There, they actually had a wind turbine plant. So they had a sustainable aviation fuel plant, which was produced from green hydrogen and direct air capture of carbon dioxide. So there they had wind turbines, about a 3.4 megawatt wind turbine, the pilot plant in one of the southernmost cities in the world, 52 degrees south latitude. So I visited that plant weeks ago. And they actually had, from the point of view of their community, an actual radar type of system in their complex, just to, prevent birds from getting injured by the wind turbine. So they had an artificial intelligence system, so which they had to specially install because the community said that birds have to be protected. That community is very important. We must, involve the community and see that. But in most cases, given enough precautions and given enough thing, hydrogen is acceptable to most communities, as the World Bank has also and other organizations have found is given enough safeguards and because hydrogen is after all something where the safety is also a small issue. So I feel that hydrogen from an economic perspective, no issue at all, because India has one of the lowest costs of solar energy and all that. But from the point of view of safety, I just like to mention that the government has taken some big initiatives in safety. For example, we have set up a center called National Center for Hydrogen Safety, which is headquartered at NICE, National Institute of Solar Energy. So in that institute, we have setting up, for example, various verticals in safety research, regulations, codes, and standards, and so on. Because it's very important for hydrogen being a controlled substance that safety and regulations, code standards play a major role. So these aspects the government is also looking, and you will hear more to come in the days. I cannot reveal what right now we are doing, but we are rest assured the government is working in a big way on hydrogen safety regulations, codes, and standards. And we have over the last year, it was very heartening to note that the hydrogen is now being considered for civil aviation also. So over the last year, for the next phase of our mission, we have set up a committee on hydrogen in civil aviation, hydrogen in railways, as well as hydrogen in shipping. So these are some of the initiatives we have taken, and I can only reassure you that hydrogen is here to stay, and the exciting thing about hydrogen is zero emissions. So, in fact, the UK's Department of Energy is called, just to give you an example of how other countries are pushing it, it's called Department of Net Zero. So it's called Department of Net Zero and the energy and net zero. So that zero emissions, going to zero emissions vehicle is a big goal today that we should all aspire to. So there's some of the initiatives that are being followed in other countries. And I would also like to say that in India, we are today pushing for hydrogen in a big way because of the pollution levels that today we have. Is also major. So I thank again the organizers, SRM University and all, for their support. And when we meet here next year, you will see, I'm sure, the results from all our R&D projects that we have awarded, the testing projects that we have awarded, and so on. And we also, I just want to make an announcement from this forum that we are organizing an MNRE R&D conference in the coming week. I will invite the SRM University R&D people also for that. And in that conference, we are going to have various discussions. It will be a 2-day conference. And there will be various discussions on like frontiers of hydrogen. There will be fireside chats. We will have round tables on what should be the R&D priorities for hydrogen. That is also the organized. So that we have our first set of R&D projects in under our belt. Now we can, the second call, Center of Excellence will also be announced very shortly. Thank you.
Thank you, sir. So on a lighter note, now you have seen all our green hydrogen challenges and the work which we need to do in the future. So we request you release more funds from MNRE from now on. Now I ask Mr. Andres Kuman, please say a few words about the summit.
Yep, so I won't speak as long as the other gentlemen. This is quite a surprise for me, but I think it's an absolute honor for me to be able to just say thank you very much for everybody for the opportunity to attend. As it was said, I represent a group of venture capitalists, and we're looking to invest in India, and we have a lot of backers behind us that are looking at ways to invest. One of the ways being biogas, the other one being e-waste, and then we're looking at some technology campuses as well that we want to do. So for me, it was really a start of a journey. We've been on this path for quite a while, and we're only getting into biogas. And so the first group of people that I would like to thank is really the government of Andhra Pradesh. The way that the ministers have made themselves available to speak to us, the way that they have been willing to listen to us. And when I say listen, I really mean listen to us. What I have found is when I've been speaking to them, they listen with open ears. It's not just a formality. They want to understand what we want out of it as venture capitalists and how we can help India on this path. So that's the first group of people. The second group, we engaged with NREDCap, and I would like to thank Mr. Kamalakar. Once we engaged with them, he then referred us and suggested that we should attend this seminar. And he extended an invitation, which made it possible for us to actually get through the border and come in and attend. And so, you know, for me, I'd like to say thank you very much. We've come in from a biogas perspective and not from a hydrogen perspective. And so he's opened our eyes up to the opportunities. We've always thought of the opportunity to generate hydrogen as a kind of a future state for our biogas plants. We're starting to build our first plant this year, and we'll be rapidly expanding that to 4 plants within the next 5 years. What we'd be looking to do following this seminar is to actually bring forward the conversion of those plants to hydrogen plants, so as we can work with people like Professor, unfortunately I can't pronounce her surname, but with the university, look at the technologies that are available out there, work with the government to look at how do we get proof of concept stood up, how do we work in the kind of the niche market of hydrogen production. Most of the talk, and that's what I mentioned to the Chief Minister as well, is that when I look at the mission statement's very much focused upon the electrolytic conversion and the way that we do hydrogen generation through electrolysis. You know, we being from a biogas perspective, we'd like to see those sort of policies change a bit so as we can enable universities and other technology providers to actually start looking at how do we generate hydrogen out of biomass. Then I would also like to thank Professor Narayana for his hospitality, for giving us access here, and then together with Professor, all of the support staff that's also been here. It's been absolutely wonderful for me to sit here and have my questions answered. It was phenomenal how, you know, I would be thinking, how do we change the policies around it? And then there would be a presentation on policies. Then we had the fairly controversial session around financing. How do we do financing? And that gets answered. Technologies. It's been really enlightening for me. It's been a really wonderful experience for me. And the energy and the happiness and the willingness of everybody to actually just go down this path has been really, really great. So thank you very much.
Thank you, sir, for attending the summit. Now I ask from the audience, if anybody wants to share a few words about the summit. Professor Upadhyaya ma'am, you want to say something? You can come on there.
Once again, I'm here to congratulate SRM, the organizers, for this excellent summit on hydrogen, and of course, bringing me to my motherland once again, yeah. And the takeaways from this summit are very, very important to every person who has attended this, from every walk of life. Being an academician, you know, be it a entrepreneur, be it a venture capitalist, be it a, you know, what the government machine, I mean, person from a government machinery. So everybody, the policy makers, you know, the ministries, So I'm sure all these takeaways will culminate into a very good hydrogen, this thing for us, right from the mobility sector to the industries to the aviation. I'm sure, as our Chief Minister, beloved Chief Minister of Andhra Pradesh has put in, by next year, definitely this summit would actually, which has triggered a direction for the hydrogen economy in the state, would see some results. And next summit would be actually based on the results of what has happened for the past 1 year. Thank you very much.
Thank you, ma'am. It was an excellent outcome which we didn't expect through the summit. Now I ask our Professor Bharati Raja.
Good afternoon to all. I'm very happy that being a part of this hydrogen summit. Basically, I'm from SRM University, Kodanakoltur campus. First of all, I would like to thank Dr. Narendra sir. Almost 1 year before when we had written the proposal to MNRE, sir told that whether we are getting a project or not, but we have to take it forward, some kind of the discussion, and we want to also be a part of this hydrogen journey in the India. So of course this hydrogen summit, I believe there are different stakeholders, as ma'am said. Basically, I am working in electrical vehicle. Even I do get afraid now whether my battery vehicle will be sustained after 10 years or not. So because there are a lot of scopes in hydrogen, of course, there are people working in, according to my knowledge, Maruti Suzuki working in hydrogen gel, something the technology is said to come. So I believe there are a lot of students are actually participated. Even from our campus, we are about 15 people who are working in hydrogen. We are participated, and it's totally, being an electrical engineer, I didn't know much on this generation side and as well as storage side, and of course we also don't much on that what government as an Indian government and MNRE the promotions and activities doing on with respect to this hydrogen mission journey. So thank you SRM AP for creating this. Maybe this is the first in country, I guess. It started in a private forum. So I wish this summit has to be continue in the upcoming year as well. Also, thanks for the entire team crew, right from the day one. Till now they are hospitality and rest of the things. Everything is so good. I hope everybody enjoying this campus for the past 3 days. Thank you for everyone, and thank you, sir. Thank you so much.
Thank you, Professor. Now I call Professor D. Narayan Rao, who is the actually author of this entire summit. It started, as everybody said earlier, 8 months ago. But as a faculty with a different teaching load, research load, we may sometimes fade away with the idea, but he always bring us into the line and then push us to do whatever is supposed to be the, this is what at the end we have seen how successful it is. So I want to listen from his words how and deliver the vote of thanks.
The Pro Vice Chancellor of SRM University AP, Professor Satish Kumar, Dr. Sujit Pillai from National Hydrogen Mission of MNRE, Government of India, Dr. Andrew Schumann, conveners, Dr. Parsardi Maram, Dr. Sujit Kalluri, Dr. Kamalakar Babu, members from our partnering institutions for the summit, SRM IST Chennai, IIT Tirupati, ISER Tirupati, all members of the organizing committee of the Hydrogen Summit 2025, the distinguished delegates, participants, and students. We are very glad that Hydrogen Summit 25 could attract the industrialists, venture capitalists, entrepreneurs, startups, faculty members, scientists, and especially the leading industrialists onto the platform of Hydrogen Summit 2025. As Prof. Satish Kumar mentioned, generally these conferences, summits will happen with academicians and researchers. The unique feature and salient feature of this summit is the summit could attract the industrialists as well. Our organizing committee could attract all the stakeholders, and let us profusely congratulate all members of the SRM University team who have been associated with the Hydrogen Summit, starting from Professor Satish Kumar. Give a thundering applause. Okay, as the government of India launched a national hydrogen mission, a few states have come forward to set the targets for themselves. The state of Andhra Pradesh has set a target of producing 1.5 million metric tons of green hydrogen by 2030. With such vision and targets, the Honorable Chief Minister of Andhra Pradesh, Sri Nara Chandrababu Naidu, inaugurated the Hydrogen Summit. As I said yesterday, as a people's leader, he is greatly attracted by technology and the promise it holds for economic development of the state. With such targets and intentions in mind, the Honorable Chief Minister interacted with some of the industrialists. Andrew was there, quite a few. And he encouraged and motivated them to come to AP, invest, and produce green hydrogen for the societal and industrial applications. I consider that as a grand success. Generally, in the summit, such discussions may not be a part of it. Our organizing committee has made it, and it was a success. As the Honorable Chief Minister said, yesterday was a historic day for Andhra Pradesh of organizing the Green Hydrogen Summit. He instantaneously and immediately announced that the government of Andhra Pradesh will give Amaravati Green Hydrogen Valley Declaration. Some of us worked yesterday night and today. The GO will be issued perhaps on Monday, declaring Amaravati Hydrogen Valley. This is a big outcome of the summit. The declaration has several components of bringing industry and academia together, just not on the paper, to work together. And he said, every year I will review the progress. Also, I have seen in the last 2 days, several networkings and collaborations are happening between industries and research laboratories. And also, we could see the expertise available in the country in the arena of green hydrogen. For example, Dr. Vijay of ARCI presented their progress in developing of electrolyzers and fuel cells. Likewise, so we are very happy that this summit could provide a platform and an opportunity for networkings. Many industries also want to collaborate with SRM University AP. We welcome that. I am a very hard taskmaster, whether you like it or not. I never like MOUs on the paper. They have to be implemented and we will make it happen. So the takeaway or outcomes of this summit are highly appreciable as collaborations are happening, networks will happen, and the government is very supportive. And also, I don't know whether I'm permitted to announce or not, we are formulating Andhra Pradesh Green Hydrogen Association. We welcome all of you to join as members of Andhra Pradesh Green Hydrogen Association. Whether you are in Michigan or Delhi or Tirupati or Bhopal, it doesn't matter. We offer our welcome to all of you to be members of this association, and will take forward the journey of green hydrogen as suggested by the Honorable Chief Minister of Andhra Pradesh and as envisioned by the Government of India through National Hydrogen Mission. Thank you very much.
Thank you, sir. We will take a small break from the speeches. So we want to show our gratitude to of people who are present here. Of course, there are many people behind this summit. So we want to show a little gratitude to our few directors who are present here. First, I will call our Campus Life Director, Anup, on the stage. And I request our Pro Vice Chancellor, Professor Satish Kumar, to felicitate our CLM Director.
Thank you very much. And it is just a support from my entire team. Thank you, my team. Thank you.
Thank you, Anupji. You are actually in a arrangements committee, but you are part of every committee.
Yes.
You are part of
Thank
every
you.
committee.
Thank you, Pada, for your support. Thank you. No, there is no scope of no, sir. Thank you. Thank you.
Now I request our communication director, Dr. Pankaj. So our all the organizing committees and the directors are very well trained in doing these kind of programs. Whatever you see the creatives for speakers, everybody without even instructions from the program committee, they have made themselves and then gave to the IT department. And it is like very proactiveness, every banners, creatives, everything, whatever we request, they'll come in minutes. So, there is an instance like we gave invitations for print and the 15 minutes it is ready, almost 700 invitations. And now I call, now I request Mr. Roy, ITKM Director. So Mr. Roy is representing ITKM department, which is actually is a large presence in conducting these events. Even at any given point of time, now you can count in the auditorium, there are like maybe 10 to 15 people who are sitting and waiting for an opportunity to repair something. but incidentally, we didn't give any work to them. But they are like that supportive. And the kind of audio and visual, everything, quality, everything came from them. And thank you, sir. So sometimes if you are really happy and wants to say something about them, sometimes, it is difficult to get words. Now I am in that situation for these directors to say some. They excellently helped us, supported us the entire event. Okay. Now I am requesting Dr. Sujit Kalluri, who is the convener of our summit, to give a vote of thanks.
Yes, good afternoon, dignitaries on the dais. So actually, it is a very tough task for me to give vote of thanks. Yes, I should not miss anyone. And I would say, firstly, please pardon me if I miss anyone. It is not mean so. Firstly, I profusely thank the magnanimous support from our SRM management, our beloved Pro-Chancellor, Dr. P. Satyanarayanan, and Professor D. Narayan Rao, who is Executive Director Research, SRM Group of Institutions. He is the man behind the show. We are just executing. So he is the one who frames everything, and we are the people who execute. And we thank functionaries at SRM University, Vice Chancellor, Pro Vice Chancellor, Professor C.S. Satish Kumar, Registrar, and other dignitaries. And from our co-organizers, this event is being run in association with NREDCAP, that is a New and Renewable Energy Development Corporation of Andhra Pradesh, under the leadership of Vice Chairman and Managing Director Dr. M. Kamalakar Babu Garu and team, and other co-organizers, SRM, IST, IIT Tirupati, ISER Tirupati, and MNRE. And at most important, we thank our industry sponsors and government agencies, MNRE, CSIR, KP Group, ACME, Synergen Green, AM Green, Green Co, Everin Energy, NTPC, BPCL, AMNA Limited, Hydrogen Association of India, and other industry partners from India and abroad. And the most importantly, we thank resource persons from industry, academia for these keynote sessions, plenary sessions, and conclave discussions. And we also thank our organizing team led by our Pro Vice Chancellor, Sir, Professor C.H. Satish Kumar. And I read out the organizing committee, the inauguration committee led by Dr. K.A. Sunita and other faculty members. I name each and everyone. And the program committee led by Professor Vinod Kumar. And thank you for the excellent anchoring by Dr. Ayesha. And the registration committee led by Dr. Mahesh Kumar Rava. And thank you for the support extended by Dr. Ravi Teja and other faculty members. And the transportation committee led by Dr. E. Murali Krishna and Dr. A. Satish and others. And accommodation committee led by Dr. S. Gangireddy. And thank you for the support extended by Dr. Bhagat Singh, who is Chief Warden in providing accommodation and Student Affairs Department. And the hospitality committee led by Dr. Kaushik Das, who has done a tremendous job in feeding all of us during these 2 days. And the reception committee led by Dr. Sabjasatji Mukhopadhyay and Dr. E. Karthikeyan and others. And the students participation committee led by Ms. Ravati Balakrishnan and Mr. Pradeep from admissions department. And the most important, obviously, the finance committee led by Professor D. Narayan Rao, Professor Dr. M. Kamalakar Babu, and Ms. N. Suma, who is CFAO of SRM University AP. And the conference committee led by
Dr. Anil K. Suresh and the team, the publicity committee, which is very, very important, and led by Mr. Pankaj, Director Communications, and Ms. Arindhati Ganwar, and Mr. Shyam, and others. And thank you for the excellent photographs, which are going to be our memory by Mr. Hamant Kumar and team. And of course, there is a tremendous support from Mr. Venugopal, Media Coordinator, and Mr. Ramesh Kumar, Chief Liaison Officer. And Invitation Committee led by Professor Kiran and others, thank you very much for your support. And the Technology Committee led by Mr. Roy, Director ITKM, and his team. And the Hall Management Committee led by Dr. A. Lakshman Rao and his team. Mementos Committee led by Dr. Satish Elipalli and his team, who has traveled 12 hours in a day for bringing those wonderful mementos. And most importantly, I profusely thank the student volunteers who have worked for this event, including research scholars. And once again, I specially thank the directorates of CLM, including Chief Security Officer, housekeeping staff, Mr. Chandra Prabhu, and all who have done an excellent job in arranging us all the infrastructure facilities. And once again, I thank ITKM department for this support throughout the event, and the publicity by communications department is very thankful. And most important, I thank print and electronic media for covering this event, and thank you very much for your support, and hope the participants got enough from this two-day event. And I thank you very much for your patience over the two days. And if there are any issues from our end, and sincere apologies. And thank you very much for your kind support given by our management and others. Thank you.
So one last thing, my co-convener, Dr. Sujit Kaluri, last 1 week, I would say maybe he might have seen 18 hours screen. So that's very, very, I usually kind of a person goes, talks to people and then do something, but he always sits with Rao sir and whatever corresponding, whatever prints, emails, everything. I can see only yesterday night during the banquet, I have seen smile in his face. Last 4 days, 5 days, even I have not very serious about work, very calm. Sometimes I may. So definitely, Dr. Sujit Kaluri is a kind of person who definitely forms a good team with the people. And if he is there, even I can do even maybe 10 events next 1 year. That is the confidence I have with my co-convener. Thank you. Thank you very much. And all good things should come to an end. I would say now, I want to say everyone bye for now. And we have actually arranged tea and snacks at the outside. Please have them. And I wish you have a safe journey. And we want to see you again in SRM University. When you come again, we will have a lot of developments to show you. Thank you very much.